Good morning, everyone, and welcome to the 2023 Pacific Northwest Regional. We have a wonderful contest starting in 12 minutes here. This is the Pacific Northwest Regional for the 2023 contest. I know it's 2024, but things have been delayed since COVID. There's been a recurring pushback. Each contest can't run until the previous one finishes, but it should be almost caught up. Maybe next year, the 2024 regionals will happen in that year. We'll see in just a minute, and we have the contest floor here. We're in the beautiful and wonderful De Anza, California. Very pretty university. A little loud here. And hopefully we should have a nice contest. You can see the scoreboard, the contest here, with all of the organizers and the participants slowly filtering in. We just had opening ceremonies, and we'll start in a minute. So I'm going to do a quick tech check to make sure everything's working, and I'll be back in about 5 minutes or so.
It doesn't matter. Just make sure it's upside down. I don't think so.
No,
I think it's just.
They have an awful lot of problems with that.
If there's any, they're not using these machines, I don't think. I don't know.
Where is
We do have a mirror, yeah. Let's get that in chat probably, huh?
John Buck?
I'll try and open one.
Sure, they're under the keyboard. Under the keyboard. No. Under the keyboard.
We'll be starting in just a minute here. Should be a fun contest.
Where are you?
I'm trying to. Here.
I think we need to be prepared to.
I know.
All right, for those of you who are just joining, welcome. This is the Pacific Northwest Regional. We're here in De Anza, but there are 5 different locations spanning Washington, California, Hawaii, and some others as well. All available on the Code Forces post, of course. We have the contest starting in about 10 minutes. I guess about 8 minutes, more formally. Everything seems to be on track, although it's a little loud, isn't it? Yeah, but we'll be keeping track of what's going on then. And in the meantime, we'll take a look at the rules here, the problems, and I guess not the problems. Problems are top secret until then. The problems and the way the rest of this contest works. So let's I guess take a look at the contest that we have going on here. You can see our chief judge in running shorts in the front of the frame here. Nick Wu, or Zhao CF or something. his Code Forces handle comes from the word cone. It's interesting. C1 something. But yeah, this event is sponsored by De Anza, or hosted by De Anza. They're a 2-year college. They competed in North American Championships, and they're a very, very fun college to take a look at. Beautiful campus, lots of stone and brick and stuff, and wonderful weather, as you would expect in the Southern California area. A lot of their contestants are here today. They're not quite on the contest floor. It looks like there are some security measures in place, making sure
Did you find it, Renee?
nothing gets leaked. Obviously, these are very secure problems.
403, 405, 460.
And apparently, we have a pencil sharpener right by our camera. Learn something new every day, right? We have, I believe, around 140 teams competing today in several different locations. I think 70 teams are competing in this location, so this is the largest of them. Okay, that's a little loud. Little loud, isn't it? We'll stick to this. So we have about 70 teams competing today. During the stream, we'll have some visitors, including Lydia, who's commentating the Mid-Central, I think, regional, and also Geothermal, who's commentating the Big South, which is a series of regionals, but they're all competing in the same contest. So it's essentially just one contest. Also, some coaches from the teams here, at least one, will be joining the stream in person. So look forward to that, and should be a fun time. If you have any questions or anything that's happening in the other streams we should take a look at, feel free to let me know in chat. I have it open and we'll be paying attention. But for now, it's a hurry up and wait game. 5 minutes left. Excited to see what happens. Without further ado, here's the contest.
Let me DM you the credentials now.
All right, I have gotten some news here. I have heard from the judges who are next door, literally across this door, that the start is being delayed by 10 minutes. So this is going to be a 10:10 start. Should be fun. This is why we don't start early. Start the stream early, because you know you always have extra time when it comes to complex events dealing with hundreds of people across 5 sites. So I don't know if this means other regionals will also be delayed, but it might. Yeah, we'll see. But it's exciting. Yeah, as you can see from the fact that this is the contest floor, teams aren't even at their desks, and we are planned to start in 1 minute, but I don't think we will. The real question is, will the mirror get delayed by 10 minutes as well? Because there's supposed to be an open mirror with contests getting released in 5 minutes, but we don't know if that'll happen. I'm sure the judges are furiously trying to figure that out at the moment. But at the moment, it's also out of our hands. All we can do is wait for the pencils to be sharpened.
Who has 470?
Here is 470.
470?
No, 17. 462 over here.
Mary, do you have 462?
462 I have. Okay.
Mary, have it, please. Hey, I want everybody to go to the desk that does not have a password and call out the password. 472. 472. You got 472? 464.
473.
Who's got all these?
I have 463. I have 464.
464. 464 who's here?
473.
Who's got the rest of them?
417.
This was that low. 463. Do you see 463?
Oh, wait a minute. Somebody's not putting up, I just found a password sheet sitting here. It needs to be under the keyboard. Let's just get it upside down.
Does anybody see 463 hanging around? 469. Who has 469?
Check to see if it's not under the problem set.
Who has a 63? No, I have 63 over there.
460.
No.
Yes.
So
Yeah.
426.
We got the lady right at the left.
463.
This is the audio roll.
Yeah. I'm all out.
Yeah, I mean, even if we said no, it still would have been a problem.
They should be all back out.
No, we're not. She's got two and we're missing. Oh, she's holding a bunch.
I need 68, 69.
Okay. 469 and 468.
We're all out. 468?
468, that's what I think.
468.
Most of them do, I think. The rumor was that most of them.
468 is at 240. Got it.
Take it. Are we still, do we have sheets? Do we have password sheets left?
We're all out.
I think they're all out. Okay? Okay?
We're done.
Can we have somebody double check that?
I did.
I've just been walking.
On this side, everything is there. I haven't checked the other.
Ready to go.
I think we're ready, right? Yes. Manish?
Yeah.
Manish? I think we're ready.
I just still need to check 204 yet. Give me just 2 minutes. I'll walk around and check every other station.
Yeah, well, we'll talk about this in post-mortem.
2 minutes late.
Good enough?
I believe that everything is out.
Let it in.
Manish? Manish? Yes. Okay, we're targeting starting in seconds.
All right, so you can see teams are filtering in here. I think we have all of them out in the hallway and they're moving in to their seats where the problems have been distributed.
I'll definitely have to go.
Other contests have started. So we have multiple regionals happening simultaneously today. Right now, yeah, all the teams have been briefed about what the contest is, and they know. Man, okay, we're gonna turn this down for a minute. They know basically what the rules of the contest are, who the sponsors are, stuff like that. Their goal right now is to find and solve the easiest problems, but they can't read the problems till the contest starts, and that should happen in around 6 more minutes. So we don't know quite yet when that's gonna happen. The plan is for 11:10, but obviously we have 5 different locations here. They all need to be synced up, and we finished, I guess, the introductory ceremonies a little later than we had expected. But yeah, the interesting thing here is that there are lots of submissions happening for other contests, and a lot of these problems are shared. So hopefully this doesn't cause any security issues, but the contestants are sequestered. I believe they have had all of their phones taken away. So they shouldn't have any internet access other than access to the page that runs the contest scoreboard. Yeah, here you go. You see lots of people in here all of a sudden. And it looks like it's a race to see if we can get everyone seated and going before the contest starts.
You are not allowed to touch anything. Not log in. Not grab your problem set. We went over this. Somebody's already logged in. Team 478. What are you doing? Got a briefing. Right? Not start until we have to go ahead.
You don't have any phone, then what's on you, right?
Thank you, appreciate it. Yeah, contestants are not allowed any electronic outside materials. So no flash drives, no floppy disks. The only thing they're allowed to use are printed materials in a certain specified limit. I think it's like 2 inches by 12 inches by 12 inches. So you can bring, you know, a reasonable amount of paper, but you can't bring an encyclopedia. And obviously, if you need to bring an encyclopedia, it's not particularly helpful. So you're bringing these to your desk. You can use them if you'd like. And yeah, that means no ChatGPT because you don't have access to the internet. It means no looking stuff up on, you know, Code Forces or Geeks for Geeks or anything like that. So pretty much it is just you and your brain and your team, I guess.
People with badge, please give it to your coach so that they can be kept outside.
I'm gonna go check with the judges to see how our scoreboard status will work, and I'll be back. Ah, here we go.
5, 4, 3, 2, 1, go!
And the contest is underway. It says it's a 10-minute start time, but I think this will be updated, and they'll change it to 0 minutes in, I imagine. But we'll see. Regardless, we have just started the contest. These teams are furiously looking for through the problems to see what the easiest one is. The way the contest works, you've got a series of I guess, M problems. So what is that? 3, 6, 9, 12, 13 problems total. You want to solve as many as possible and do so as quickly as possible. The faster you solve them, the fewer penalty points you'll get, which is this third row, or as fourth row if you count the number here. And yeah, better penalty is a lower number. You get penalty points by getting incorrect submissions or by taking longer to solve a problem. So if you solve one problem 10 minutes into contest, that'll give you 10 penalty points, and you'll get 1 point for this in this sum column for the number of problems you've gotten correct. Obviously, solving more problems is better, so it doesn't matter how long it takes you or how many incorrect submissions it takes to solve a problem. If you're able to solve one more problem than you were before, that is an advantage on the scoreboard. It looks like our teams have begun. We should see the queue for both Div 1 and Div 2 happening here. Of note, these contests do share quite a few problems,
Raise your hand, please.
but not all of them are shared. So there are some problems unique to Div 1. Div 1 is in general harder, but Div 1 is also the only way to qualify for the ICPC North American Championships, which will be held in Orlando, Florida later this year. It's a very strong regional. I should mention it's also a very large regional compared to others. There are, I believe, 140 some teams here. There are 70 teams at this location, so over 200 people competing here at this location. And this is one of the largest regionals in the country. It also has Berkeley, Stanford, University of Washington, UC Davis, De Anza University, where we are right now, and teams from all over the country, including California, of course, Washington, Oregon, and some parts of UBC is here as well. Pretty strong team from Canada, Hawaii. So lots of different universities across the Pacific Northwest. Some of them will be competing in Div 1. We also have Div 2 scoreboard here. And it looks like we are waiting for the first submit. All right, so the contest timer has been updated. We're officially 2 minutes into contest.
Look at the instruction sheet. Yeah.
For the username, please make sure that you put DAVDI in front of your team name. Read the instruction sheet properly.
Let's try to refresh this, see if we have a better time here. All right, we're still 13 minutes into contest. Should be fine. We can just subtract 2 minutes or whatever, huh?
Follow the direction.
We are still waiting for the first submission. You can see all the contestants here looking for which problem they think might be the easiest. We might also have the open problems available. I guess we don't quite have them, but we will soon. There will be a mirror. I've posted it in the link, and yeah, it should be available for other people to look at if that's something that they're interested in. I'm actually going to go see if I
If you're not
can
able to log in, please follow the directions. You have to put DAVDI / and then the team name.
check if we've actually started here, what the status is. So I'll be right back. All right, it looks like we have some submission. Doesn't appear to be showing up on our scoreboard though, which is interesting.
Well, no, like one time in 3 or 4 weeks. So that's what we see coming out upside down.
All right, I'm going to keep an eye here on our technical debugging, because I'm not sure why submissions aren't being shown, but they're not, and that's what we'll have to deal with. We have some questions here about who's allowed in Div 1 and Div 2. Any team can register for either division, but Div 2 is really mostly only for newer teams who are interested in the idea of like ICPC, but don't think they stand a good chance at competing in North American Championships or don't want to qualify for World Finals, because they're newer and their goal is just have more experience in the space. So if you do compete in Div 2, you're not eligible to qualify for the
For
North
people
American
complaining that
Championships,
they can't find the compilers, click on the applications menu and then click on whichever program
which
you
are
want.
held in Orlando, Florida later this year. So we would encourage teams to participate in Div 1. Even if it's a bit harder, there's a chance that you'll do well. I think you need to place in the top 10, and you also need to be the first in your school, or at least first among the top 10 schools in the region. Yeah, I guess we'll see if there's another way we can find the scoreboard if this one's not gonna work for us. All right, well, we've got this. So yeah, I guess we can take a look at the scoreboard here. So we have Conqueror of Pacific Northwest. In Div 1, they've got A, L, and M in first place. First team to solve A, and also getting L and M in about 2 minutes apiece. We have another team related to this. Oh, I guess this is an open division, so this doesn't mean anything. I wonder if this is Conqueror of Tourist. Yeah, so I guess we'll pause here. We got Constantine, coach from Stanford, who's participating. But I hear we do have submissions from Div 1 that are AC. So I don't know. I'll try and find those. Then we can take a look at them. All right. We have finally gotten access to the scoreboard. Here's what it looks like. So this is the Div 1 scoreboard. And looks like Stanford Cardinals, first place from Stanford with L and M. 2 problems. It looks like A is also solvable according to the open mirror. We'll take a look at these problems then, L and M, and see how solvable they are. M is 777s. The Div 1 problem, it's probably also in Div 2 if it's this easy, but we'll take a look. Eddie is overseeing the construction of new slot machines. And his slot machines have 3 wheels, each of which can show one of several digits. When activated, each wheel shows a random digit. The goal is for all wheels to be able to show a 7. Okay, a slot machine is good if each wheel is capable of showing a 7 and bad otherwise. For a given slot machine, determine if it's good or bad. So basically, for each of these, do they have a 7? So the number of digits on each wheel, oh, so 2, and then you have 3 lines of 2. Is there a 7 in each of them? Yeah. So this is indeed a 1-minute solve. We can maybe do it later if people would like to see the code. The problems are different from the South region, yeah. Is it still too small? I don't know. I don't know how much bigger we can get. Oh, we can hide this. There we go. Twice as big. Yeah, so that's problem is, I'd say, one of the easiest problems in the contest, not having seen the other ones. Looks like L, also from the open division. Seems quite easy. We'll take a look at this one. Ashley is training for a programming contest in Brandon's Online Judge. Brandon's Online Judge has a new feature which allows Ashley's coach, Tom, to load a list of problems for Ashley. I don't know why we have all these people involved, but we can go through it anyway. Tom has curated some problems for Ashley to work on. Each problem has 2 integers as a lower skill and upper skill bound. A programmer has an integer skill level. If someone with a skill level between lower and upper bounds inclusive and they solve the problem, then that will increase their skill level by 1. Okay, Ashley will train on Tom's curated list of problems as follows. She will look at the first problem in the list, either skip or solve it, and repeat this for every problem in the list in the order that Tom loaded the problems. Once she's skipped a problem, she can never go back to it. Compute the maximum skill level she can have if she chooses to solve or skip problems optimally. Okay, so let's look at an example here. So you have 0, 2, 0, 0, 1, 1, you start at 0. So your skill level goes from 0, 1, 2, 3. You have 0 to 0. You have 0 to 2. And I think it was 1 to 1. Yeah, 1 to 1. So the idea is you can pick a problem to work on, and you start initially at 0. So if you pick this one first, then this problem's too hard for you. Nothing happens. You don't get to solve it. But if you pick, let's say, the yellow problem is a very interesting problem, I guess. And if you pick that one, then your skill will increase from 0 to 1. Same thing if you pick the red problem. So the idea here is if you pick them optimally, you can pick red first, and then you can pick green, and then you can pick yellow. So there are probably a bunch of ways of doing this. One way is you can sort these by left endpoint, and then you can have a priority queue of right endpoints. And once you never want to work on a problem unless it's beneficial to you. So you're always going to work on problems that have been added to your priority queue of right endpoints. So you're going to start with just yellow and red. And the first thing you'll do is you'll work on the first problem that ends. So initially, if you're here, you have a priority queue. You have a priority queue that includes this red element and this yellow element. And you'll want to remove the first one. So you remove the red. Now you're in the yellow. Now you're at 1, right? So you add the green. So now you have this one and this, and you're at 1. You remove the green, remove the yellow. That'll give you an n log n solution. There might be a way of doing it faster, but intuitively it doesn't seem like that would be the case. Berkeley Ballers from UC Berkeley catching up to the open standings with an ACN A. That makes a dark green for them. It looks like that's their first dark green because they've been slower than Stanford Cardinal for both of the other two easy problems, L and M. This early into the contest, it's easy to get a good head start, especially if you get lucky with the problems you look at first. So there's always an interesting give and take about, is that something you want to do? Do you want to try and read the problems in a particularly interesting order, or do you want to read them in a very predictable order so that if there are other teams who are doing the same thing as you, you'll be able to beat them on skill? I've had different coaches in the past who have had different ideas about the optimal order to read problems in. Personally, I've always started at problem F. I don't know why, maybe just a habit. But yeah, I'm the F forward guy on my team. That's what I certainly was during my ICPC days, at least. There is a link to the scoreboard. Let me post it here for us. I think this is the real one, Constantine. Yeah, it is really small. We got a submit from Stanford Cardinal on K. Looks like it's incorrect. It's our first incorrect on K, but we have some other incorrects on C, and then also some wrong ones on L. If I had to guess on these, I'd say these are most likely TLEs. But it could also be like, it could just be a wrong answer, right? It could be that they couldn't do n squared, and then they tried just sorting them, or some greedy that doesn't quite work in every case. It's intuitive to want to do something like, sort them by increasing end time and then just do them in that order. But the problem is, right, the start times matter as well. So it seems like there are two different orders that you need to process them in, one for start time, one for end time. Yeah, I know this contest is, or this is a little small. Let's see what we can do about that. There might be a way for us to get, we have a really nice, there are a lot of people who put a lot of effort into this very nice scoreboard. But it doesn't appear to be working, unfortunately. Yeah, so we have this beautiful scoreboard, but it's we're not getting the actual submissions on it. All right, we can take a look at Div 2 though. So in Div 2, we got the Dream Demons in first place. And it looks like most of the ACs are in the first half of the Div 2 set. So one of the things the Chief Judge, Nick, mentioned here is that we have two halves of each set and one half is shared. So we have the first half of the Div 2 is its own set, basically. second half of div 2, I believe, matches the first half of div 1. Or might it match the first half or the second half of div 2? I'm not sure. Sorry, second half of div 1. But yeah, and it looks like A, B, and C in div 2 are the three most approachable problems, at least for the teams that are succeeding in them. Got another AC on B. So congratulations, congratulations there. Yeah, let's take a look at div 1. So we have two Berkeley teams, Berkeley Ballers and Return of the Sleepwalkers, both with problem A. I would imagine soon to be looking at K. So why don't we take a look at problem A ourselves? You do only get one computer per team. Exactly. Yeah, three team members, one computer, which means, as you can see here, yeah, in the contest floor, you have to decide how you use your terminal time wisely. You can't just, you know, dilly around on the computer if your teammates need it, because obviously they'll never be able to code if you spend all 5 hours coding. So debugging is an interesting thing to do. You can try and do it on the computer, but another thing that's very common, especially in these contests, is printing out your code and trying to look through it to find the bug on paper. It's possible the printer is one of the things that's so loud that we're hearing in this contest floor here. All right, so we have, for problem A, we have a string of A's, B's, and C's, and it contains the same count of each. It's beautiful if its length is divisible by 3, and the string, wait, it does contain the same count, so its length will always be divisible by 3. And if it can be split into contiguous substrings of size 3, where each substring has one of each in any order. So for example, this, but this one is not. Given a string, you want to partition it into subsequences, not necessarily contiguous, such that each subsequence is a beautiful string. For example, A, B, this one, you can do, oh, they don't have to be contiguous. Okay. They're partitioned into two subsequences, both of which are beautiful. For a given string, find the minimum number of subsequences you can partition it into such that each subsequence is beautiful. It can be proven there's always at least one way to do that that satisfies the constraints. The reason there's always at least one way to do that, in case that's not clear, where's my whiteboard here? So what you can always do if you have some string, right, A, let's just do this. Can we zoom in? Yeah. If we have something like this, you can always do ABC to take this one here, and this one here. And then you can do ABC again and ABC again. And this might not be ABC, right? It might be ACB or something. But you'll always be able to do something of this sort. You can always get each triplet as its own. So it's always possible to do this. Also, you can be somewhat greedy with this, I believe, because if you have an A followed by a B, right, and you see a C, you always want to put this C into this group. There's no reason not to. Similarly, if you have a B, the B is going to need to get matched with an A and a C, so you might as well just put the B with the first group that needs it, and then close out that group if it is the third letter. So I don't see why greedy here wouldn't work. But we can try this case here. So let's see, we have this. So we do A, B. All right, we see new A. This needs to be in a new group. C fits in the first group, and now this is effectively just an empty group now because it has its A, B, and C. That was the C. Now we have a B. Yeah, so this is an interesting case. Where do you put the B? Well, you're going to need a B in all three of these, so it doesn't matter, right? You just put it in the first group that doesn't have it. Now you have a C. Where do you put the C? I guess you can just do this. Shouldn't matter. Now you need an A, so you put it here. Now this is empty. And now you have an A again. So put it in the first group that needs it. C, first group that needs it. Another C. This group doesn't need it, so here. B, and then B. Yeah, so I guess this should be Should be sufficient. Can't imagine any concerns there. We've got the previous scoreboard from last year here. You can see Berkeley ended up winning on problems. They were able to get B and D and E, 3 particularly hard problems that ended up winning them the set. We'll see how the hard problems shake out this year, but it looks like so far people are pretty agreed on A, L, and M being the easiest 3 in Div 1. In Div 2, we have a nice scoreboard here. You can see the first half of the set, A through F, seem to be a little bit easier than the second half. And perhaps that's because the second half is shared between Div 1 and Div 2. We can actually check that real quick. So here are the Div 1 problems. They end in 777s in training. The Div 2 problems, they don't, but they do have 777s. So yeah, it looks like training in 777s. The second half of Div 1, it appears, is the first half of Div 2. Which kind of implies there will be a lot of easy problems in the end of Div 1, doesn't it? When you think about it. Because like they're not going to put, you know, an FFT simplex problem in a Div 2 contest. We can take a look at the open standings too. This will give us an idea of maybe what might be coming down the road here. And we see this team. Who's in it? Can we see? I guess some UBC folks. Perhaps Conqueror of Tourist. UBC, they have A, C, F, L, and M. So L, M, and A, these are all known to be solvable. But it looks like C and F are the new ones there. And we have similar results here. C and F have also been solved in our Div 1 standings. I guess at that point we might as well take a look at F. See how difficult it is. F in Div 1 though. Item selection, an interesting name. You're displaying a website that lists items for sale. The website has a paging UI that displays a fixed number of items per page, 1 page at a time. For example, if there are 55 items total, the page displays 20 at a time, and then there are 3 pages total, right? So 0 to 20, or 0 to 19, 20 to 39, and then 40 to 59. But we only have the 55. Oh, yeah, they tell us right here. All right, cool. Makes sense? So you may navigate and select items using these UI elements. A checkbox for every item on the page. After you click the checkbox, the selected item becomes unselected, and an unselected item becomes selected. Okay, so you can click a checkbox. I guess that just works how you'd expect. A select all button, a deselect all button, a next page. And these only affect the current page. Okay. And a previous page. You have pre-selected some items based on the machine learning recommendation algorithm. The recommendation may or not work for you. You want to know the exact items, or you know the exact items you wish to purchase, and they may differ in some way, so you want to get them. So what's the minimum number of checkbox and button clicks required to select exactly the ones you're interested in? People say Kaysen, but I don't. I'd be surprised if Kaysen's competing for UBC, right? Kaysen's from MIT. He is from Canada, but I don't know. I'd just be surprised to see him competing from UBC. Oh, maybe there are multiple teams. Let's take a look. Hang on.
Instructions at the bottom, it says to save your code in the sources folder, because if the machine crashes in between, you will lose the code that you may have already worked on. So please follow that diligently. Otherwise, you'll have to end up repeating the work. So
Looks like some technical announcements going on to the contestants here. Oh, yeah, I guess this could be Kason. The real Conqueror is on the second team. Conqueror of Pacific Northwest. Yeah. Okay, makes sense. How do you see this? Does it show you? Oh, it's just Kason. It's literally just Kason. Wow. So why is he in BC? Maybe, but not UBC. Is it just Conqueror? Yeah. Dylan, he's good. Okay, yeah, how do you do item selections? Let's see. So you have some items, you want to reach them. You can either select none and then go hit the ones you want, or you can select the difference. And it looks like all the pages are independent, right? You can't ever just go to the next page, or just go to like the next item. You have to go to the entire next page. So a greedy should work for this too, right? Because for each group of 20 items, right, like, yeah, every group seems independent. Select all, deselect all, next page, previous page, but there's no like next element. So you're gonna have to visit, oh, but you might be able to skip some pages, I guess. So it's a little implementation heavy, but basically just like for a given page, if you have to visit it, then you have to go there. And it's disabled on the first page, so you can't loop around. And that just means you know the last page you're gonna have to visit. So you're gonna have to press next page that many times. For each page you have to visit, your choices are you press deselect all, and then you click the ones you want. So it's the number of trues plus 1. You click select all, and then the ones you don't want, so the number of falses plus 1. Or the difference, so just like the number of ones that don't match what they are. Not plus 1, because you don't have to click the select or deselect all. So it's a little implementation heavy. Also reading all of this is a little annoying, right? You got 5 integers, you have to figure out what all these mean. But in the grand scheme of things, when you've solved all of the easier problems, it makes sense to jump into it. You can see we have 5 different regions here for this regional, or 5 different sites for this regional. British Columbia, Washington, Oregon, Hawaii, and California. California, I believe, is the biggest one. You can see we have quite a few teams. This is like 30 teams or so in Div 1, and then many more in Div 2. Yeah, here we go. Yeah, another, I don't even know how many this is. Looks like 30 or so Div 2 teams. So about 70 teams here today total. AC from, oh, this is Div 2. AC from Sierra, Dream Demons. Been in first for a while now. It looks like they're sticking to the first half of the problems. Second half will come later. I thought for a second no way this is right. No way. There's no way these are in the same order, right? Because, hang on a minute. So this is the Div 2 standings, right? A through F have been solved. That means E has been solved. What is problem E here? Training. Oh, maybe this is actually solvable. Wait, so this is an odd implication here. It looks like the Div 2 teams may be doing better than the Div 1 teams. If these 6 problems are shared, am I crazy here? Yeah, you can check on the team tab, but wait. What, how is this happening? hang on, folks. We got to look at these side by side because this doesn't make any sense. How are the Div 2 teams doing so incredibly well? Where are the problems? We have, So on the right, we have div 2. On the left, we have div 1. So we have ABC, acceptable seating. Oh, we don't have balance tree, so they don't match exactly.
All right, listen up. I need everyone's attention. You got to listen. This is really important. At the bottom of your password sheet, there's some instructions that say that you need to save your source code in the source folder. If you do not do that and you just have it in the root and your machine restarts for some reason, you will lose all your work. So make sure that you're saving things in the source folder. That's it. Thank you. Good luck.
Yeah, I gotta say, I'd be a little frustrated if I was a contestant and there were this many announcements going on in the middle of the contest. Because it's like you're deep in thought, right? You're reading a problem. It's already very stressful. You have teams talking around you. You have your teammates. You have to focus on what you're doing. And then now there's someone talking to a microphone at you about technical difficulties. It'd be very, very frustrating. But at the very least, it's fair, right? At least fair for everyone on the site. Okay. So I'm not sure if these are the same problem orders, but yeah, because these ones are sorted alphabetically, and then these ones have a jump in the div 2 problems. So it could be the first half of the div 2 problems are easier. I'm not quite sure. These are alphabetically sorted. Yeah, they are. So I'm not sure. I'm really not sure what's going on here, to be honest. So UBC has entered first place in div 1 with 5 problems, including an AC in dark green on problem H. Looks like C, F, H, and K are the approachable medium difficulty ones, with a pretty good curve so far. The real question is, what will the curve look like maybe another hour into contest? Is every team going to have C, F, H, K, L, M, A? Like, is that going to be everything? A, C, F, H, K, L, M? Or is one of these teams, like one of these solutions, something that was impressively hard? We saw earlier, wrong answer on K. I guess that was also from Stanford. So did they learn something from that wrong answer? What's going on? Looks like F also is deceptively hard, right? We have 2 or 3 teams now that have gotten it, but quite a few wrong answers as well, including Berkeley Ballers, who have been draining a good amount of time into this. They were doing very well in the beginning. We're winning for quite a bit there, but yeah, a little tricky. How's UBC doing? We got one team, Order 1, who has two ACs so far. Only one team from UBC? Yeah, I guess relatively small representation today in Div 1. Oh, I guess. Oh, it could be just British Columbia. Okay, never mind. Yeah, UBC is winning. So, well done to them. We'll take a look at problem H in just a minute. I'm going to go see if there's anything I can do to get the pretty scoreboard back and let you look at Div 2 while I'm gone.
Yes, it did.
All right, I'm back. We've got the contest underway. Let's take a look at, I guess, C, F, or H. Figure out which of them in Div 1 is most exciting. C, Candy Factory. That sounds fun. I just had a Snickers bar. So let's take a look. We have an ICPC, International Consortium of Popular Candies. That's a good acronym, if I do say so myself. All right, and this pencil sharpener or printer is honestly getting on my nerves. So we're muting them. Some popular candies hosting a prestigious candy festival for candy lovers worldwide. The consortium has asked N candy factories to produce candies, and each of the factories has some quantity of unique type of candy. So they have unique types for each factory, and then every factory has some quantity. Packs of candies will be given to the participants at the festival, and a candy pack must consist of exactly K candies of different types. Okay, so K factories are involved in one pack. 2 packs may contain different sets of K candies. Oh, interesting. Okay. There may be unavoidably some leftover candies, given the quantities of candies that the N factories have already produced. The ICPC does not want to waste any of the candies produced and is willing to create extra packs of candy to ensure this. They can order any of the N factories to produce additional candies, and what's the minimum number of additional candies that must be ordered such that there will be no leftovers after packing. So the only time you might have leftovers is if there are too many candies produced from the same factory. Exactly K, yeah. So if you have like one candy that's produced over half of them, for example, those will all be wasted. If you assume K is 2. If K is 3, if one candy is produced over 1/3, those will all be wasted. So you'll need to produce additional ones, and you can always find a factory that will do them to fill in those additional. I think that's only the case, or the only time you might have a problem is if there's that one. Otherwise, you can do some sort of like priority queue thing if you wanted to, but you don't actually have to do that. You can just reason that will never happen. So you just look at which factory is the biggest, and you see is that going to cause a problem. So you have 4 factories, and then K is 3. So this is the one that we're concerned with, right? 4, and then how many other ones are there? 3. So this adds up to 5. So in total, yeah, let's look at this. So in total, we have 9 in total, right? 9. Nine candies. 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So these 2 will be grouped with this. These 2 will be grouped with this. One of these will be grouped with this, and then we're going to need 1 here and then 2 more for this. So yeah, the logic for this problem, I believe, should be as simple as sort the input array, find the sum of everything, find the sum of these, and then see if the total number of things is at least k times the biggest. And if not, then you're going to need to add whatever that difference is to your answer. So that's your answer, right? The k times the biggest minus the number of things. Which is really concerning because that surely isn't right. But why not? Because like otherwise, why would bounds be so tiny? Does it have to do with the fact that k is really small? But like, you could always just keep everything small, right? If everything is close to the same. Oh, you have mod problems, don't you? If the total number of things modulo k is not 0, then you have an issue. You might not have much of an issue though, right? Because you can always just add a couple more. So my question for this is like, why are bounds so tiny that this would cause a problem? This is 3. We only have 1 sample, so we can't use samples at all to help us understand what's going on here. So we have some unavoidable leftover candies from the N factories. So 2 candy packs can contain different sets of candies. And a candy pack must contain exactly k candies, each of a different type. So why do bounds need to be so small? I would imagine they don't. I would imagine it's as simple as you need a multiple of k. And you need slightly more. But perhaps it's that part which is causing people to freak out. Maybe it's easy. I don't know. Look, we got, what, five submissions? Should I just do it real quick and see? Let's take a look at div 2. We can always come back here. All right, now we don't have a ticker for div 2. We have a visitor coming to join us. Always fun to see. Yeah, so well, with nothing else, I guess I just want to check if this solution idea is right. So might as well just jump into this. Let's make a candy distribution problem here. Make it nice and big so people can read what's going on. Almost. There you go, big enough. And we'll say, is this single test case or multi-test case? Just one. Welcome. Got a question for you here.
Whoa.
Do you want to pull up a chair?
Is there a trigger pull? I have a couple minutes.
Maybe. Okay, yeah.
I have a couple
Don't hit the
minutes.
power cord.
Sorry. I know you weren't expecting me to. show up.
welcome.
I see you found Candy Factory.
I did. So this Candy Factory problem, it strikes me as very easy.
What makes you say that?
Well, it's also suspiciously easy because bounds are small,
Oh.
which makes me nervous. So, correct me if I'm wrong, but the only candy that will ever cause problems is the biggest one, other than the end mud K part.
Sure.
So, is the answer not just either whichever is bigger, the number of candies we would need to add so that we have a total that's a multiple of K, or just the total number of candies minus K times the biggest?
Maybe you should try submitting that.
Yeah, that's what I was actually right in the middle of doing.
Oh, okay. Maybe I should step out for a few minutes and let you.
No, we can talk about other ones.
Do you have the real scoreboard, or do I need to send you that?
We have kind of the we have this. The real one is we have a slight issue with
I can send you the like public real one and not the like secret real one.
is this a secret real one?
That you have the secret real one. You should not expose that.
Well,
Let me.
late.
Well, it's okay. I will send you the real link so that you can.
Okay. Is this on Discord?
Yeah. I'll send it to you on Discord right now.
We'll take a look at Div 2 for everyone else now.
By the way, for those who don't know me on the stream, I'm Nick. I'm the head judge for Pac Northwest this regional, and I'm sneaking in for a little bit while now that the sort of beginning of contest stuff has all sort of calmed down. So yeah, so this is the proper scoreboard that will have it'll respect the freeze. So we don't want to be showing if you use the real one, you would be spoiling the freeze on stream, and that would be not very good for us because we don't want to spoil the results.
But they are identical up to that.
They will be identical for the first 4 hours, but please use this link.
When we do have the freeze, is it just going to be these yellow?
Yeah. So
Okay.
at the when we get there, David will explain what the freeze is, but there will be some suspense in the last hour.
Yes, of course.
What do you think of the problem set so far? Like, what have you looked at?
I think we've looked at L, M, and maybe A. What are those? Let's see the titles. I'm better at remembering titles than I am other stuff. So this is a greedy, right?
ABC string is greedy, yes.
You just have however many things, and then you put an A in the first of your buckets that doesn't yet have an A. Yeah, I think I proved there's no way of doing better than that.
Yep.
777s is a classic. Gotta love it. What else is there to say about this? This one is, yeah, so this one, you do a priority queue and a sort, right? So we have a picture here that will explain it somewhat well, I think. Yeah. So you sort these by first index, and then you add them when you get to that, and then you always remove the first thing to end.
So I think you might have misread the problem. So
Did
in
I?
the problem, you have to process the problems in order. So if you read the third paragraph, it says there is a specific order. So you look at the first problem, and then Ashley decides, oh, she's either going to solve it or she's not going to solve it.
You don't get to choose the order of the problems?
Nope, you don't choose the order of the problems. That's why it's
So why would you ever not solve anything?
exactly. So you always
okay.
it's much easier. In fact, your solution shouldn't work. It should just be wrong.
Just be wrong?
right?
Is there a sample to break it? No.
The sample does not break it.
One sample club.
Oh, actually, no. The sample will break it. Yeah, the sample you will claim that you can solve everything because you will. I think
Oh,
you
the
will try to
answer
solve
here
0,
isn't
0.
three.
You'll try to solve
Okay.
1, 1, and then you'll try to solve 0, 2. So you would actually break on the sample.
Yeah.
I did not set the sample to be very careful, I'll be honest.
Is there any reason we've chosen to have one sample for all these problems? I've noticed a lot of one sample games.
Is that true? It might not
One
be.
sample.
It might not.
This one. 2 samples.
Oh yeah. Okay, so I was nice, and for the easier problems, I had in Division 2. You'll see there were way more samples, but this is Div 1.
Yes, but these are the easiest problems of Div 1.
Yeah,
That's
so
fine, that's
so 777s is in Div 2. Training is also in Div 2.
fine. Oh my goodness.
Oh, this is
This doesn't look easy. I has no solves, right?
I think UC Berkeley tried it, but they haven't solved it yet.
Okay.
Yeah.
Who needs a sample?
I think the samples are generally. We use the samples to try to make it clear what the problem is asking, but I think what happens is, especially with a lot of the problems where it's like one integer per line, if we have multiple samples, you end up having like 4 pages of samples, and it's kind of gross. So we were subject to some like printing restrictions because of that. Like if you went back to problem I, like you have like 11 you have this sample takes up like half a page.
Yes.
And it's like
Can I ask a question? Just
Yeah,
as
what's up?
as a judge.
Mm-hmm.
Any particular reason you chose to put each of these on a different line rather than 10 in one line like Code Forces?
You will have to ask Vambi. Vambi came in at the 11th hour and was like, we should do 1 per line. This is a consistency argument that comes up a lot. The gist of it is that 1 item per line is sort of his like axiom or maxim. I think maxim is the word I want. So he always insists that if you have like here you have like n items and each item is like a cell and you put each one on its own line. Like if these were points, for example, or edges in a tree, you wouldn't have like 2n minus 2 integers and then like the first 2 are an edge, the second 2 are an edge, and so on. So like his argument is that like an integer doesn't get like special treatment and you can just stack them all on one line.
What if you have a single array?
So in his world, in his argument is that like, oh, you have an array of n integers.
That's
It's n items. Like
Okay.
it doesn't matter if it's an integer or a point or whatever.
Yeah.
You always print them on separate lines. So actually, some of my problems I autopilot and I do the Code Forces thing. I do one line with n integers, and then Vambi was like, we got to make these consistent, and I was like, all right, we're gonna do the.
It's a style thing. It's a style thing.
Yeah.
Personally, I have very strongly biased myself to do whatever makes the question look good, which includes very very short statements. I've got, but that's a style thing. Different people
Yep.
choose different things.
I'm gonna step out
gotta
and
head
let
back?
you get back to things, but I might be back in later to, if you want to ask me any questions about the scoreboard, or I can try to.
Sounds good.
start
I'm
over
gonna
things.
try this. See how it goes, and we'll see what happens. Thanks so much, Nick.
Yep.
Oh, actually, it sounds like I have an appointment with with somebody else here. We have another special guest coming on the show. I do that a lot. Sorry, what is it that you do on Code Forces, Mikhail? Yeah, what is it? Can you elaborate? What do you do a lot on Code Forces? One of the commentators is Second Thread, that's me. The other is Nick. He is one of the judges of the contest. But yeah, Second Thread on Code Forces or YouTube. All right, let's take a look at Div 2, and we'll be back in a minute here. Input arrays in one line instead of multiple lines. When you input them as one line, like, you mean when you're writing problems? Like creating problems? Yeah, I think that's the classic. I'm not sure. Yeah, my Code Forces handle is Second Thread. All right, I'm getting distracted here. We may have another guest coming up here. Over Zoom. The classic online meeting tool. When you're creating, okay, yeah. All right, sure. It's a second thread, and let me get his for you. And this. Yeah, those are the code forces handles. Okay, feel free to friend us there if you're interested. Lydia may be joining. She is the commentator for the Mid-Central Division. Looks like Dream Demons up with 6 problems, first half of the set, all ACs, and then going from there. Div 1, Div 1's a mystery. Div 1 is a suspense. The problems are so hard, we can't even show you who has solved them because they're that difficult. All right, guest arrival is imminent. Be back in a second here. Okay, can you say something just to make sure we have your audio going on here?
Oh, absolutely. I can say something, and I'm very happy to be part of that live stream now. And if you say something for my broadcast viewers, I think they should be able to hear you as well.
Yeah, we can do this. Here's a quick test. Make sure Zoom's working.
Let's go!
Wonderful.
Oh, this is crazy. Every time I'm surprised when technology works. This is something that never gets old. I'm just very shocked that things work.
That might not say a great thing about the default state, but but that's fine. Yeah, no, we've got this one working, and we have a makeshift scoreboard that we've been able to get to show people based on just like screen sharing the public one. So what regional are you commentating for, Lydia, right now?
It's Mid-Central, so all the incredible teams from University of Illinois Urbana-Champaign, University of Chicago, Vanderbilt, they're all here in the top of my leaderboard. Very exciting to follow them.
Home of the one and only Wisconsin as well, I presume?
Yeah, absolutely. This is exactly the way it goes.
Lydia, are you familiar with the fact that I grew up in Wisconsin?
Correct.
My home state.
I learned that from an interview that you did at the ICPC World Finals registration couch.
In DACA, right?
This was a very exciting moment.
Yeah,
correct.
That was fun. It was fun to get to meet some of the teams from there. Great part about World Finals, you get to meet people from all over the place.
Oh, I'm looking forward to that. This year is going to be twice as much fun. And we'll need to figure out which teams will go. Well, from this contest, I very much hope that each of us can lead a way for these teams for next September, right? We are currently trying to advance teams to Astana in September 2024. Exciting times.
When you say twice as much fun, can you explain what in particular you mean by that to the
Oh,
people who are new here?
absolutely. So yeah, ICPC World Finals is an event that is supposed to take place every year. Every year we host regional contests that select teams to the championship level events that then select teams to the World Finals. But because of COVID, we are unfortunately running a little late. As you've already noticed, we're currently broadcasting 2023 regional contests, whereas, well, my calendar just says that it's 2024 already. It's all because of this, scheduling conflicts and us trying to keep up with the clock. And specifically for World Finals, this resulted in us actually having not one, not two, but even 3 World Finals in 1 year, and 2 of them that will be held very, very soon will actually be combined.
So is that
which is
it sorry,
hilarious and exciting.
is it the 2020 and 2021 or 2021 and 22 that's happening?
This will be 2022 and 2023.
Oh, okay.
But just to make it less confusing, this is not how we call them. We call them 46th Annual International Collegiate Programming Championship World Finals.
And 47th?
And 47th
Okay.
International Collegiate Championship World Finals. And then it just helps you this little bit figure out how do you identify. So it's always a fun challenge if any of the coaches, and I hope coaches are currently watching us as well. When you're trying to identify which year at ICPC the global dashboard you need to open, the easiest way for me to go is just to count back from whatever year it is now to 46th and 47th ICPC World Finals.
Yeah, that works, I guess. The tricky part again is that the school year doesn't line up with the calendar year, right? School year starts in like August or whatever instead of January.
Mm-hmm.
So even if you have a normal year with no delays, the year that your ICPC finals is in wouldn't correspond with the year you qualified for it in a regional. So it's always a little messy.
And this year, the registration will be able to hear a lot of stories from people who actually graduated university many, many years ago and have been working in the industry or doing their research for a few years already. So I'm sure we'll get some exciting updates from our contestants. And absolutely ask them how were they even keeping up with the whole competitive programming community and how it went. Well, still something very exciting to look forward to. I think it's a little variety, and as I've already said, well, twice the fun.
We have a question here about Div 1 and Div 2. What do they mean from someone who's new to ICPC? So I guess I can take this, Lydia, if you'd like.
Yeah, absolutely, go ahead.
So my understanding is that Div 2 is more designed for people who are much newer to ICPC and don't really have an interest or an expectation that they'd be able to qualify for the North American Championships. So if you're interested in coding a little bit and you're a little familiar with programming, but you haven't really done much programming contests in the past, your first year in ICPC, for your school's first year, you don't really have a coach or anything like that, then maybe Div 2 will be a little more approachable. Because if you get thrown in the deep end with Div 1, there might only be 1 or 2 problems you'd be able to get if you haven't seen stuff like that before. And then Div 1, the main benefit of that is that if you compete in that, you're competing against all the other best teams in your region or in your country, in your continent, even when it gets to North American Championships. And the goal there is qualifying for the next stage. So at this level, you'd qualify for North American Championships, and then everything from there on is Div 1, right? North American Championships is only Div 1. World Finals is only the very best of Div 1.
Yeah, but also I think it's a lot of fun on how teams identify themselves. Well, obviously, it may seem like solving these easiest problems of today's contest in just 3 minutes. And in mid central, we had give me just a second. 1, 2, 3 problems solved in 3 minutes each, and then a few more problems solved very, very fast, or probably, yeah, and then like probably 7 problems open within the first hour or so. Yeah, within 70 minutes. And it may look overwhelming when you compare yourself, even theoretically, with the teams that can do so many problems this fast, like on average 10 minutes per problem for 7 problems in a row. It's pretty incredible. It may feel intimidating, and you may think that you don't really have a place in Div 1. And what I would be very excited to eventually see and look forward to is the same problems can be interpreted as something that contestant in Div 2 considers being complicated, and surprisingly contestant in Div 1 in Div 2 can find very easy. So it's a lot more about, you do not have to underestimate yourselves. Just go for it.
The other thing is like, it's not really as linear as you might think, like just difficulty, because there's a second axis to it, which is, in my opinion, originality, right? So there are a lot of problems which are very, what people call standard, which means like it's an idea, but it's a common idea that lots of people have seen before. So if you give someone a classic, you know, just like if you give a person who's been doing programming contests for 3 years, you give them a segment tree DP, right? It's going to be probably not too difficult for someone like geothermal or like me to be able to code out in half an hour. But it's also a very difficult thing that 5 years ago used to be an incredibly difficult problem because people hadn't seen something like that before. And now if you give someone, you know, a persistent segment tree problem, it's going to be annoying for them to code, but it's not going to be difficult. But if you're brand new to competitive programming, a persistent segment tree problem is impossible, right? You're not going to invent persistent segment trees, especially if you haven't seen segment trees before. You might get really lucky and be super smart and figure out segment trees, but you're not going to be able to invent the persistence, for example. So yeah, there are these things, but at the same time, there can be problems that are very medium to both experts and new people. If the primary goal of the problem is make some observation that's specific to this problem. If it doesn't require having some tool in your tool case, and it's like, notice that, you know, if you do this algorithm, you can simplify it by doing this unrelated algorithm, which ends up being the same thing. That kind of thing, generally those are more popular problems, just because like people enjoy them more if it's like very unique and the idea is very very specific. But yeah, so I guess the reason I'm saying all of this is that difficulty is not inherently unique, right? Even if you're newer to problem solving, you can still surpass people who've been doing it for longer and have more experience.
And even for teams who may seem to be training and practicing the same amount. For example, I currently have 2 teams from University of Urbana-Champaign in 1st and 2nd place, and they're the only ones who actually solved silent problems at this point. It just happened probably a minute ago. But even them, they have different subset of problems. So they have this 6, let's call it like early game problems as well. 4 of them from the very beginning of the contest, and then 2 more like right around an hour mark. But then one team solves problem E, another team solves problem D, which looks like they read all the problems at this point, and they figured this will be more approachable, even though they probably not only study at the same university, but also they were taught by probably the same professors. And so there is no specific difference in their knowledge, but rather in their preference, in their practice, and the way they approach problems and the way they estimate problem difficulty. This is a lot of fun to see. Well, it's also probably not that fun from the team from the 2nd place, which still means that if they close the stop line of the scoreboard, they're absolutely the best, one problem ahead of everyone, but they're from the same school. So, well, NAC slot question can add a lot of attention in here. We'll root for them. I absolutely love myself some, you know, a little Cinderella story, a little subverse expectations in here. So yeah, it's cool to be able to fight against the best team of your university and just lose by 80 penalty minutes time.
Just to be clear about why being from the same school matters so much, only one team from a school can qualify for the next round of ICPC, the North American Championships. Only one team from a school can. So even if you get 2nd place in the regional, which is incredible overall, if the team who beats you happens to also be from your same school, in this case, University of Illinois Champaign-Urbana, then you still don't qualify, right? Because you can only have one team from school make it.
This is
So
heartbreaking.
it's really tough.
Well, I've been following a lot of contests, ICPC contests specifically around the world, and this specific rule is super region specific. It's not exactly the same all over the world. In some regions, teams are allowed to advance to championship level competition, even if there are multiple teams from the same university. And I always feel like moving this incredible intra-school competition to this early may seem so unfair for the team in the second place. But at the same time, I know that it significantly helps to increase their motivation, their training level. We often see so many excellent teams from the same university if there is that limitation that they cannot go further unless they practice really, really hard. Now it suddenly matters. Suddenly it's not just enough to be good in computer science that you're probably studying for, but you need to actually grind.
It is a tricky thing too, especially for the judges, because the judges have to design a problem set that not only is like interesting and approachable for all of the easy teams, but it can't be dominated by easy problems. If the entire point of this problem set and winning it means you're just able to solve a lot of easy, right? Count how many arrays have 1-7 in it. If the entire contest is like that, then yes, it'll be approachable to easy teams, but you'll wind up with the teams who aren't the most qualified for North American Championships being the ones who win just because of these weird penalty side effects. So yeah, it's when you're designing a problem set, it's like, all right, how hard do we make it, right? We don't want to burn all of our difficult problems on this when we could use them in World Finals or North American Championships, but we also, right, need to make sure that we don't have a team win just because of their performance on easy problems.
Oh, tell me a little bit about Pacific Northwest leaderboards. How many teams do you have, and how many teams already solved at least one in each division? Obviously.
Yeah, let's take a look here. So we have quite a few teams. In Div 1 and Div 2, I think we have over 70. In Div 1, we have 65 or so teams, it looks like.
Ooh, nice.
But I guess we have several hundred, we have like 140, I think, in both divisions. But in Div 1, we have, like 65. And we have, I think, like 40 or so in Div 1 at this site. As you may know, Lydia, Pacific Northwest is split across 5 different sites in different states. We have one team with 7, I guess we have 2 teams with 7 problems. We got UBC and also Stanford Cardinal. UBC has H and Stanford Cardinal has B. That's the one difference in the solved set. But the thing that's particularly interesting about this is that although currently we're like an hour and a half, 90 minutes into the contest, H was solved by UBC 35 minutes in. That wasn't even their most recent solve. So since solving H, UBC has gotten F and gotten K. Stanford has gotten B, and then no one else has even submitted to H. H has had one submit 35 minutes in by UBC. That puts them in first place, and they're crushing penalty too. But yeah, it's very interesting. I wonder if it's like some obscure math thing that they've seen before that no one else has. Might be worth taking a look at.
That is what I always kind of expect from this random submissions from the middle of a scoreboard that are first to solves, and they're also like just here, and then top teams do not even approach this. And also sometimes I just know that a particular university is very bad at math. It's very good at math. And so I'm like, will any team probably even consider approaching this problem? This was obviously just a really good at math contestant who went and spent, 40 minutes integrating some crazy thing and then figured out a formula that is 1 line long and then implemented that, and then hooray, an extra problem right away.
Do you happen to have the problem on-call team in your set, Lydia?
What a great question.
I know there are a lot of shared problems between these.
Yeah.
Because if you do, I'd be interested in talking about it. I haven't read it yet.
No, I don't have one.
You don't have it.
let me read you the list of problem names, and we'll see which ones actually match. I'll read them in the order of from A to L. So rampant growth, range editing. I don't really know how to read this, but champer known verification, tournament matchmaking, segment drawing, eccentric excursion, triple sevens, diverse contest, training, balanced tree path, cramming for finals, and matrix fraud.
So you also don't have acceptable seating arrangements.
Nope.
Interesting. Those are the two most interesting looking things from our scoreboard. All right, sorry. What about you have range editing?
I do have range editing, and
it's a
range
tough
editing
one.
actually was solved.
Oh, really?
Or wasn't it? Or wasn't it? Give me a second. I think I have plenty of attempts. No. I absolutely misguided you. So 8 attempts from teams from all over the leaderboard, but still no successful solutions, unfortunately.
All right, let's look at that. That one's we have same thing in Pac Northwest. There are a lot of wrong answers, especially from good teams. Like we're not talking like first time here. You just happen to
Oh yeah.
misread the bounds and you're trying an n cubed on 10 to the 5th. Like these are
No.
top tier teams who are getting it wrong. So it's
Absolutely.
Let's take a look.
Absolutely same for me. Nice. Okay, let's go. Yeah, I
I'll
have it
read
in
the
my
problem
screen.
for you and then we can talk about it after. Is that all right?
Uh-huh.
All right, so you're editing a list of spreadsheet cells. Initially, all of them are empty, and you can perform 2 types of operations. The first type is you can select some range of cells in, I guess, a row or a column, maybe, and change their values to a positive integer of your choice. Second operation is you can select a continuous range of cells and delete their values, and then make them empty. Given the
Okay.
final cell values that you would like to have in this spreadsheet, calculate the minimum number of editing operations to obtain them. Wait, change their values to a positive integer, so you have range set, basically. So you can like 2D range set and then 2D range clear?
Mm-hmm. Well, 2D or is it either a column or a consecutive range of cells? Oh, it can actually be a rectangle, not just a line.
Kind of, I don't know.
Interesting.
They say spreadsheet, right? Spreadsheets are usually 2D,
Yeah.
but it doesn't say 2D anywhere in the problem, so maybe it is just a line. Maybe it's like one row of a spreadsheet, for example. Spreadsheet's an interesting choice of a word, though. Okay, so I guess you have range set and then range clear, which is also range set, right? Like, there's no difference between clearing them and setting them to 0?
Well, I believe there can still be zeros in the spreadsheet, but no, 0 means empty. Yeah, there is no difference between 0 and empty. There cannot be 0 as a value, I believe.
Okay. So yeah, so effectively, like, you just have range set, and you want to make some array with the minimum number of range sets.
Interesting. Do we have any limitations on what kind of input there can be, or is it just like a random input from the spreadsheet? Like whatever values there are, we can get it.
Yeah, so you're given basically, it looks like some array, and the question is, what's the minimum number of range sets you need to get this arbitrary array? But very, very notably, the size of the array is at most 800. So it's at most 800 elements.
That's not much.
Yeah, so it's not like we need to find some greedy way of doing this in linear time. We can be much slower.
Okay. So what are my initial thoughts? Well, obviously, we can always just take every single cell as a separate value and set it individually. So this is our absolute upper bound. There is no reason for us to ever go about the number of non-zero values in the given input. Then every time we have, our operation, for whatever reason, probably because you just mentioned like segment trees and stuff, I expected the operation to be like update on a range, as in not set them all to equal value, but I don't know, add a fixed value everywhere.
Yeah, but it's not. Right?
No, it's much easier.
Range set.
I have first to solve from our current leaders team Ipatsu. They now have 8 and they solved problem L. Just updating spectators on WhatsApp.
So real quick, someone here is saying DP and N squared, but like they're important details still, right? Like what is the DP and how do you do it in N squared? Like what is your state? But anyway, sorry. Continue, Lydia. Yeah.
Yeah. Well, they're welcome to elaborate. So, but instead we are only allowed to just actually literally set a range. So, if you have a number of cells with the same value, that's great. We'll just set them all at once, and we can make it as our very last actions. As in, we don't really need to do that early. Like if we have 10 ones in a row, this will be one of our last actions, and it's nice because won't have any intersections with any others. So this is a plus. But on the other hand,
so I guess just
intuitively want to select as many of them as possible. So if we select all of the cells that have the same dedicated value, we'll then have to patchwork our way through the rectangle that we've built to make sure that each of the values requested will be manually built, which is weird. It may require some weird shaping.
So like one of the things you mentioned was like if you have consecutive 2s, for example, then you can merge them together, because you would never, if you have 2 things that are the same, you would never set them to different things. They'll always just stay equal. So consecutive equal elements can be merged. And then one way of looking at this is when you overwrite some range, if you're ever able to, at the very least, like construct if you look at the places that you paint at the end when you're done, right? If you imagine like painting a stroke, these will make a tree always. You'll have a tree structure of them, because although the two ranges
otherwise there's no reason to overpaint the other end.
Yeah, like if you have 2 ranges that overlap, there's no reason for them to overlap like that, because you're overwriting the second half of the first one. So you might as well just stop them early. So you'll always have like some sort of tree structure of the ones that you paint. So now, can you and then if you have a tree structure, just the number of strokes is your answer, right? But the question that's remaining is can you get all the tree structures with a DP and N squared easily? Is that something that's doable?
Do we need to?
Maybe.
800 is pretty low limitation. We can do
N cubed maybe?
And
do we have a time limit? What is the time limit? Did they tell us?
I don't have it in the interface, but it's actually 4 seconds on OpenCADIS.
Ah, so that does scream N cubed.
That's a lot.
Yeah,
that's a lot. So yeah, whoever was commenting that it's N squared DP, I'm not buying.
Omar, give us more details. If it is N squared DP, show us how we can get there, because it seems like you may be smarter than judges if you can find a way of doing that. Otherwise, if I was a judge, I would have made bounds at least 2,000.
Well, judges do not have to actually set a problem as difficult as it can be. It's sad to actually waste a problem that has a more elegant solution and only requires something intermediate. But on the other hand, well, if it's necessary for contest balance, then probably it's just worth it, and they should go for it.
Yeah, it's true. I was looking at one of the earlier problems, something about candy distribution. I thought I had a greedy solution to it, which was pretty simple, but it's possible I was wrong, because just from reading body language, when Nick came in, he was like, you should submit that and see what happens. And I'm like, okay, well, if that's the response, then it seems like the answer's probably not, but we'll see.
Oh, another fun question that I would like to know about Pacific Northwest Coastness. How many incorrect submissions do you have? Because Mid-Central has barely no incorrect submissions on the easier problems. Well, probably for problem G, 78 solves 1 incorrect submission. For problems C and I, 65 and 68 solves 4 or 7 incorrect submissions. So there is literally not an early game problem that turned out to be, weird to have this tricky corner case that every team that was not ready for that will fail on. They were actually apparently pretty straightforward. And reading the problems, they are apparently pretty straightforward.
Lydia, I'm looking at our scoreboard now, and I don't know that I'd call it a bloodbath, but I certainly wouldn't feel comfortable submitting to C, F, G, I, or K.
Oops.
So yeah, C has, it looks like 2 or 3 times as many wrong submissions as AC's. F is like 1 and 1. I has 2 wrongs, no corrects. G has 1 wrong, no corrects, and K has 1 wrong and 4 corrects. So, and these are, like, to be clear, like most of those are teams at the top of the scoreboard too, right? So those are like the teams knew what they were doing and then still got them wrong, which means, B also has an AC. Or I guess maybe that happened earlier, but we got dark green from B by Stanford Cardinal.
Congrats. Oh, this is excellent.
It looks
I
like.
wonder how long was their solution testing, but sure.
Yeah, sorry. It looks like other teams are starting to get H as well. It's starting to get on the scoreboard, despite the early 35-minute solve. Okay, Omar is a newbie. I don't know if he's joking or he's serious about this when he said easy n squared DP. Omar, if you have a solution to this n squared DP, give it to us. If you don't, if you're just like suspecting that it's n squared, that's totally fine. But I'm just curious. If you're a newbie outsmarting us, all the best to you. Right? Some days I feel like I should be a newbie, but yeah, no, it's a date, and we got just 3 more. The score refreshed, 3 more wrong answers, Lydia. So it's brutal over here.
Oh. Okay. Sending my energy to teams in Pacific Northwest. Apparently, I was taking a good care of Mid Central, and they did things well. We have very successful leader teams specifically, because once again, Urbana-Champaign has been just rocking it, even though they just submitted B incorrectly, and even though problem L was, well, obviously not easy, even though they solved it in 100 minutes. 6 incorrect attempts, probably not something that they dreamt about, but also still a very nice lead, very nice advantage, like 1 solved problem over the second place, like pretty clear pace, and the easier problem they went through without any hiccups. So
what is your problem B,
fun.
by the way, if you don't mind me asking?
Problem B is the range editing.
Okay. So yeah, it looks like
no solutions yet, but 1, 2, 3, 4, 5 teams out of top 10 are actually, I believe, working on it actively and for a pretty long time.
It looks like that will turn out to be a medium/medium hard problem in your set, if I had to guess, because Urbana-Champaign,
yes.
they're at like a similar level to UBC, right? So at least in like by World Finals performance historically, and UBC has gotten 3 of their UBC problems. 3 of the UBC teams, sorry, have gotten H. So I don't know. I'd be surprised. Like I would expect them to figure out what's wrong with their H and get it later on. If I had to guess.
Yeah, but my concern is, well, we have B, that's range editing, and that's okay. A lot of incorrect submissions. Teams will spend a lot of time on that. We have F, that was untouched by anyone so far in the lead, and we have K that has an off submission here and there. Already submissions on B, already solvable D that their schoolmates from Unbingeable already solved, and then just 2 more problems. I'm pretty scared about their performance. This seems very dominant.
Well, we'll see. At the very least, it'll be a fight between some UBC teams. Thank you so much, Lydia, for joining. You wanna say goodbye here, and we'll head off.
Yay! See you soon, everyone. Absolutely tune to our broadcast. We have a few more broadcasts scheduled for the next 2 weeks. So hopefully this YouTube channel will still entertain you with something very exciting. And yeah, best of luck with all the incorrect submissions. I wish them all gone.
Well, they'll keep working for the next 2 hours or 3 hours or so. All right, thanks, Lydia. See you around.
See ya. Bye-bye.
All right, so there was Lydia. We'll have geothermal coming on in 15 minutes or so. Let's hear what people are saying. Omar says, I have an observation that there will always be a final edit, meaning we may need to brute force that. Yes, but if you brute force it, you still have a problem that's almost as hard, right? So it's true, right? Like there will always be something you do last, but even if you know what that one was, it's still not obvious how you get to right before the final edit. To me, at least. Maybe it's obvious to you, but I don't see how you do that. Mikhail says, the problem does sound like some sort of DPLR should work with another order n transition iterating over how to split the segment. Yeah, that's it. You don't know what the first edit is, I don't think. But that solution that Mikhail said is it, right? Let me elaborate. Surely that's right. Let me share my screen and then so you need, let's use colors because these are easier to see. Let's say you have something like this. I think anytime you draw a range, okay, anytime you draw a range, you should always start and end at that color. It never makes sense for us to paint this range pink. Because why end here? If you end here, this isn't going to end up being pink, right? So instead, just end here. So you never want to start and end, or you always only want to start or end at a pink. So, okay, fine. So let's say you want to paint or you want some range to be solved. If you do this, these start and end with different things, right? So we have to find some way of like splitting this up into two parts. And let's say we split it up into these two parts. So this part will be painted pink, and now we have to solve this part. So our order n transition is going to be, we're going to try moving this point. We're going to try each of these places, right? So there's n squared state, order n transition. And then once we're here, now we're going to try solving this range here. And we'll try each of the transitions. The one that will work will be this one. And then we'll paint this green and then solve this recursively, right, within the subproblem. Ooh, you might need like some order 1 stuff though, because it's a little messy. If you have like these, like how do you, if you have like a green here, a green here, and a green here, you need to consider solving these ranges, right? You need to call these sub-DP states. But no, it's easy, because if this is green, well, it's not easy, but you can do it. Because you know these are all green, so you want the spaces between each of the greens. So you can do it with like a second DP or something to do for all of the things between greens from this position to this position. What's their cost? Mikhail says DP of LRX, which means color everything on this range except color X. Yeah, and then color X is what you paint it. Yeah, so it is like an n, either n squared with another n squared thing to help you speed up, or like an n cubed DP. I'd be worried with the n cubed, to be honest though, just to be frank with you guys. I'd be worried if you did an n cubed about memory. Because n's big, right? Like n's small for n squared, but it's a big n for n cubed. 800 cubed is a little scary to me in Java. Maybe in C++ it's a no-brainer. Cool. Thanks for the help. I appreciate it. It's a little stressful when you're up here in front of a bunch of people. Come up with solutions. Intended is n cubed. I would hope so. Not n cubed memory though. Not n cubed memory. Right, Nick? It's not n cubed memory. It's a lie. Is he in this room? He might be literally next door. N cubed time, very short. Yeah, n squared memory. Okay, good. Yep. Very short is interesting. So my solution will be a little more messy than intended, I would imagine. But if it came down to it, I could get it. Let's take a look at the standings again here. Div 1. We got a 3-way tie for first place. 3-7 problem solved. We've got UBC, Return of the Sleepwalker, UC Berkeley, and Stanford Cardinal. Like I mentioned earlier, there's a lot of good talent here. In previous years, I think we had, who won last year? I actually forgot. We showed in the beginning of the contest. But yeah, and the easy problems have fallen. It looks like that's F, H, and K. Not easy, but medium. Another solution from De Anza on F. Did they get it? Their third submit? No. Oh, and UBC on I. No ACs on I yet. So this will be a dark green if it's correct. Big if. But it's running for a while. The suspense is killing me. There's an 8 in the open. I don't know what 8 means. Could you AK this if you're a newbie? Not a chance. Unless you're a very, very, very lucky or talented newbie. You could give it a shot though. You might be able to AK Div 2. Maybe not in 5 hours, but in enough time. Don't set a timer. I don't want to leave because this is so entertaining, but also we're just sitting here waiting. Oh, they got it. What legends. AC on I, dark green, 106 minutes into contest. Well done from UBC. There you go. Puts them in first place. I bet they're proud of themselves there. I would like to see the reaction. They're obviously, UBC is obviously in Canada, right? So it's not here, so we can't see their reaction, but it's exciting. It's exciting. All right. Well, we'll take a look at I. We'll have geothermal come on in just a minute here, but we'll take a look at I, and hopefully I is a problem that's also in his set, and then we can think about it together maybe if he hasn't solved it already. But we'll see you guys soon. I'll let you take a look at Div 2. We'll be back in a bit. rumor has it. Let's go. Thank you, Lydia. Lydia has fixed this for us. Yeah, sorry the scoreboard is broken, but it's back now. Beautiful as ever. We're going to jump into a call with Jay in just a second here. But thank you for fixing this. It looks amazing. We'll have Jay joining us in just a sec here. We have a meeting with him ready to go. But yeah, what a cool scoreboard. We have some hex code teams. These are traditionally from Hawaii. A lot of Hawaiian teams tend to like making hex codes as their names. Something they've done for a few years now, the judges say. Just a way they like to have fun. UBC, their AC on I is carrying them. Now, I want to mention a potential mistake that I made from earlier. H is not actually the problem we thought it was. H is on-call team. The problem we were talking about is I, the N cube DP. So that's not H, that's I. But yeah, similar difficulty, similar on the scoreboard. Looks like we got another solve from I. By longest subroutine. Nope, that's the open division. Never mind. We got a solve from I by just UBC SEA. Yeah, okay. Welcome, Geothermal. How's it going?
All right, let's have a look. All right, can you see me, David?
We can.
Excellent.
It's great to have you on.
Good to be here. Glad to have you over here. And let's switch screens. And now, hopefully, cool. Hopefully, everyone watching the South stream can see David now.
Good morning, South Stream. I know it's pretty late for you guys.
Not too late, just 3 or 4 p.m. depending on what time zone you're in. Hopefully, how's everything going in Pacific Northwest?
Pretty good. We had a little fluster at the beginning with a delayed start, but it seems like things are all on track now. We're doing pretty well. I saw briefly, is it true that UCF had the dark green from you guys?
Yeah, UCF Catalan and UCF Apocalypse Attack, which is another UCF team, has a 2-problem lead at the moment. So,
oh my goodness,
you'll be glad to hear that your old team's doing great.
Yeah, congratulations to them. I just want to mention, in case people aren't familiar, I went to UCF. I was a UCF competitor back in my day, so it's good to see they're doing well.
Yeah, if there's extra time at the end, I would love to talk to you about just everything that UCF does for training, just because it's really impressive, the program that they've built up and how they manage to have such a strong pool of talent year after year. So, but for now, so let's see, I guess I don't think that we're on the exact same problem set, right? There might be some overlapping problems, but between the South and Pacific Northwest, but some different ones.
What I've heard is there are four different ones. Now, I don't know if that means we have 4 problems you don't, or there are 4, like the different count is 4. But yeah, I think I've heard there are four different problems between our sets.
All right, cool. That should be a lot of overlap. We have 13 in total, so.
Yeah, happy to talk about some shared ones. So
how much time have you had to spend reading the problems so far?
I think I've gotten through maybe 4 or 5.
About the same here.
But they're definitely.
Do you guys have ABC string in your set?
We do. That's the greedy, right? We've talked about that one, yeah.
Nice. Let's see. Are there any that I think most of the ones that I've read, I've like talked about a little here. So I'm happy to look at some new ones or to talk about any that you guys haven't discussed yet? Are there any that you're particularly interested in?
Do you happen to have acceptable seating arrangements?
Acceptable seating arrangements. I do not think so. Let me check our Div 2 actually and make sure that it's not there.
Unlikely.
No, we have it.
You do? All right. Can we take a look at that one?
Sure thing. So let me read it out.
Wait, hang
for
on. You
the
have this in
benefit.
your Div 2, but not your Div 1?
Yep.
Yikes. All right.
No one solved it in Div 2 yet. Maybe it's a hard one.
It looks
So-
like it, because in our Div 1, there are 2 solves.
Interesting.
Sorry, in the open Div 1, there are 2 solves. And those 2 solves are Ksun and Conqueror of Tourist. Both
so,
LGS. Yeah.
Yes. Yeah, strong, very strong competitors. All right, let's see. Oh, hold on, let me check. I think my Zoom audio might not be picking you up. That would be bad. Hold on.
Good morning. Good morning, South. Big
Oh,
South.
maybe it works. Okay, never mind. I think you're
Okay.
good.
All right.
I'll check the stream and make sure no one's complaining about being unable to hear you, but okay. Should be fine. I think let's see, someone's saying you might be a little loud, so maybe I'll turn this down a little bit, but I think we should be good.
I'll just be consistent on my end. Hopefully that helps.
Yeah. Well, okay, I've tried to make you the same volume as my mic, so hopefully we're fine.
All right. Do you mind if I just read problem B first, and then we can talk about it after?
Yeah, acceptable seating arrangements.
Yeah, I'll just read it out loud just to
Go for it.
keep us in sync. Charlie is managing a classroom. The seats in his classroom are arranged in a grid with rows and columns, and each student has a distinct height. A configuration of students to seats is acceptable if the following conditions are met. Each student is assigned to exactly 1 seat, and the students are in increasing order of height from left to right in each row. So it looks like there's 2D grid, yep. And then you want them to be sorted in each row. All right. The students are initially seated in an acceptable arrangement. Charlie wants to rearrange the students into a potentially different acceptable arrangement, and to do so, he will swap any 2 students. However, he wants to ensure that the configuration stays acceptable after each swap. Help Charlie devise a strategy to move the students from the original arrangement to his preferred arrangement. You don't need to minimize the number of swaps, and you're limited to, at most, 10 to the 4 swaps. It can be proven this is always possible for all possible inputs that satisfy the input constraint. Oh, is this
Interesting.
interactive?
This is really cool.
No, this is just judge.
No, it's
judger.
yeah, it's just
I've,
it is like
I've heard there's one interactive problem which is really good. Is what Nick tells me.
interesting. Yeah, so that's problem J in our set. And do you know what the IG verdict stands for? Because we've gotten a lot. I don't know if it's like idleness limit exceeded or something, but we've had a lot of people that, or a decent number of teams have accepted. Or have gotten accepted on them.
IG is in like Igloo Gamma or whatever.
Yes.
I don't. I've not.
Yeah, I haven't seen that one before. A lot of teams have been getting that. It doesn't seem like it comes with a penalty. It's I know quick update for people watching the South stream. UMD White has just solved their 8th problem, solidifying their 2nd place position. So congratulations to them. Yeah, so I don't really know what's going on, but no one's really gotten it in the South. Has anyone gotten that problem over on your end?
I'm gonna be honest. I don't know which problem it is. I haven't
read it too. Maybe
Sorry,
we can talk about
what
it
is
later.
it called? What's the title?
That would be step 1, sequence guessing.
So that's K for us. Yes, actually, quite a few solves. We got 5, 6, 7, like 8 or 9.
Wow, interesting.
Yeah. So impressive.
Very cool.
All right, let's go back to this one though.
Yes. Yeah, so this is an interesting setup, and it feels like it's a little rare in ICPC to have problems where your multiple different outputs can work, and you're just trying to figure out and you're just trying to find any possible construction. So, pretty cool setup here.
So a quick question about the input.
Yes.
So, is 2 the height and 3 the width? Oh yeah, and then so you're given 2 grids. So it's this input is
yes,
2
exactly.
2 by 3 grids, and you
Yep.
go from the first to the second. Okay. Interesting.
Mm-hmm. Let's see.
Noticeably, input is tiny.
Yes, and we can you do up to 10 to the 4th step, so we have a lot of room to potentially do stuff that isn't the most efficient as long as it works.
Mm-hmm. One
I mean, I guess
one observation. Sorry.
No,
Like,
you go ahead.
if you had these sorted in like row major order, if you're able to sort everything, then you don't have to worry about going like from some state to some other state. You can just go from some state to sorted, and then from the other state to sorted, and then invert the second half.
Yep, that's a good idea. And so then we just have one like canonical set of one canonical arrangement that we're just always going to try to reach.
Yeah.
And we know from
question-
we know from the problem statement that we can prove that this is going to be possible. So
yeah.
I guess as long as we can do that in 5,000 rather than 10,000 swaps, then we should be good to go.
And the question is like, how do you sort this in row major order? Like,
Yeah.
can you do that?
Let's see. So I guess I mean, intuitively, it seems like it seems like it should be helpful to work either from smallest to largest or largest to smallest, either one. And I guess the thing that I would worry about a little is that, so if we want to, is that like, we can swap, so if we look at like the position of 1, for example, we can swap 1 into any position and it'll still be like the smallest in its row.
Sorry, am I messing up your Zoom?
No, you're not.
here
You're
if I do
good.
this? Okay.
No, you're good. 1 will still be the smallest thing in its row, but the problem is that if we swap it, or is that whatever we swap into the position 1 previously occupied might be larger than the next thing in that row. So that's a little bit tricky.
Yeah. So if we have something like this, maybe I'm gonna try putting the biggest one in the last, if that's okay.
Yep. Should the second thing be something other than a 1, since we know that all the things are distinct?
Oh, well, yeah, it doesn't matter. You're right. But 2, 10, and then 3, 4. Oh, I guess that might be helpful. 6. So if we have something like this, so we want to move the 10 to the 6, right?
Yes.
So, sorry, just to confirm, can your stream see me? See my?
Yes, they can see the drawing.
Okay.
It's helpful if you can stay on the left side, or actually maybe I can just move the Zoom window or something. Yeah, it'd be helpful if you could stay on the left side just so that of your screen, just so that because I have the problem up on the right.
Sure.
But what you're doing right now is perfectly visible.
So we want to swap these because we want 10 to be in this spot here.
Yep.
And in this case, it's fine, but it could hypothetically not be if we had something like this. So if we had 7, 8.
Right.
Because now swapping them, if you did that, then you'd have 7, 8, 6, and 6 is too small.
Yeah. I wonder if there's like, I guess this might be a little bit too slow, but I wonder if there's like one thought is that if we can prove that we can always do a swap that will destroy an inversion in the array, then that would be sufficient because, or that would at least, I guess that might theoretically take too many moves, but then if we like just theoretically kept doing a swap that destroys an inversion is meant until the array is sorted, then that could potentially work.
Yeah,
so I guess
that's a good conjecture. I have no idea if it's true, but
yeah, me neither. I mean, the other thing to think about is that the number of inversions, in some sense, the number of inversions could be large, or could be large. It could be like 400 choose 2 as you're writing out. However, it is like at least slightly limited in the sense that we can't have an inversion between 2 elements in the same row. In other words, so each row has to be sorted in order.
So Mikhail, who's helped with some other problems in our chat, says he thinks there are at most 20 times 20 choose 2 inversions, which would be below 5,000.
Yeah, I think I agree with that. Wait, hold on. I guess I would think 20 choose 2 ways to choose 2 rows times 20 squared.
Wait,
because if we choose 2 rows and then
I feel like it's order n squared things, right? Because like for each element here, this element here could be bigger than every other element not in this row.
Right.
So that is pretty much n squared.
N squared inversions per item potentially.
Or, yeah. So if there are n items in total, they're pretty much n inversions per item. I mean, the only time it doesn't work is if they're in the row, but there aren't that many in that row. Most of the
Right, but like 20, I guess n could be like 20 squared, right? So there can be on the order of like 20 squared inversions per item.
Yes, exactly. Yeah.
And so like basically with 20 squared, it's like I would expect the number of inversions, unless like we do something smart, to be potentially on the order of n to the fourth, which would be
I agree.
which would be not great. We can see. Let's.
Yeah. It could be if you always if you always pick the swap that has the most inversions, it could be that cuts it down really quick.
Yeah, perhaps. Or it might be that every swap is guaranteed to. Or maybe it could be that every swap in some way is guaranteed to destroy more than one inversion, but hard to say. Maybe maybe we should put this aside for a little bit and think about.
Some other problem?
And keep thinking of ideas.
But okay, yeah, sure. So one question is like, just for this example here, we have like a very solid example, right? We have 7, 8, 10, 3, 4, 6.
Yep.
Like, how do you actually in practice make progress here? What do you actually do? Swap the 6 with the 8 or 6 with the 7?
Let's see. I guess. I mean, in some sense, like we just want to swap the entire 2 rows, right?
Mm-hmm.
So let's see. So I guess I think the only valid move here is to swap 6 and 7, right?
Oh, yeah, you're right. Yeah, that's the only
So
thing
let's
you
do that
can
maybe.
Okay. So let me just...
It's a cool problem. All right, awesome. And now... Sounds about right.
Is there anything else you
Feels
need
like
to
we're
do?
sort of bubble sorting or something like that. Okay, and then now we can do the 8 and the 10.
Now we're done.
All right, and so in order n moves, we've moved the 10 to where we want it to be.
Oh, but look at what we just did. We had this thing here, right? We did this. What we did is we took all of these things and then we moved them over by 1, and then we moved this down and moved the X here.
Yep.
And you can always do that. I mean, it doesn't have to be in the beginning.
So,
You
yeah.
can have things before it.
Yeah, I agree. And so maybe, let's see. So how many moves? So this took like 20 or order, like just n moves basically, right? Or I guess here it took us 3 moves. Is that right?
Yeah, I think so.
So it seems like maybe if we just I think like there's nothing special about this where row major order makes this easier to work with. So maybe if we just go back to trying to solve the problem directly, we can do this and it'll take like at most 20 moves per element. And since we have 20 squared elements, that's 20 cubed moves at most in total, which is 8,000 moves, which is fast enough.
Okay. So you're saying don't do row major order just because then we don't have to do it twice, so we get extra room.
Yeah, exactly. So here, do you want to maybe like work it out in the in the sample?
Sure.
Yeah.
So can you read it to me just because I don't have it available?
Yeah, sure. So the first grid is going to be 1, 4, 5, and then the second row is 2, 3, 6. And then for the target grid is going to be 3, 5, 6. Ooh, like the color change. 1, 2, 4.
Okay, so I'm gonna,
Awesome. So
I'm gonna
let's
use a
bubble
little
to
bit of the
6.
right side of my screen, by the way. So in case you want.
Okay, we don't need the problem anymore. I'll just pull you up, and now the people can see our beautiful faces. So that's always a plus.
You want 6 to move to where the 5 is, right? Because that's. Or sorry,
Yep,
what are we trying to do first?
I think we were thinking largest to smallest. I mean, I guess the 2 should be in some sense isomorphic. So
okay.
But let's do largest to small. So and the 6, like right, we can already move it with the 5, so we can do that right away.
Okay, so then you get 1. I guess let's just do this.
Yeah, I'll keep count of our moves, but I guess we aren't asked to minimize the number of moves, so it's not important that we just use 4 moves like the example output does. All right, so now the 5 has to switch with the 4, and we can also do that directly.
Okay, so if we were to do this, what problems could there be? So there could be this one is, well, this can't ever be too big. because
Right.
we're doing the biggest to smallest. So we know this one is safe. And then
I guess the issue
this
could be
one
that
could
like
be too
that
small.
like what if the top
too big.
what if like the top middle was a 3 and the bottom middle was a 4? Like it could be that the 4 isn't large enough to
And in
to
that
be...
case, we would just have to loop them. Like
Exactly.
We did before. Okay. Yeah. Yeah. So I think we got it. Let's just do this just for completeness. So then.
Yep. So
5
1,
here,
5,
4
6,
here.
and then 2, 3, 4. All right. So now we need the 3. Now we've got the 4, 5, and 6 in the right positions. Now let's do the 3. And so see with the 3 now we can't just directly swap with the 1.
Mm-hmm.
So we're gonna need to swap the 1 and the 2 first.
Okay. So then we would have 2, 1, and then we swap the 3 and the 2.
Yep. And then we're done.
Yeah, looks great. And then 2 works
Yeah.
and 1 works.
Nice problem. I mean, it seems like the I know trying to think about solutions in the abstract doesn't seem like it works super well for this, but then when you actually like think about concrete ideas, it turns out to work out really nicely. So it's a cool task.
No, I like it. I like it.
Yeah.
Very, very.
There have been a lot of
good.
good problems in this set actually, and that I feel like.
Do you want to take a look at the interactive one yet? Have you looked at it yet?
I have not. So yeah, that seems really cool.
I've heard wonderful things about it from Nick. So.
Excellent. Great.
That would be fun.
I'm going to take a moment, by the way, to let me explain to my stream what an interactive problem is real quick. I don't know if you've gone over that already.
I'll have them watch you as you do it.
Great. So basically, for most competitive programming problems, the way the problem works is you receive an input and then you write an output. And so for this problem, for example, 777 I pulled up, you have to like read in this sample or this input and then write out the correct answer. And then your goal is either for the answer to match exactly what the judge thinks the correct answer is, or in the case of this acceptable seating arrangements problem that David and I just went over, you have to output any acceptable answer. Any like valid swaps, it'll be a correct solution. Interactive problems are a whole different beast. The way an interactive problem works is that rather than receiving all of the input at once, the judge is going to give you some information, and then you're going to have to like maybe ask the judge certain types of questions or give it like some information before it'll give you any more input. And so you're basically your program is going to have to communicate with a judge program until hopefully like it finally ends up giving the judge program the correct answer that it wants to hear. So that's a general sense of how these work, but we'll see a more concrete example right now. Anything else to add for now, David?
Yeah, just the most classic example of this is guess the number, right? Like you're thinking of some number and then you make a guess and the judge tells you, is it too high, too low, or did you get it right? So that's like that's the most common example, but they don't have to be like that. That's just
right. Yeah, it's a great example.
All right. So yeah, let's read it maybe. This one is sequence guessing?
Yeah.
All right. So you guess the sequence instead of guess the number.
Yes.
So
let's see.
I'll read it again and then we can go from there.
Yes, go ahead.
So you are tasked with creating a secret sequence of integers that's difficult to guess. The sequence is subject to the following constraints. The first number must be 0, the last number must be 100,000, and each number must be either 1 or 2 greater than the one before it. So you start at 0, you have to add 1 or 2, and you have to end at 100,000. At first, all you need to reveal is the length of the sequence, and then an adversary will guess the numbers in the sequence one at a time. If the guessed number is in your sequence, you must reveal exactly where in the sequence it appears, and if it's not, you must simply reveal that it's not in the sequence. This is considered a miss. Note that because you are not forced to write down the sequence in advance, you can cheat by changing the sequence you have in mind, so long as it does not contradict the information you have revealed so far. It turns out that under these conditions, you can always force the adversary to guess 33,333 misses, so miss 1 in every 3 times of your total, before they can guess every number in the sequence. Your job is to write a program that makes them miss this many times. Do they give us a sample?
Well, I think like
okay.
Yeah, I think they give us a sample interaction, but it obviously but like there's only one, or presumably you're only going to end up just creating one array that works, and so.
Mm-hmm.
This is an
but it'll be
interesting
different every time. This is like very weird because this is like you're almost writing the judger.
That's exactly what I was going to say. So, for context for people, there are like 2 types of interactive problems. there's one type of interactive problem which is called non-adaptive, where basically there might be like so as another, or going back to David's guess the number example, if with a non-adaptive interactive problem, the judge will just like figure out in advance that the number you're trying to guess is, let's say, 20, and then it'll just like output the correct answers to all of your questions based on your guess being 20. With an adaptive interactive problem, the judge can like cheat a little, cheat in air quotes, in the sense that the judge can change the correct answer to be any possible answer that's consistent with the questions you've asked so far. And so, for example, if you said like, the judge might initially say, okay, 20 is going to be my answer, and then you ask, is it higher or lower than 30? And the judge says lower, and the judge might say, okay, I've changed my mind. Now I want my answer to be 10, and that's allowed because even if the answer was 10 all along, the judge would have given the same answer to your question about whether it's higher or lower than 30. And so,
to give it a concrete example of like when this would be useful, like if you're playing guess the number between 1 and 10, right, and someone guesses 3. 3 is a bad first guess. What you should guess is 5, because that way it splits it evenly. But the judge might have initially been thinking of the number 2, and then before they answer, they're like, all right, I'm going to change my answer to 7. And 7 is still consistent with like it can pick whatever it wants, but it's going to change its answer. That way it makes it worse for you, and it takes advantage of something you did that was suboptimal.
Yep. So the idea of writing of doing an adaptive interactive problem is so the judge can make sure that the contestant's program will perform as poorly as it possibly could. And that's exactly what we're trying to do here, where we're trying to force the judge to take at least 33,333 misses.
All right. I'm sharing my screen again with you here, Jay.
Excellent. I can see it.
And we can maybe walk through some way of thinking about this here.
Yep.
Do you think maybe it might be easier to think about this in terms of like 1 to 10 rather than 1 to 100,000?
Yeah, probably.
Okay, so we have 0.
I guess I see it. And then one thing that I worry about a little bit is that it seems like the 333 bound could be pretty tight. And so in that sense, like some very niche properties of 100,000 could be pretty relevant. Like
the fact that it mod 3 is 1?
Yes.
Is it mod 3 1? Is that true?
Yes. 100,000, yeah.
Yeah, any power of 10 would be. Yeah.
Yep.
Okay, so yeah, so the first thing is like, basically you have potential, right? Like you have some number of potential left. And
yep.
Oh, hang on a minute. They can guess any number.
Right.
Oh, this could be a problem.
So one thought is the difference between any two adjacent numbers in your sequence has to be 1 or 2. So if you report a miss, that means that the next higher and next lower numbers have to be in the sequence.
Mm-hmm.
And in particular, the judge can just guess one of those numbers immediately afterwards at no cost, and then we'll know what position they're in. So it seems like as soon as you either when the judge guesses a number that's in your sequence, you have to immediately commit to how many numbers you're going to put below it and how many numbers you're going to put above it.
Yeah, so the judge will probably guess like 5 first, right? Or
yeah,
something in the middle.
Yep, and so if you report a miss, then it'll know both 4 and 6 are in the sequence, and in particular can then guess 4 or 6, and it'll know exactly how many of the elements are in the left part below 4 and how many are in the right part above 6. So in that sense, at each stage, you have to commit to a certain number being on each side. So that makes me think like one slightly silly thing that I would think to do is I would think at this point is I would actually be tempted to write a brute force program that asks the question of what's the maximum number of misses we can force if we have n, or if we have, I don't know, a certain number, we have a certain like length of our sequence within a certain like length of numbers. So in other words, if we need to use like 2 out of 3 elements, for example, what's the maximum number of mistakes we can force and how do we do it? And that might potentially and so theoretically, if I was solving this problem and my teammates weren't using the computer, that would be a way to try and spot a pattern. But
so is this what you're talking about? You're saying like if you have so much room and so many forced hits, you can force this many misses.
Yep.
Is this always what you should do? Because like, well, so I guess the first question is like, if the judge guesses a position, you have to decide two things. One, is it a miss or a hit? And then also, you might as well decide, I guess, well,
You have to decide. I mean, you have to decide if it's a hit. You have to decide how many numbers will be to the left, and if it's a miss, you know the judge can just like ask the adjacent numbers right afterwards. So you might
as well just decide.
Yeah, like the judge could force you to say right then and there how many numbers you're going to put to the left.
Yeah. And if it's a hit, you have to decide, yeah. So every time there's a guess, you have to determine what do you put here? Like how much space do you devote to each side?
Yeah. So then so it seems like then you basically, yeah, I feel like this is going to turn into a problem that's large, where like part of it is figuring out the basic strategy of when should we like hit and when should we miss. But the other part is like it feels like I have a suspicion that a lot of the trick will be making sure that we like get the full 33,333 misses that we're looking for, rather than like 33,332. Like it feels like making optimal use of our space is going to be extremely important.
If we have this DP, can we like use this DP to determine what our score would be for every decision we might make?
Oh, I guess the other issue is
like, or also, yeah, do we have any runtime concerns?
Yeah, so the DP, I think we definitely can't use as a solution to the full problem, because it seems like this is going to take O of n squared space.
Yeah.
So I can imagine like writing a brute force with this to like find the pattern and then implementing that pattern, but it seems like it could, but it seems like writing the DP is like the entire solution won't work. The other thing I'm thinking that like might not be, I guess maybe I guess it could be kind of encoded in the DP. But one thing that I'm thinking about is that if we have, like, for example, a gap of size 1, and we know that it has like 0 hits inside of it, then the judge doesn't need, or we know that it has all hits inside of it, the judge isn't going to need to make any guesses inside that range, because the judge isn't going to risk any misses in that range, because the judge already knows that that if it guessed in that range, it would miss. So in that sense, like gaps of one can't help us generate a miss.
I guess the question is, what is the smallest, like what pieces of information would generate a miss? Maybe this is just the base case of the DP, but
yeah.
So if you have like a 1 and a 4 with one thing in it.
Yep. Then I guess I think you could just say the judge could output either 2 or 3. You could just say nope, it was the other one, and that would get you a miss.
And
so with length 2, you can definitely guarantee a miss if you have, and assuming that you only have one thing to put in there.
Yeah. So I guess, yeah, if you have two spaces and one thing to put in there, or I guess 3 spaces with 2 to put in there.
Yeah. So 3 spaces with 2 to put in there. So I guess like if the judge I think you can guarantee a miss, because you can just say whatever the judge guesses first is a miss.
Yeah.
But now if the judge guesses in the middle, let's say.
Well, if the judge knows this.
Yeah, then the judge knows exactly which one of the others is. Or I guess if it's a miss in the middle, then the judge knows both the left and the right have to be hits. And if it's a hit in the middle, then the judge gets information about exactly which of the other 2 is the hit.
Yeah.
So in that sense, with 3 gaps, and we can force 1 miss, and if we have like 3 things or if we have like 3 hits in there, then of course we can't force any misses.
My initial reaction here is this seems like a really easy problem to get wrong.
I agree.
Because like it seems like the judger could be, or like the judge, like your adversary could do something stupid. And that could be like, oh, hang on a minute, that's
right. It could be harder to react to.
Yeah. Like
I guess like maybe if we can find a pattern where, like if we can find like sort of a pattern where like, okay, with this many, like it seems like we're going to get big O of n over 3 like misses from a gap of size n.
Yeah.
So it seems like maybe what we could do is we just need to figure out like what exactly is the pattern and how can we, and like how many gaps should we have to achieve that pattern? And then that might like motivate us to, that might help us figure out the solution.
So yeah, I guess if we have a certain gap, we can kind of determine how much room there should be there.
Right.
Or how many like things are there. Do we want to just like make a chart of like, if you have 2 spaces, you want one thing? If you have
2, and we have 1 gap,
3
let's say.
spaces, you want 1 gap? Or is 2 okay?
I think with 3 spaces, we want, well, the thing is, if we only have one thing and is gap of size 3, then it has to be like blank hit, or sorry, it has to be like miss, hit, miss.
Oh, so you don't want 1, you want 2.
So we want 2, yeah.
And then you don't,
like,
don't want
any
3,
of the
you don't want
pieces.
1. Yeah, okay.
Yep.
What about for
And
4?
then that's gonna get us 1 miss. So far we haven't done yet, so let's do that now. Let's see. So if we, let's see. First of all, if the judge, do you want to say the judge guesses middle?
I feel like yeah. I mean, one of the middle is probably always the best. I imagine.
I would think so. Yeah. All right. So if it's a hit, then that means like it's going to be able to tell whether the left what about the left one, and then on the right one, we can force a miss. So if it's a hit, then we force 1 miss. If it's a miss, then that means that like the left and the right both have to be hits, and then the situation on the front. Right. So in either case, we can only guarantee 1 miss. Yeah. So we can only guarantee 1 miss, and to do that, we can either have like, I think 2 or 3 will both work. I want to say. Or maybe even. Sorry. Yeah, I think 2 or 3.
And this still gives us n over 3 floored.
That still give us 1 miss.
Yeah. Okay.
Although 2, we got 1 miss with 2, so I guess I would expect like 2, 3, and 4 get us 1 miss each, and then I think 5. I guess I would expect that we'll be able to get 2 misses.
Okay. Let's see.
Yep. All right. Want to say the judge plays in the middle again?
Yeah, it's probably the best.
All right. So if it's a miss, then we get like the information about these 2, and then we also get the information about the left and the right. So in this case, we only are going to get 1 miss.
Yeah, so we have to get a hit and then a miss here and then a miss here.
Exactly. Then we basically have 2 of the n equals 2 situations. So that means we need like 1 thing to hit in the middle, and then we need let's see, 2. How many? Or we need 2 things. So yeah, 3. We need 3 things.
So now the real question is it possible to do, I suspect it's not, but could it be possible to do better if the judge starts here, for example?
Yeah, or like, you mean for the judge to do better?
Yeah, can the judge ever ensure only 1 miss?
Yeah, good question. So if that's a hit, then we can ensure a miss just by like using the 3 on the side.
No, the judge just makes this a miss.
Yeah,
the judge you can always make one of these a miss and one of these a miss.
Yeah, so if we make like the, oh yeah, so that's a good idea. So if we like partition, I think that works. So
hang on a minute. Can we just do this in general?
Yeah, I think we can. So you're saying that if we, nice. So if we like guarantee that, if we like basically guarantee from the start that every like 3rd thing is going to be a miss. Yeah, that works. That makes this easy. So if we like we just like guarantee right off that every like 3rd element is going to be a miss, and then the others, like, we can just go either way. We can just say whichever the way the judge guessed is wrong. That'll definitely satisfy our conditions, and they're like 9. The initial gap has size 99999, so that's going to get us exactly the right number of misses.
That's cool. So it's just anytime they guess a number that's either 1 or 2, you're wrong. It was the other one.
Exactly. Nice.
That's pretty cool. All right, nice problem.
Yeah,
so it's not.
I thought that was going to be way uglier than it was.
Yeah, and then so there's no DP. It's just a greedy. Or it's just an observation. Yeah. That feels good. It's a good problem. I like it.
Yeah.
Very satisfying.
Again, like, it seemed like it was going to be really involved, and then it wasn't.
I wonder,
if you don't mind, I'm going to switch over real quick to the scoreboard for a moment, just to give my stream a little bit of an update.
Sounds good. Am I still going to be audibly there?
I think that your audio won't be there, so
okay.
Give it just a moment.
All right. I'll cut you off too then.
All right, let's see. Hopefully everyone can still hear me. So let's see. Hold on.
All right. Yeah, not sure if you'll be able to hear. Oh, okay. I'll be quiet then. Okay. All right. Yeah. Quick scoreboard update here. So, one of the things that I really want to ask Geothermal about is why do you only use 2 segments? Not sure what you mean. Yeah, it is. Well, remainder module 3 kind of, but I hope you guys saw what we just stumbled upon. If you're watching, because that was pretty cool. The idea is. Oh, I'm sorry. Yeah. So now I'm muted. Okay. So yeah, I've muted him as well. Yeah, one of the things I want to ask about is if there's going to be a scoreboard effect here. Because this K problem, it looks really hard, but it's one of those things where I don't think it actually is as bad as it looks. And I think if you're in a contest where lots of people solve it, you realize that it's not actually that bad. If you're in a contest where everyone stays away from it, you think, hang on a minute, this is going to be a big pain. So, yeah, I'm interested in what happens in Big South. Because if it ends up being very different from what happens in Pacific Northwest, that might be why. Because it looks like it's really hard, but it's not. Yeah, scoreboard update. UBC crushing it with ACs on D. I is brutal. Holy cow. Yeah. Wow, I is a big difference maker. Whether or not you can get I is going to be a huge part of the contest. And then D as well. Which one is D? Cramming for finals. Haven't looked at that yet. Yeah. So UBC is kind of running away with it. They've chosen not to go for B. Berkeley in second place with 8. Pretty solid penalty points. Yeah, not in too much danger of getting passed by 3rd or 4th place. And a solid first place from Berkeley. The one thing they really want to worry about is getting beat by the other Berkeley team, and it looks like both of them would probably need at least 9 problems to be able to overtake them, which means, I don't know, one of the hard ones that Return of the Sleepwalker doesn't get. We have a submit from Berkeley happening right now on K in 16th place. Let's see. It looks like that's an AC, moving them up into, I think, 12th place. Oh no. Yeah, maybe. Yeah, 12th place. Stanford with an AC, Stanford quad with an AC on K as well, moving them into 11th place. And it looks like we're still having a bloodbath on C. Lots of wrong answers there. We have 12 wrong answers from null hypothesis. You may remember null hypothesis from an earlier set. I don't know if it's the same group of people exactly, but it's definitely a team name we've seen before. We have here for the t-shirt, at least they're honest, from WSU, Washington State University, I think. And yeah, it looks like almost every team has been able to get on the board here. Hopefully BYU Hawaii is able to figure out whatever their bug is on M. M is, of course, the 7 problem with the 3 wheels. You want one 7 on each of them. I believe in them. And I'm not sure if super long downtime is here, but if they are, they haven't made any submits yet. Lots of ACs though. Happy to see that, and I'm proud of the judges for having very manageable problems for both L and M. I think it makes for a good set. Let's take a look at Div 2 as well. So in Div 2, looks like we got the first half is much easier than the second half, and second half might be the shared one. So we have an AC on K, a couple ACs on K, some dark greens there, or with one dark green, as always. And not too many wrong answers. It looks like A is the most frequently wrong answered problem. Small spattering and 20 wrong answers on problem B from half Asians. Welcome. We've got Geothermal here. We just talked about the interactive one. He can't hear us. We're muted at the moment. But yeah, we Here you go. Here's this for you. Yeah, we just solved the interactive one. It was a good problem. It's a lot easier than we thought going into it.
What is your opinion of the problem quality? Like cute or bad or?
For that one,
Yeah.
I thought that was cute. That was really good. It's probably my favorite one I've seen so far.
Yeah. So I know that I think Jay probably was talking about how in like the Big South and whatever they're like not getting verdicts.
Is this is this the
It's
scoreboard effect?
It's not the scoreboard effect. There are like there was a
Wait, when you say they're not getting verdicts, is there like a system issue?
there was a misconfiguration and we weren't we've been working on fixing it internally. So I think they should be getting verdicts any moment.
Oh, does Jay know about this?
I don't
Can
know
we
if
let
he
him?
knows.
Can we let him know real quick?
We should probably if you want to let him know.
Hey Jay, quick announcement here. Sorry, we'll go back to ourselves in a minute. I don't know if you're aware, but for the interactive problem that we just talked about, yeah, that's what I'm hearing from Chief Judge Nick over here.
Yeah, I got involved. I got pulled into it because I helped prepare this problem, and so there was just there was some misconfiguration, and so I had to do some last minute. I was coding actually for the last like 30 minutes to fix things, but the problem should be working properly now.
Yes, sorry, was I muted? I don't know how you heard me. Okay, how do let me pin this real quick. Now I'm full screen. Why am I full screen on my own Zoom? Give me 1 sec here. Been a minute since COVID, hasn't it? All right, I'm back alive. All right, yeah. So which problems do you want to talk about, Jay? We got, yeah, one of the interesting ones for us is cramming for finals. Do you have that? Let's take a look at it, yeah. I'm happy to. Oh boy. So we've got some distance things going on. All right. It's final exam season for Ashley. Oh, and Ashley is heading to her favorite library to cram for finals. The library has a dedicated floor for studying where there are rows and C columns evenly spaced. Each table has only room for one student, and some students have already arrived and claimed their favorite tables. Because the floor is usually very quiet, it's possible to hear sounds from other students who are nearby. For example, frustrated typing on a laptop keyboard after they've gotten problem K incorrect. Or specifically, one student is studying on table row I and column J. Another student stabling another column. You can hear them if their distance is less than or equal to D. So basically, if your Euclidean distance is less than some amount, you can hear the other person. Okay. With this, Ashley wants to find an empty table where she can hear as few other students as possible. What is the minimum number of students she can hear if she picks her table optimally? So, the important part of the question, what are bounds? And R and C are what?
if the number of tables is really large, then we can guarantee that Ashley will be able to find a table where she can hear no other students, just simply because like if R is 10 to the ninth, for example, then 1,000 students, each of which can be heard over a distance of 2,500, can only cover a like total horizontal length of 1,000 times 2,500.
Mm-hmm. Yeah, it's a good point. So we know.
So in that sense, we can perhaps
like R and C
bound
are
R and
almost
C.
like 10 to the 6.
Right. And even then, like if it's 10 to the 6 by 10 to the, it seems like we can probably also do some kind of area bound, perhaps, where like but anyway, so we can think about it, but it seems like at least like doing a big O of R solution should be feasible.
So how much area is each circle? Like,
Yeah, we can always like
2,500
approximate it
squared?
using a square, so about like 5,000 squared.
Yeah. So that is kind of a lot.
Yeah, I mean, if 5,000 squared times 1,000, that's gonna, and then like if we, and then either our, although I guess the issue is like it's not clear that that's actually the number of tables that will, like some of the radius might not cover, or some of that area might not actually cover the tables, but if we assume that it all does, then we know either R or C has to be less than the square root of 5,000 times 5,000 times 1,000. Which is about like 5,000 times 30 or 150,000.
And can you only sit at an integer space, like a lattice point?
Yes, it looks like that. So,
Okay.
yeah. One thought, let's see, what's the time limit on this, I wonder? So it's 4 seconds. So what I wonder is, could we just do something really simple where we figure out like, okay, if R and C are both larger than 150,000, then the answer must be 0 because we know, or like about 150,000, let's say.
Mm-hmm.
Then the answer must be 0 because we know, sorry, I can't talk because we know that the students can't cover enough space to actually like hit every table.
And if it's smaller than that, you can brute force whichever's smaller, the row and column, and like or I guess just always do the row, and then process every student.
Exactly. So for each row, we can figure out what interval each student's range covers. And in fact, each student, and that actually should or maybe we don't even need to do this like square root observation. Maybe what we can do is we can just say each student is only going to be relevant for at most 5,000 rows. So that means that the sum over all rows of how many students are relevant is going to be like at most 1,000 times 5,000 or 5 million.
Oh.
And so that means we can sort the students by row. We can like insert students as they become relevant and drop them if they stop being relevant. As soon as we reach a row with no relevant students, we can just say, okay, the answer is 0. We're done.
Yeah.
And that way, even if R and C are large, we're going to be okay. But otherwise, we can just figure out like we can then like for each of those students, we can solve kind of a sub problem where we figure out like the range for each of those students, and then we do like a separate, I don't know what to call it, like whether it's sort of event processing thing where we like sort the endpoints of like where each student comes in and out of our range, and figure out the minimum number of students that can be heard for that.
This simultaneously to me seems like it's both very difficult to do a more general solution than that, and then also the bounds are set very low, which makes that suspiciously accurate.
Yep.
Are we right on track here?
Should I spoil everything, or do you want to keep
Well,
talking?
if the answer is just yes, then
All right, let me give the judge's perspective here. So indeed, you can, based on the given bounds, like R and C being large is kind of a red herring. Although none of the judge solutions explicitly looks for 0 in that fashion, you can just kind of, or at least mine doesn't. Maybe
so let me ask, if D were bigger, would this be impossible?
If D was bigger, like our solution does depend on the fact that D is small.
Okay,
yes.
yeah, all right.
Our solution is like O of n times D, and I think there's probably a log n factor in there somewhere.
Well, I think that's what mine is doing as well.
Yeah. So to sort of spell out the solution sort of in detail, we're going to do a line sweep over the plane. And so, as mentioned, a student is only relevant for at most 5,000 rows. And in fact, the only sort of interesting points for a student are the ones that are on the circumference-ish of the circle.
So like the highest or so like for each row, the leftmost and rightmost points of that row that intersect the student's range
Yeah.
is all that you really care about.
Yeah. So you can compute all these intervals, and then you do a line sweep, and then you have the sub problem of you have all these intervals, find an empty one that find an empty slot that touches the minimal number of intervals. And then the only thing you need to do is if you ever see that the answer is 0, you just stop and print 0 immediately.
Yep, that sounds like I guess exactly what I was trying to describe. Yeah, so this I guess is a good example of a problem that is maybe a little bit easier than it looks, just because the 10 to the 9 bounds are really scary, and then it turns out, just like Nick said, they're a red herring and you don't actually need to think that hard about them.
Yeah, it makes sense.
Sorry, go ahead.
And this
David?
only has, looking at the scoreboard, this only has one solve for us? Very recently,
yeah, for us
too.
it has 3 solves. Let me see which teams those are, but I bet if I was the top team, oh wait, maybe 2 solves? Hold on, let's have a look. So UCF Apocalypse Attack and Maryland White have both solved it. Yeah, go UCF, and then no one else. So yeah, I would hope at least that the North America Championship level teams are going to be looking at this one before too much longer and giving us some thought, hopefully attacking it in the last 2 hours of the contest, because I definitely think that for a team that's like at least a team in the top 2/3 to 3/4 of the NEC pool, I would think this would be a very approachable problem for them once they spend a little time on it.
And you're certainly right, but I'm going to play devil's advocate here. To a lot of teams here, this
leaderboard effect is you about to say?
It looks like leaderboard. I was going to say leaderboard effect for K, actually. I mentioned that earlier, but the big one is the geometry effect. It looks like geometry. You have circles, you have intersecting circles, you have lattice points. It looks scary. So a lot of teams, I think, are getting scared away from this when really they shouldn't. They could do it.
That's a good point. And we also, the other geometry problem in the set, the one that I think is like probably more real geometry, so to speak, is problem L. And I think that problem has 0 attempts so far. I guess not having read the entire set, I wouldn't be surprised if it was the hardest one in the set, although I think maybe there's going to be some, I could imagine there being like some clever trick that makes it more doable.
Is it segment drawing?
Yes.
Do you want to talk about that real quick? I know it's scheduled for our meeting to end here, but do you want to talk about J real quick and before you go?
Sure.
All right.
This is L for us.
Oh, sorry. Yeah. Segment drawing.
Yeah. Do you want to read it? I read the problem quickly earlier, and I thought about it a little, but didn't have a ton of immediate ideas.
I'll read it real quick just in case. This is
it.
geothermal, by the way, but yeah. I'll read it real quick. So segment drawing, you're given some points paired with an equal number of line segments. All points are strictly above the x-axis, and each line segment lies completely on the x-axis. None of the line segments share any common points. So you have disjoint line segments and you have points above the x-axis. You would like to draw some new line segments for each one for each given line segment pair. The ith drawn segment must connect this point to its corresponding segment. Okay. And the corresponding point between the between point I and line segment I is fixed. You cannot rearrange which point connects to which segment. Otherwise, it'd be easy. You just sort them and then go left to right. No 2 drawn segments may strictly intersect, but is allowed to have one drawn segment touch another at an endpoint. You'd like to find the minimum total length of all drawn segments, or determine it's impossible. Oh, minimum length. Okay. Determine it's impossible to draw all such segments. So it could definitely be impossible.
Right. If we have 2 points where the line segment for point 1 is to the left of the line segment for point 2, but then point 1 is to the right of point 2, and they're at the same like y value. Oh yeah, you can draw, that'll be better. Then there's going to be no way to avoid the segments crossing. Yep, exactly like that.
So I guess first question is it possible? We have to solve that anyway.
Yep. I mean, for this example, obviously no.
I guess, yeah, one thing you're interested in is like this space. In this space.
That's a good point.
Like those are your choices.
Right.
If you ever have yeah, since they never cross, is the best you can always, if you make them as long as possible, does that always, oh, it might not for weird reasons.
Yeah, I mean, I guess like for any, this is interesting. I guess like so if like they had, I think the main interesting case would be if they had different y values and then one can sort of go over top of the other.
Yeah. But the topology is kind of interesting, right? Like you know the order of the the order of the segments that you draw on the bottom. Always.
Right.
Because these never intersect. So you know, for example, blue will always be to the left of white.
Mm-hmm.
Okay. So yeah, I mean that's maybe that doesn't mean much, but
yeah, I mean, I guess we know that. I guess like we know that the fact that blue has to be to the left of right means that like, or it sort of limits the set of segments we can draw for blue, right? And in particular, the set of segments we can draw for blue doesn't depend on which segment we draw for white, because blue just has to like, blue can use any segment that will go over top of white, and then it'll be fine.
yeah, exactly.
So like I sort of wonder if there's just going to be some like angle sweep thing going on here, where like I guess what I'm wondering is,
it's like
will there be a case where like what blue segments we can use depends on what white segment we use, or vice versa?
Well, so like what are the requirements for the blue segment here? You have to go over. So for all of the things that are above you, you don't affect it.
Yep.
For all the things that are equal to you, you can't affect it. And then for
right,
all the things
or else if you can't affect it, then the answer is automatically no.
Yeah, exactly. And then for all the things that are below you, you don't care which direction they go, because
right,
you either have to go to the left of them or
point.
to the right. Yeah.
Because your ending point is going to be either like strictly left or right of theirs.
The direction you go is determined by where your segment is relative to them.
Right.
Is n
so
big?
It seems like then.
How big is n?
100,000.
Oh, that's where it's hard. Okay.
Yeah. I mean, I guess like theoretically though,
but like right now we have an n squared, right? That's pretty easy.
I would think I think so. Like, because what you're saying is like all the bullet points below it, we just need to make sure that like I guess that we go like to the left of any of the points that belong on the right, and to the right of any points that belong on the left.
Yeah, exactly. So your blue, you have a left endpoint and a right endpoint. So right now,
yep.
Your requirement is you have to be over here and you have to be over here. And then for every
so
point,
all of the
sorry.
So like basically we like start with, I think like it might be helpful to think of these in terms of angles that the line makes. And we have like sort of a range of angles that we can start with, just determined by the endpoint. And then each additional like point that we have gives us another bound on the angle that we use.
Exactly, yeah. And you just do a for loop for all the things below you, and then you get like a new requirement for each of them. And then your blue things are here, right? And now your point is here. Like, so once you're done, you know this area here satisfies all the requirements, so you pick the closest one to your segment. Or your point. So now the question is, how do we make it fast?
Yes.
Which is a good question.
You were a geometry. Were you a geometry person on your team?
I was. Yeah. So
yeah, that's what I thought. I was very explicitly not the geometry person on my team. So this might be more of a you problem than a me problem.
Let's I'm feeling ooh.
Wait,
this is a convex hole problem. It's a convex hole problem. This yeah. So let's imagine you have a convex hull, right?
Okay.
And you want to know the thing that's farthest, that's tangent to this,
Yep.
and that's going to be your most extreme. Like you have a clock pointer, and you want to rotate it down until you hit the tangent thing here. Until you hit it.
Interesting. Okay, hold on.
And these are all of the things that come after you. And then you'll have another one for all the things that come before you. For these ones here. So all the white segments that come after blue, and all the green segments come before blue. And the green ones have their convex hull, and these ones have these. So you'll have two requirements, which are that one.
Yeah.
and
So you'll
this
do
one.
like so you'll do sort of like you'll sort of do like a left to right and then a right to left processing of the by segments.
Exactly. Yeah. So now the operations you need add to convex hull.
Yep. Which you can do.
It's a huge pain, but you can do it. And then you need tangent point to convex hull, which you can also do. If you have the left, you split it into two halves, left half, right half. But I fully understand why no one has solved this. Yes, because it's a big pain. Are we right?
So this might be this reminds me a little bit of the East Central NA, or not East Central, just the East Conference. I guess East Central from from last fall, where the last problem was a geometry problem D that, like, on its face the algorithm to solve it was not super involved, but then just like implementing all the details and getting it right was a massive pain.
Yeah, absolutely. All right, real quick, are we right? Is this the right idea? Do you have convex hull in your answer?
I do not.
What?
In fact, so we know that there are solutions that are based on like decremental convex hull techniques, and everyone that I have talked to, like, I think that's like their first instinct, and then they're like, you are cruel people. Why did you put this problem on the contest? But there is actually a very simple, not even really that geometric solution. Like, this problem is geometric, but I would say that the amount of geometry that you need is virtually non-existent. Hint, hint. So
geothermal's got to go in a sec. So let's not. Can you give us a little more explicit?
I'm not in a huge rush. I don't have like something else going on.
Okay, so let's consider looking at the segments from left to right. So let's just look at like the leftmost segment, and you just like you have the point, and it exists somewhere.
Yeah.
So I think the claim is, and I might have mixed up the directions because I've mixed this up in my head many times. But if you take like the point that corresponds to the leftmost segment, and it is possible to connect them. It is always possible to connect the leftmost point with the like left endpoint of the segment, right?
Yep, I think I agree with that.
Okay, so now the question. So
we sort of want to figure out like how close we can get it to being a like straight down segment, right? Like,
well, we don't even need to think about that necessarily. I think the question to think about is like, what is the rightmost point that we can connect it to? So ask that question instead. So ask, what is the leftmost point on the segment that you can get to, and also what is the rightmost point that you can get to? And that might be the empty set. If that's the empty set, it's impossible. Otherwise, the sort of the crucial or a crucial observation is if you can hit the left and you can hit the right, you can hit anything in between.
Yeah.
Yep.
So now you just have to ask, what is the left and what is the right?
But this.
Yep.
Like, how do you do this fast? Like.
So
like yes, I see you can do this, but where do you remove the factor of n?
Let's start. Let's loop over the points from like in left to right order by segment, and then you maintain a stack of your points. If there is if your current point in the stack is like above you, then you ignore it. You can ignore it because you're going to repeat this process again.
Real quick, what is this like? How are we sorting the stack?
The
stack is left to right.
You're looping over the points in left to right segment order.
Yeah.
And so the order in the stack is obviously fixed.
And
so
when does that in the stack?
I'm going to describe that.
Oh, yeah, go ahead.
So you take a current point and you look at the point on the stack. if the point in the stack is at the same height or lower, you can do some math to figure out if this impacts your current point.
So like, let's say we're gonna add this yellow one, right?
Mm-hmm.
And we have the pink and the green on the stack.
If we're looping from left to right, then the orange point doesn't interact with anything, right?
Which ones are the pink? Here?
The orange point doesn't interact with either the green or the pink and present, right?
This is orange?
Yeah. Sorry, I see
yellow.
green, pink, and orange. Maybe
Let's call it yellow. Let's call it yellow.
Okay. So like imagine that the pink point was like further to the right, and then the orange point was like to the left but above it a little bit. Then you can get this like, then you get this effect where the point, like the closest way to get the point to touch is that the point ends like the orange point, it touches the pink point on its way down.
Yeah. So, but what is the stack?
So the stack at this point would be like the green point and then the pink point. And so now so these points are like potentially constraining. Like these points can potentially constrain where you are. Because these points are already like to the left, you have to make sure that when you draw your line segment is always to the right of those points.
Oh, and this is always going to be a convex hull, and that's why they're the same.
Yeah.
Yeah. Makes sense. And
So
what
wait,
if-
hold on. So how are we deciding like when to add and pop things from like I guess like the I think like the one part I don't understand is that like what we're sort of saying whatever point is at the top of the stack is the one point that we need to be careful about. And I guess I'm still not clear on how we're determining which point that is.
It's the same stack that you have when you do convex hull,
Okay.
because it's like the potentially constraining points.
Yeah.
So like if you have this yellow here and you add this yellow point here, this pink point is no longer in the convex hull, so it's no longer
Right.
ever going to be constraining.
Nice.
Yeah. So you don't need this weird like convex hull addition thing, I don't think. Yeah.
Cool.
Like I mentioned. Before you go, Geothermal, thank you so much for joining. We have
Thank you.
some people in the chat congratulating you once again on your LGM status, and I would like to do the same as well. So well done, congratulations. I hope one day I might make it there. It's
Me too.
dubious, but well done.
Thank you very much.
All right, we'll see you around. Thanks so much. Have a good
Good
rest of
seeing
your
you,
stream.
David. Thanks.
Bye bye.
Bye.
I think we're in. Oh.
All right, can we show this one?
Yeah, that should be I think that's the frozen scoreboard now. I think we've passed the 4-hour mark. Or no, wait, no, oh yeah.
Not yet. We have
Oh,
another hour, think. One more hour.
1 more hour. I got very confused. I was like, huh, but this is fine. I got my time zones all mixed up. Maybe I'm in Hawaii time.
Do you know if Constantine will be coming soon?
I can message him right now, actually. He was doing the open contest and telling me about some of his thoughts, but let me see. I'm gonna message him right now.
If you want to go grab him, that'd be great. Then I'll take a quick break. You can talk to him for a bit.
Okay, yeah.
Okay.
Yeah, I'm messaging him. He'll probably need a couple minutes to get wrapped up, and then I can go find him.
All right, sounds good. We'll do a quick scoreboard check in the meantime here. Take a look at what has changed. It looks like, oh my goodness, UBC is running away with it. 11 problems. 11 problems by UBC to 8 problems by Berkeley. And then Stanford Cardinal has D. It looks like UBC figured out what were they getting wrong? I guess they weren't getting B. They finally got B. They took the time to do it. D is still paying off handsomely for them, and they also have G, which we haven't even looked at. So well done to UBC. Congratulations on the fantastic start to a performance. As far as whether or not they'll be able to hang on, we'll see later, but great start. Berkeley also is doing pretty well. 8 problems with 400 penalty points is nothing to laugh at. Because no one else will be able to pass them with 8 problems. So, but there are also 2 hours left in contest, right? So there's a good amount of time for things to happen. They also have had wrong answers on I and J. the 4 wrong answers for a 5th submit might not be helpful. And we got another submit on I quite down the scoreboard from another UC Berkeley team. The Berkeley Ballers. Berkeley Ballers had a wonderful start and then have had quite a few wrong answers and giving them a not amazing penalty point for 5th place, despite how well they started. Also, it's got to be pretty frustrating just to spend all that time working on a problem and get it wrong a bunch of times, because then so much of your contest is spent just debugging rather than working on new potential things you could maybe solve. What else? We have Stanford Cardinal in 3rd, 7 problems, pretty good penalty. And Berkeley, another Berkeley team, in 4th, probably the biggest challenger to potentially prevent 2nd place Return of the Sleepwalker from qualifying for NAC. You'll notice on the scoreboard here we have different stars for people's performance in getting the dark green, as we call it in Hacker Cup. Welcome, Nick. We got Constantine. All right, we got some visitors here. Welcome.
Hello.
All right, let me show you how to do this so you can hear yourself with this. There's your mic. Is Nick coming?
Oh, he just left. He brought me here, so.
I guess it's you and me.
All right.
How's it going, Constantine? How's your contest been?
Well, Stanford is not doing that great, so could be better, but okay, I've been
In
trying
3rd place here?
Yeah, I've been trying to implement some problems, but also I haven't looked at that many problems because I've been trying to implement the things I solve, and then I have lots of bugs. And
Which ones have you been thinking about?
I mean, I did like A, C, L, M, K, but I had a bug in A for a long time, and
K,
now,
the interactive one?
yeah, and then now I have a bug in K. Like I solved it immediately after I read it with a similar solution to what you had with geothermal
Okay.
that I later had on the live stream, but somehow I just have a bug. I don't know.
Oh, darn it.
Printing something in the wrong order.
It felt really good to figure it out.
Yeah, I think like
I enjoyed it.
when I saw that Stanford solved it very quickly, I thought, okay, like it can't be that hard. But like once you're in the mindset that it's not very hard, it's you come up with a solution.
Yeah, for sure.
So like the numbers are very suggestive, like 3, 3, 3, 3, 3. Okay, maybe I should split it into groups of 3.
Golden State Bears have another submit on C, it looks like. Did they get it? Oh, wait.
Oh, there's
I'm
lots
looking
of things,
at our queue.
Lots of things in the queue now. It was empty for a while. Or
I don't see him on the queue. Let's see. Still running? We're not in the freeze. Sorry, we don't care about Berkeley. We care about Stanford. We got a Stanford coach here. All right, what do you think? Let's talk about Stanford. What do you think Stanford's biggest strength here is? Which problem type?
it probably math.
Yeah.
Yeah, they have a strong new member this year, who's a new incoming math PhD student. So I think they should be. But this contest somehow, at least, it's not very math heavy. It seems like.
I've noticed the same thing. Yeah, it's like very algorithmic.
Yeah, I haven't seen any number theory. Maybe I don't know if there is one, but I haven't seen any.
Could be one of the ones that's just untouched, like E or whatever.
Yeah.
You want to take a look at one of the new problems then?
Yeah.
Constantine?
Yeah, why not?
Which one have you do you know H and I?
I've
Stanford's struggling on them.
I haven't. Yeah, let's look at one of them. I don't. Maybe
Okay.
H. Because you discussed I think a bunch already.
Yes, you're right. Yeah. H is what we thought when we were discussing I. We thought I was H. I thought it was H, but it wasn't. All right. You want to read it?
Yeah.
Go ahead.
An IT company has formed an on-call team of software engineers who will manage their backend services and make sure that these services run without interruption. When services go down, for each service that is down, the on-call team must dispatch one member who is familiar with that service to take care of its issue. One team member can handle at most one service at a time. The company wants to evaluate the robustness level of the on-call team, which is defined as the maximum value of case, such that any case services that go down simultaneously can be handled by the on-call team.
It's kind of the max flow min cut thing, which is what is the fewest number of services that might go down that would break the on-call team.
Yeah. So, and like for every, what do we know? We know for every team member, we know which services. We now have a mask of which services they can handle.
So, yes. Yeah, so for example, you have 4 team members, 6 services, and which ones do they handle? So what is the fewest number of services you would need to have fewer than that number of people pass it?
Yeah.
This is, there's an algorithm for this, right? It's the thing to check if there's a maximal matching. There's like the,
Yeah, so we're looking for a matching between the maximal matching between just the people and the services.
yeah, so you've like, oh wait, is it that simple? If you have something like this, oh. Yeah. So now there are 2 services that can go down that will break you.
Yeah, so you're looking for the maximal case such that for every case subset on the right there is maximal matching. There's a matching that saturates.
Yeah.
There's a matching that saturates that subset, and
Or in other words, the first K that breaks it.
yeah, the first K that breaks it. And I mean, I'm reminded of this. I know it's called Königstheorem or Hall's lemma. So many names where like there is a maximal matching in a bipartite graph. If say that saturates the smaller side, if every subset on the smaller side knows at least this many things on the other side. So can we use this somehow?
We can use a sum over subset DP. If we know we're interested in, for some subset, how many people are... Oh, wait, maybe it's a slightly different problem. Because the person doesn't need to know all of these. They just need to know one of them. Right? You're interested in how many people know... You want to find a service, and it's like how many people know at least one of these services, and it's only 1. And that's less than the number of services, which is 2.
How many people know? Yeah.
Oh, so you want an or? Wait.
Yes, it's just an. It's like how many people have.
So this person wants to. This person wants to update every subset, which is.
We're just looking for the smallest. Are we just looking for the smallest size subset on the right that knows fewer than
many
things on the left? Yeah.
Yes.
That's just what we need.
So then for every person, you need to increment all of the subsets which share at least 1 bit with you.
Yeah.
Can you do this with a sum over subset DB? It feels like we have all the tools, we just don't know how to use them.
Yeah.
Is there a way of phrasing it like any subset of this?
Well, I'm thinking if a set on the right knows more than whatever 20 people on the left,
Oh,
then it doesn't like it's infinity. You
yeah,
don't
that's a
care.
good point.
And if it knows a small number of people, then we can kind of naively merge when we look at bigger things.
Okay.
So like if you're considering some subset on the right, you just break it down as whatever that -1 element and an extra element.
Mm-hmm.
And if either of those smaller sets give you infinity, it's infinity. And if it's small, you can just naively merge and just write down just write down the set on the left that it knows. Just like merge two lists.
Yeah.
So you'll end up with something like
So you process
2 to the 20 times 20.
Yeah. So you process every set in increasing order of bits,
Yeah.
and then you just pick like the first thing, take it off, look at the rest of it.
Yeah.
Well done. We'd be good. So which problem is this? This is H.
Okay, which Stanford solved I, but this is somehow still not solved. Okay, I mean,
I feel like they can do it. If
I
can do it,
think
it's
so.
good,
Like,
they can do it.
I mean, they.
Oh, they just got I
Yeah.
just now.
Yeah,
Nice,
yeah.
Nice.
They did. Okay, this should be something they should be doing. Yeah, but we'll see.
So they get 2 hours or what? Hour and a half left? Hour and 40 minutes because there's delay
No,
left.
hour and 40 minutes.
Yeah. Think they can get 3 more problems?
Yeah.
I think at H for sure, but there just are not that many
I think
problems
they
left.
can get 2 more, although it depends on how hard the rest of the problems are. I haven't read either any of D, E, or J, but I feel like they should get 2 more. 3 more would be a tall order.
All right, let's look at one of D, E, or J then.
Yeah.
See what we can do with them. We've looked at D before, haven't looked at E, and we've looked at J, so let's look at E. Eccentric excursion. Eddie's planning a cross-country trip across N cities. There are N-1 roads connecting them, so you have a tree. Each row connects 2 cities, is bidirectional. The roads are laid out so it's possible, so we have a tree. So Eddie wants to go on a trip such that he visits each city exactly once. He may start or end at any city. It might not be possible to visit each city once using only roads. Luckily, Eddie can travel a flight between... Wait, so visit each city once in a tree is pretty limited. That means you're taking like... That's like a 3... You have like 3 paths from one node. It's the only tree you can have. Anyway, okay. So luckily, he can take a flight between any 2 cities that aren't directly connected by a road. He would like to take exactly K flights during his trip. Okay. So it sounds like you're decomposing a tree into paths here. Maybe K plus 1 paths? So if you can't take any flights, you can only solve a rope.
Yes.
If you can take 1 flight, you have this rope. I guess you can do this kind of. You could do this with 1 flight. You could do and then you could fly over, and then you could do this.
You just decomposed your tree into 2 paths.
Mm-hmm. So for this is 1. So for K, you have K paths.
Yes, so you're just decomposing your tree into K paths.
And what is the question? Exactly. So okay, so you just have to do it. Can you only use a flight if they're not directly? Oh. So sometimes you might want to take a flight, but you can't.
Yeah. So you're decomposing into paths such that the endpoints are somehow not connected. But is that such a big problem?
Like you have to use exactly K? I mean, it might not be that problem, but
yeah. So like the rope you cannot do the rope in No, actually, I don't think
You
that's.
can maybe do a rope.
You can do rope with 2. I guess.
Well, you can maybe do a rope with any number because you can do like 1, 2, 3, 4, 5. But if your rope is length 2, then you're screwed.
Yeah. I get a feeling though that like this is not so much of an issue. You can somehow always reorder, like the once you split your tree into paths, you can reorder the paths in such a way that there won't be flights between those endpoints, because probably it's otherwise not a tree if there are so many edges that you can't do it.
Is there an easy way to find the fewest number of paths a tree could be decomposed into? Is it like an easy tree DP? Oh, they have to be disjoint.
Yeah.
So if you have degree 4, you're going to have to make 2 cuts. But it depends if you come from your parent or not, because your parent might cut you. So I guess it's just DP of...
Maybe you have to separate whether you have a path ending at the root of the subtree, or the root of the subtree is in the middle of a path, because in one case you can extend and the otherwise you have to cut.
Like to your parent?
Yeah.
Yeah. So DP node of like, and then do you go to your parent or not?
Sure, that's one way of saying it. Yeah.
Okay. So this gives us the minimum. That's an ugly problem. I don't have a great idea.
Is this so now we know the minimal number of disjoint paths that you can decompose the...
Yes, we have the minimum number, but we might need to increase it.
Is that not the case that afterwards, like, what are the situations where any number larger than that you cannot do?
Imagine you can always do it bigger than that, but it's not just, is it possible? It's do it.
Oh, okay. Well, okay, yeah, then it's just ugly, but
yeah,
algorithmically that should do it.
Well, do we have an algorithm yet to, like, how do you do this?
Well, the DP probably gives you like the minimal, the breakdown into the minimal. Surely, if it can compute the minimal number of paths, it can also give you the paths.
It can give you what the minimal paths are, but how do you? Is it? I mean, maybe it is, but I don't see immediately how you would increase the number of paths by 1 here.
Well, so you can work like now. This is just a problem on the rope, because presumably, like, you will take these minimal paths and then you will just work inside the minimal paths to break them into smaller pieces.
Yeah.
So
okay.
you can always take, if you have a rope, you can do.
You can cut something.
Yes, and you cut something, and you sort of, you start on the rightmost node in this picture, and then you fly to the leftmost, and then you walk right. Because you have to be careful not to fly through the.
You start on the leftmost, fly to the right.
No, you started on the rightmost.
Yeah.
And then you fly over to the leftmost.
Okay, this only works for paths that are at least length 3, though.
Yes. So if you have a path of length 2, then you cannot increase.
You might. If you have 2 paths of length 2, you can move this one over here. If you have this and this, you can move this guy here.
How? What is the point?
So if you have A, B, and then C, D, you could do A, C, D, B. What would this tree actually look like? A, B. I don't have an actual tree where this would be the case, but C, D, E, if you had something like this. So C, D, E. what we chose was this and then this. These are the two paths, and there's this edge. So before we had A, B.
In the problem, what is the constraint on K? Is there an upper
This doesn't
constraint?
work. 500.
No.
Oh, up to N, less than N.
Oh, just less than N. I see. So when we're working within a rope, we can get it to a situation where we have a bunch of isolated vertices and maybe something of length 2. And then so we can get to a point where we have a bunch of things of length 2 and a bunch of isolated things, but maybe we have to keep going, so we have to and so for the things of length 2, you probably have to do, if you want to increase, you might have to do what you're suggesting here, this sort of swap.
Yeah.
And you can probably do this swap. There's probably always at least one way to do a swap. Like any particular configuration you pick, there could be an edge that you're flying over, but it can't be like you have choices here of how exactly to do this, and it wouldn't be a tree if every choice didn't work. But it is, yeah, I don't know, maybe UBC will get to this, but I don't expect this to be solved.
Yeah.
Unless there is like a nice concise.
All right, I'm gonna go to the bathroom real quick here, Constantine, and you can keep running this if you want.
All right.
You want
yeah,
to?
I'll just sit. Yep.
What do you want? Which scoreboard do you want to look at? Div 1, Div 2?
Div 1 scoreboard.
There we go. So it's up here, and then you also have it here if you want.
All right. No new submissions in the last few minutes. Let's see. Maybe I will read J. Let's see the scoreboard. Maybe D. Oh, this is I think this has been discussed on the stream before, but I will read it anyway. It's final exam season and Ashley is heading to her favorite library to cram for finals. The library has a dedicated floor for studying where there are rows of C tables evenly spaced. Each table only has room for one student, and some students have already arrived and claimed their favorite tables. Because the floor is usually very quiet, it is possible to hear sounds from other students who are nearby, for example, frustrated typing on a laptop computer or nervous leg shaking. Specifically, if one student is studying at a table in row I1 and column J1, another student studying at a table in row I2 and column J2, it's possible for two students to hear sound from each other if and only if the distance between the I1 J1 point and the I2 J2 point is less equal to D. Wants to find an empty table where she can hear as few other students as possible. Hear as few other students as possible. We get the minimum number of students in here if selects a table optimally. And then we have the size of the grid, the number of students, and the D.
We're talking about the geometry one?
Yeah, I started looking at D. I remember you guys discussed it on the stream, but I didn't listen to the solution when you were doing it with Nick.
I can give you a summary if you'd like to hear.
Of the solution?
Yeah.
Yeah. Let me
You want to solve it?
Yeah, I want to think maybe for a minute or two. So there's a bunch of circles with all the same radius, and you want to know the point that's covered by the fewest circles here.
Yes. The lattice point.
Yeah, the lattice point that's covered by the fewest circle. How many circles? There's 1,000.
1,000 circles, each with radius up to 2,500.
1,000 circles, each with a small kind of radius. Is this solved by only UBC, right? I think.
Yes.
So how feels like not that many points matter? Like, why wouldn't I just? So I was going to think about points in the corner, but I guess there can be circles. There can be circles near the corner.
Yeah, I guess you could, if you wanted, have something like this, where
Yeah, okay.
and this could be your grid. And then maybe one of these points here is like a lattice point.
Mm-hmm. Yeah. Okay, 10 to the 9, 10 to the 9. You can't have that many. Like, there's not that many. There's not that many grid points that the circles can all cover.
Yeah, exactly.
Like order. Still order 10 to the 9 though. Of points that can be covered in total by them.
What sound do you think this is? Is this like a stapler? I'm gonna go look. There's a sound that keeps like a motor or something. Here, I'll let you listen to it. I'm gonna go see what it is.
Oh yeah. Not really any more submissions, although maybe these Berkeley submissions are new on problem I. Feels like in this problem we should select some not so large number of points to check, but I don't know how do I make it. How do I pick a small enough number of points?
Sitting here in silence.
Did you figure out what the noise
I
was?
did. Did you see this move?
Oh,
Did you notice this?
no, I did not.
I was this thing moved as me carrying the thing around.
Ah, okay.
Yes. So, as it turns out, these are not helium balloons. These are normal air-filled balloons.
Well, yeah, I guess.
So, this
Put down
is
sticks.
yeah, sitting on sticks instead of strings. So this is a pump that they have going, which is over. It's like over here. They have a pump that they're using to manually inflate these
I
balloons.
see. That's why we didn't see any balloons at the when they were explaining the contest rules.
Yeah, they're not inflated yet.
Yeah, usually there are balloons pre-prepared. Yeah, I couldn't figure out how to get what to do here. Maybe you can tell me.
Sure. So key observation is that things are small. So how many Ys might be hit by all of the people?
Well, like 2 million something. Yeah, like every there are 1,000 circles, and every circle can hit 5,000 Ys. So 5 million, I guess.
So in total, yeah, there are only 5 million like entry removal points. Because like for a certain Y, you start mattering, and then you like will matter for a bit, and then you stop mattering.
Yeah.
So the total number of points here is like 5,000.
Yeah.
And then this is if we count it once per Y. So that's just 5,000 N.
Yeah.
So if we just do this for every Y, it should be fine, right?
Yes.
So 5,000 N log N. If you just sort them all on a Y. Do a sweep.
Oh, I see. I see.
And if there are ever any Ys that don't matter, then it's just 0. Or where there's nobody there, then 0.
Okay. So because like once you cut, only the start and end matter, and then it's easy. And
Yeah.
And you cannot have more than 5,000.
Yep.
More than 5,000 of them. Very nice, but okay, it's a little tricky maybe.
A little tricky.
This whenever I see circles, do you know the problem from NAC 2019? What was it called? I think it was called. Was it called trees? I think it was called. I don't remember what it was called actually, but the problem was just you have a bunch of. You have a set of circles on the plane, and no two circles intersect, and you need to basically determine the tree structure. So like, there's a tree structure where a circle is contained in another circle, and you have to do some like very easy 3DP on the tree structure given by this.
I think it was called this.
Ah, yes, that is what it was called.
What are these things? These are
socks.
Okay, let's not. This is a dangerous game to be playing on a live stream for a word I don't really know what it means. Yeah. So let's draw our own pictures. So you have like these circles, and you gotta like find the structure, right? That's what you're saying.
Yeah. You need to find the tree structure that this contains.
Yeah. We had a similar hacker cut problem with this actually.
Oh, really?
We had it was a hacker cut round 3 problem, I think, from 1 or 2 years ago. Yeah. So we had a problem like this, but instead of circles, it was with polygons.
Aha.
So it was, can you move one marble to another marble if you have these rubber bands around them without any rubber bands ever crossing another rubber band? So it's the same kind of thing where you needed to find the tree.
Oh, I see.
So like, yeah, here's this example on the right is a good. It's like, can you swap the blue and red without ever having a rubber band cross a rubber band?
Oh, I understand. I see. Yeah, okay.
Yeah.
The tree structure with polygons should be harder than with circles.
Yeah, it's pretty messy. And it's big too, so you gotta be fast. So shout out to Meta Hacker Cup. Fun contest.
One of the very few that still exist.
Yes. It's a good one. Yeah, so this one's like you can like cut it in half and stuff. Like there and there, process the upper half, the lower half. Since they never cross, it's nice. Yeah, anyway, don't need it for this, but good idea.
There's like an easier version.
All right, what else do we have? Oh, this is the one we just looked at. This one's ugly.
Yeah.
Ugly. What's item selection? Oh, this is naive
looked at
DP.
it briefly. It seems like
like every page here is disjoint, right?
Yeah. So and like on every page, it's not so hard to figure. On a specific page, it's not so hard to figure out what you have to do.
Yeah. Matrix fraud. Oh, this is the one we did. Yeah. Wait. A binary matrix. Oh, we haven't done this.
Oh,
You want to read this?
I haven't looked at this either.
All right. For, did I just take somebody's water? Oh boy. Now I'm gonna get cancer.
The contestants.
It wasn't a contestant. It was a judge. It was a judge. I don't know who's judge, but that was mine. All right. So we have a binary matrix. A matrix is a binary matrix if all its entries are 0 or 1. A matrix is a banded binary matrix if its rows and columns satisfy the following property. Every row has a 1, every column has a 1, and all the ones in a row are contiguous. Okay. For a row I, if SI is the leftmost column that has a 1, and T is the rightmost column, then SI is greater than SI minus 1, and TI is greater than... So you have something that looks like this. So you've got like... sorry.
Yes, that's right.
And then like this.
And it has to start in the beginning and end at the end on the bottom.
Yeah. So basically you have two monotonic sequences. Like here's one.
Yep.
And then you have another. And they don't cross.
Yep.
Okay. Wait, do they have to be? Yeah, they have to be monotonic. Yep. Okay. Now what's the question? Detecting these is important. Okay.
Do you want to toggle some cells in the matrix to make it a banded binary? To make it a banded binary.
Okay. So how many do you have to toggle to make it? This?
Yes.
Ah.
The size is 200,000.
Not obvious. Well, one of the sides is small, right?
Yes.
So one of them is small. Let's say this one is, how small is small? 300 by 300?
Yeah, I mean...
What is the...
450.
Yeah, okay. So 450 by 450. So we can actually determine, we can brute force each one of these.
Which are you assuming is small? Because it's not quite symmetric.
Yeah, but one of them is small. Let's say this one's small, 450.
Okay.
Oh wait, you're right, it's not symmetric.
There's are two cases of which one's small.
Hang on. No. Cause you can rotate this and it'll still work. Right? Doot. Yeah,
Oh yeah.
you can rotate it.
Oh yes, it is actually symmetric, this structure. Okay. So
Okay.
then it doesn't matter.
So here you can brute force each of the pairs.
Yeah.
So each pair has a cost, right, for these ones. And then a range of things they can hit. Yeah, it sounds like it's just a DP. You just need an order one way to query like a range of things that you can hit. So you need to query everything that's the left is over here and the right is over here. Let's do those colors. So this part here has to be here and the right has to be here.
What is it that you're...
No, right has to be here. And you want the minimum?
No, what is it that I lost you at some point? What is it that you're trying to query?
So we're doing like a DP, which is like DP. Yeah, I think this is the answer. So DP at some LR and then some row. So like left, right, and then the row. And it's if we take this thing here, this block on this row, then what's the minimum number? What's the minimum how much does it take to do this to the end? Like to get from here to this row to the rest of the rows. So that's the DP, the number of the number of changes.
From here to the end, provided that you end at R, end the first row at R. Right?
So what we're saying is like if we need to solve from here down, and this time and on this row we take
LR,
this
yeah.
range.
LR.
Yeah.
Okay. Yeah.
Then what's the minimum number of changes we need to make from here down?
Yeah.
And it's just we are always going to need to make these changes here for the left and right things of this range, and then we need to hit a range that's valid, like that.
Yes.
So we just need to range query in order 1, if we can. So how do we do that? Like we have like n squared things here. We have like n squared new states and n squared old states, and we need to like make this like line these up fast.
Yes.
So to line the things that we have to line up with this, they have to have red in this range, blue in this range, yeah.
So this is just querying on some, like what is geometrically the space on which we're querying? It's just a rectangle, yes.
It is a rectangle, but you can't, can you do rectangle min? It's so the blue is a prefix, so it's always going to be this thing. And then red is a range in the middle, then here. So it's going to look like this. We can just process these one at a time.
You need all of.
Oh wait.
You need all of 1 at this point.
We'd like order 1.
Modulo pre-processing.
But we have a lot of things to answer, so we have like flexibility in how we sort them.
Oh yeah, that's true.
We need like order 1 per answer, but we are answering for every rectangle that looks like this.
That's true. Okay, then, I mean, then surely this can...
Oh wait, this red is not quite like this. Yeah, there's a relationship between the red and the blue. This is also blue. These aren't independent. This is like this, and then this is blue. And this is blue. So actually what we're doing looks like this. Where this is this is a square, is what I'm saying.
Yeah. When that segment grows, how does it change the space that you have to query?
When the blue segment grows?
For example, yeah.
If it grows to like here, then we... So we lose these ones, and then we get... So now we're querying these. So it seems like we need to do each square independently, because there are two weird things that happen. We now include this, and now we no longer include this.
Yeah.
You can't really remove from max.
Yeah.
So if we're doing, like, let's say we have this yellow fixed, then we just want to know for all red endpoints going up, what is their min? What the min? So you have from there, then from this, then from this. I feel like this is really not that hard. Like
you fix the blue, yeah? You fix the blue?
Yeah, you fix the blue and then you do all the reds this way.
and then you do all the reds this way, and
So the question is, how do we get the min of all of these things in order 1? Because we have to add the min of all of these all at once, right?
yeah, okay, but this whole picture is like 450 by 450, yeah. So yeah, so at every like whenever
because every time you expand the square, you update all these mins. That's why.
yeah.
Yeah, when you add a new thing, you just update every min once. But that's fine because you then do a pass through all of them.
I mean, also like this like whenever we finish a row, we can do some pre-processing, and the pre-processing can just be like for every cell, what is the min from the left side to that cell.
Ah, yeah, you're right. Yep.
And then you can build these going up in red.
Yeah. Man, I would have done really well this contest. I gotta say.
It always feels like that when you're just sitting relaxed, like commentating or watching, but then somehow in contest nothing ever goes.
I know. Well, starting in less than a minute, Constantine, we have, in 20 seconds, what happens?
Scoreboard.
Scoreboard freeze. And what does that mean? In case anybody's watching who doesn't know.
That means that now we don't know whether teams will solve things or not. We can only see submissions as pending, but we don't know the results of the submissions until the results announcements.
Indeed.
Hour left in the contest. 1 hour.
Not many changes
Scoreboard
near the
now
top, it seems like.
frozen. All submissions from now on will be shown as pending.
So you just heard the 1 hour remaining announcement. After this, of course, we'll have the scoreboard reveal, during which we will, we personally won't, but the contest organizers will reveal all the submissions that happened in the last hour and reveal who wins the contest. Obviously, UBC is looking quite good.
Yes.
Stanford's in a second, close race between second, third.
Yes, so Stanford still hasn't got an H. They submitted D, which is that the circles? Yes, that's the circles. And it's the return of the Sleepwalker teams made a lot of submissions on I. They were at 6 last I checked. Now they're at 9, but
Still not there.
still no luck.
Which one is J again?
Is there some other geometry, right? I haven't read it, but I looked at it briefly.
Same returning. Oh yeah. The one with geothermal.
You guys
J's tough. It's a tough convex hull one. Like it's doable, but it's just hard.
I have Stanford red that didn't solve problem. It didn't attempt problem K, sticking out in this scoreboard. But they solved problem H.
Yeah, it's true. K, I don't know. Maybe they think K is hard. They don't see the easy idea. Looks scary.
Yeah, maybe. I think that team. Well, I don't know. K kind of feels mathy to me in the sense that it's kind of a trick. So
Yeah, but like if you don't see the trick, I feel like it's really easy to put yourself in a hole of
Yes.
like, yes, I'm gonna do this very difficult DP and like figure out the best way of doing it, and then it turns out it's just like, oh look, there's an easy way of.
yeah. Okay, I think I will head back to the.
Sounds good. Well, thank you,
functions
Constantine,
area.
for joining us.
Thanks a lot.
We'll share the scoreboard once more with you guys and take a quick break. Get some water. Go to the bathroom.
monitor.
Welcome back, Nick. We have an ongoing scoreboard freeze right now, with the final solutions being monitored very carefully.
Yes, I'm monitoring the scoreboard. I have my laptop slightly off screen, and I'm mostly just making sure that we're answering clarifications. We actually haven't had any like game-breaking clarifications. We always have minor inconsistencies that teams some teams will just like really hone in and be like, I noticed a small issue. What did you mean? And we're like, you got us. We didn't catch this in proofreading. But yeah, no major issues in the problems or in the problem statements. So that's been good.
I guess open question for you as a judge: which problem did you imagine before the contest started would be the most difficult?
So I didn't actually think very hard about which singular problem would be the hardest. More specifically, I didn't think there was like a killer problem in the set. So a lot of the times in contests, there might be like that one problem where you're like, oh, no team is going to solve this. If you had to ask me what the hardest problems in the set were, I would have said like easily the two hardest problems were problems E and J. And the scoreboard does show that they haven't been solved yet.
E looks so annoying. Constantine and I were thinking about E. It just looks very,
E is, it's a problem that I think conceptually the solution is not too hard to see, but there are a surprising number of edge cases.
Yeah, no, I mean, yeah. It looks, yeah.
Yeah,
It's like you just need to split a tree up into K+1 paths, right? That's just what it's asking?
That is one way of thinking about it, but I don't think that is...
Well, K+1 paths, and then you have to order the paths in such a way that, like, you couldn't ever combine two adjacent paths.
Yeah, I actually think that formulating it as K+1 paths does not help you get to a clean solution. There may well be a solution that does that, but I am not aware of a good solution that does that.
Drop my water bottle cap. Yeah.
Yeah, the intended solution is just greedy, actually.
Yeah.
It's like we can do this problem like almost purely as a greedy, and it kind of just works out. But you just have to be careful. There's just a lot of there's some casework in there. But,
well, you heard it here. You heard it here, folks. The hardest problem in the Pacific Northwest regional, just a greedy.
There are a lot of greedy problems in our set. Now that I'm
Constantine was talking about how few math problems there were.
Let me look at I need to pull up like the problem set so I can look and see, because with all the shared problems and I'm like keeping track of everything, like it's been hard keeping track of which contest has which problems. Like I got pulled in to help with the Big South regional and got involved there. But yeah, I think we have maybe just two. No, we have three greedy problems, I guess. So problem A, ABC string.
Yeah.
Problem E, which is this hard. I mean, you can do parts of it with DP, but like it is possible to do the problem like almost purely as a greedy. And then problem L, which is one of the easiest. This was the training. This was the.
Oh yeah, where you don't even have a choice.
Yeah.
I would even not really call this greedy. Like you.
I ended up calling it greedy because a bunch of when I proposed this problem, a bunch of people were like, "Oh, you can do this with a DP," and I was like, "What's your state?" And then they started listing a state, and I was like, "Okay, do you want to maybe think a little bit less hard about it?"
Yeah.
And then they like thought about it for a little bit and realized, oh, actually, yeah.
Yeah, no, it's a good problem. I like it. Like it's nice to see that like, hey, this doesn't matter. It's just like I guess it is a greedy. It was like a.
Like you always take the problem if you can. You never have an incentive to skip. So, ergo, like it fits the greedy methodology.
Sure.
We were talking, or I was talking with the judges about like the scoreboard and how it looks. It looks like right now the median team in Division 1 has like 4 solves, 4 out of 13. We think that 4 is like a good number. Like in the past it's been like 3 and that feels a little low. 4 is a good number because obviously if it gets too high, the top teams are going to run out of things to do. And then on the hard end, UBC has been crushing it. They're at 11. And then I see that Stanford and Berkeley both have teams with 9 solves.
Yeah, I gotta say I do like that you had 2 easy problems in Div 1. I think it's good. I think it's good not to have like just one easy problem and then it gets impossible, or even worse, it's just like starts off hard right away. Just because like I don't know, it's good to get the warm up, and like even if everyone solves it, it's still fun.
Yeah.
Good to get people on the scoreboard.
Yeah.
Have a good experience at regionals.
I feel like I feel like some regional contests that I have seen in the past, they do this thing where they're like, oh, there's the perfect contest rule where like every team has to solve a problem. And so what the contest organizers do as like an afterthought is they're like, yeah, we'll just give you a gimme, a trivial problem. You solve one, we still have every team solve one, everyone feels good. But some of the contestants are like, the difficulty curve went from like nothing to like boom, and that doesn't feel very good. And it's very hard to
Like you're
navigate
talking
that.
about like the difference between the first and second problem.
Yeah, like a lot of contests, the difference between the first and the second problem is enormous. And it's very hard to like traverse that gap.
It certainly can be, yeah.
Yeah, I think what actually ended up happening here, well, so I was responsible for the final construction of this problem set, and actually problem M, the 777s problem, that was originally not going to be in the problem set.
For Div 1?
Yeah, it wasn't going to be there. So like the training problem was going to be like the easy one. And I thought about this, and I was like, I don't know, how like it felt a little bad. It was like training is like an easy problem, but then there's not like a second problem that like really stood out to me. I will say I'm pretty surprised about problem A. I didn't expect problem A to get this many solves. I thought it was a little bit harder than that. But I mean, I'm glad that teams are solving it.
I suspect teams are solving it without proving it.
Yeah, so
like I can see it's hard to prove, but I don't think it's hard to come up with that idea.
Yeah, I think that there is a scoreboard effect where teams are like, I'm just gonna try this, and if it doesn't work, we'll try something else. But well, it works, and it takes a little bit of effort to prove it, but it's not too hard to see that the greedy in this one also works.
I mean, like I think, yeah, part of the thing with A is just like the only solution path that I could think of that you would ever go down is like very clearly like the right thing to do. Like you get an A, it's like, okay, where am I gonna put this A? Well, I got to make a new string for it. All right, and then you get a B. It's like, well, I'll just put it with the A, right? I mean, maybe you can make a new string, but like, let's just put it with the A first. And then you get another A, and it's like, well, I have to make a new string for it. And then once you've done that, then it's like, okay, well, it's more or less self-sufficient what to do.
Yeah.
Very small logical jumps.
Yeah. I mean, I'm glad that teams are getting it. Like, even though I thought that the problem was harder than it was, and I originally was like, we're gonna get a bunch of teams stuck at like 2 problems solved. Like I'm looking at the scoreboard, and it's like 3/4 of the teams I think have solved it. Like I'm seeing 46 solves before the freeze. Like if you like, I would not have guessed 75% of teams would have solved it. I would have said like maybe like 50, but you know, I'm glad I was wrong in this case. Like it's good that there was I didn't originally think there was going to be like a third problem that was really approachable, and there was going to be a big cliff at 2. But now there's like problem A exists, and then problem F is also like looks like the next easiest after that. But that one's also a bit of a bloodbath just because of the casework.
All right, so we have I, range editing. I'm just looking through all of them. Segment drawing was J. It was the very tough geometry one with the stack or...
The problem that's not really convex hull, but
Convex
like
hull.
is convex hull.
I think
if
it is
you-
convex hull. Look at this. Look at this. Look at this. Let me show you my convex hull code.
Oh, I mean, I don't.
It literally is a stack. Okay, it's gonna give me GitHub's two-factor authentication nonsense. No, we don't have time for this, GitHub. We don't have time for this. We need our hackpack. Don't two-factor me.
Yeah, I didn't even think of it. Well, the thing is, I didn't think of it as convex hull, but like as I like think about it, I'm realizing that it is. But
Yeah, here, let me show you. Let me show
yeah,
you.
but like convex hull does use this like primitive of, or like there are the convex hull algorithms that do this like stack. You maintain the stack of points or whatever.
You have, here you go.
Yeah.
You've got this stack of points. You sort them by X, just like we did before.
Yeah.
And now you have these points, and then you keep popping stuff off the stack as long as it's not like a new requirement, and then
Yeah.
you just do it twice.
Yeah. It's been so long since I've actually looked at convex hull code because I usually just book code it and never
Yeah.
think about it. But no, it totally. I'm like starting to see it. Oh yeah, other surprises from the judging room. Problem K here. So K was the hardest problem for us to prepare because we had to implement the adversary side of it. So
Yeah, and it's like you could do anything.
yeah, so the adversary, we were coming up with a bunch of strategies, and actually it wasn't the night before the contest, but 2 nights before the contest, we just had extra eyes on it just to be like, oh, what can we do? And we like broke the interactor in multiple different ways. And so we like firmed it up and like added some more strategies at the
What do you
last
mean when
minute.
you say broke the interactor?
We passed with incorrect solutions. Like there were
okay.
there were solutions that were like incorrect, but were able to pass because the strategies were not good enough. So we had to add some more strategies.
Yeah, when I first looked at K, I'm like, oh, this sounds like it's gonna be really easy to get wrong. It sounds like it's like really like weird, but actually it turns out it's not if you get the right solution. All right, L is training, which is
That was the easy one.
easy one, and then we got K. So it looks like I think I understand the solution to all the problems. I'm sure I'd get some of them wrong, but yeah, 777s.
Yeah, 777s was so one thing that you will see if you look at the Division 2 set. I don't know. Did you talk about the problem ordering thing that we did for Division 2, or should I talk about
A little
that?
bit. I thought there was like half and half, but then I looked at it and I couldn't figure it out, so I got confused.
All right. If you open the Division 2 set, I'll explain what I tried to explain to the. But I'll try to explain what I explained to them, but unfortunately something kind of went awry. So what I told the teams was that the problem set was going to be split into 2 halves, the first half and then the second half. And the first half was going to be the easy problems, and the second half was going to be the not so easy problems.
But according to the submissions on Div 2, it looks like that's how they interpreted
Yeah,
it.
so A through F are the easy problems, and then G through M are the not so easy problems.
Did you expect this to be the case in Div 1 as well?
Div 1, we did order the problems alphabetically. So
Oh, I see. Okay. Yep.
anyway, so now if you go back to the problem titles in Division 2, so if we look here, so you can see problem A is cut off, but it's a cappella recording. And so A through F are all in alphabetic order. And then from F to G, those are not in alphabetic order. Like ABC string does not actually come alphabetically after 777s. So what I told them was the first half is alphabetic, the second half is alphabetic, and there will be like one pair of problems that is not, and that is where the swap happens in the difficulty. So here I was telling everyone like A through F are the easy ones, and then G through M are the hard ones. At the time I didn't want to tell them like, oh, it's 6 and 7, but I said, it's obvious where it is, and then a lot of people laughed awkwardly, and I was like, I hope I'm not saying something dumb.
Well, I think
But-
what they may have thought you meant when you said it's obvious is that it's like the questions get very much easier, and you'll be able to tell by what the question says that it's obvious.
Yeah, I got a little nervous, but I'm glad that I think most of the teams figured it out because if you look at the Division 2 scoreboard, it is mostly like you got this big, like, you see the left half is like
Yeah.
A through F are like lots of solves, and then G through M is like completely untouched, and it's not like what other contests will do. So other contests will, they either order the problems randomly, or they like to do like A is easy and M is easy, and they stick the hard stuff in the middle. I didn't want to do any of that. I just wanted to be upfront with them and like give the teams that are going to solve the easy problems, I wanted to give them a bit of a head start. Be like, here are your easy problems. I know you're going to find them, but they're just right here. And then here are your hard problems, but I'm not going to tell you which of them are hard. So in each half, they are alphabetic. So problem A is not like the easiest of the easy problems.
Mm-hmm.
It turns out that problem F was the easiest of the easy problems. And then similarly, in the second half, like I didn't think ABC string was going to be the easiest problem, but it kind of is looking like it.
I gotta say, I'm glad you didn't do this for like Div 1, because this one of the results here is that it feels like you kind of spoil that the easy problems are easy. Like, for example, if you put the place where you put, what is it, K or whatever, the interactive problem.
Yeah.
If you put that in the easy section, it becomes easy. If you put it in the hard section, it becomes a little bit harder, maybe.
Yeah. Like you act like in that situation, you actually need to be very confident in your difficulty assessment. And for easy problems,
it's not even that. It's that you need to be okay with people knowing the difficulty of problems.
right. Yeah, so
Because like in a Div 1 contest, what might happen is like, especially in like an ICPC regional where there aren't that many, like in a Code Force contest, this probably won't happen. But like in an ICPC regional, you might have people stay away from problem K. Like it kind of looked like what was happening in Big South.
Mhm.
And then if that happens, the problem looks harder. So then if you're able to like overcome that, ignore the fact that no one's solving K and choose to solve K anyway, you should be rewarded by that.
Mhm.
But like if you were to split a Div 1 contest into like easy and not easy, then you prevent that from becoming like a cool strategy that happens.
Yeah. Yeah, I think there were many reasons why a Division 1 contest should not have any, I'll call them meta spoilers for the contest. So like I told the teams up front in Division 1, the problems are in alphabetic order. This is what they do at NAC. This is what they do at World Finals. And the implication was that I didn't sneak a problem. I didn't sneak the easy problem anywhere. I just ordered the problems alphabetically because that's the NAC and the World Finals convention.
Mm-hmm.
Sometimes that means the easy problem is A. Sometimes that means the easy problem is M. Sometimes that means the easy problem is somewhere in the middle. For Division 2, I got the okay from folks to experiment with this. Part of it is that you can't qualify for NAC out of this. So I think some teams were able to better take advantage of it than other teams. Like there were some teams that their first submission was not to a problem in the easy half. And that was kind of confusing to me. I was like, oh, I didn't actually expect a team, their first submission was going to be to like problem.
Was it ever right?
It wasn't correct. Like
Okay.
you can actually see, like if you look at the scoreboard, like
Yeah.
the lowest placed team that has a solve in the G through M section is like in rank 20, and no team below that. There are teams below that have tried to solve like the harder problems, but they haven't gotten it. And like I don't know if the teams just didn't hear me at the briefing or what have you, or maybe they just want to try the hard problems. Like that's also fine. But there were definitely like other teams that like took full advantage of this and were like, we're gonna solve A through F first before we even look at like the other problems. And I think that if we gave this information to Div 1 teams, the scoreboard could look really imbalanced. Like if you know that a problem is easy,
Yeah, don't do this for Div 1.
yeah,
I understand for Div 2 is like it's a different, the thing you're optimizing for is different, right? You want people to have fun, you want them to enjoy their experience at regionals, and you don't want them to spend the first 2 hours of the contest getting a headache over a problem that they really shouldn't be working on anyway. But for Div 1, yeah, you don't want to.
yeah. We used to say that Division 1 is like a light version of what they would see at NAC. I don't know if we've actually reached that per se. I would like to think that the harder problems are definitely like quite challenging. Like, yeah, looking at the scoreboard, like we have a healthy number of teams that have solved like 7+. Like we
Seems, yeah. I mean, my gut reaction is it seems easier than NAC.
It is definitely easier than NAC, and part of that is it's still a regional. Like
Yeah.
you're going to have like very strong teams that are going to do well at NAC there, but we also want to have a good problem set for the teams that are like competing for that like 3rd or 4th or 5th slot, and we don't want there to just be like a big cliff, and it's like, oh, all the good teams like are above the cliff and all the not so good teams are below the cliff. We want it to try to be kind of smooth. One thing I will remark is compared to last year, it's looking like this scoreboard has a little bit more of the columns, like the columns of green. It might be hard to pull up last year's scoreboard. I could try to pull it up for you actually.
I think I had it.
Yeah, I can actually just DM it to you right now. I pulled it up. So here is last year's scoreboard that I just DM'd to you on Discord. So if we look at this scoreboard here, once David brings it up, you'll see that there are columns for the really easy problems. So like you'll see like problem C and F and I, you have the columns. Those are the easiest problems. But then like at the top, you don't actually have this like column effect. You have a more like this spread out sort of thing. Like problem B, D, and E especially, they're not like coherent columns. Like if you look at the teams that solve 7, like
yeah, there are multiple, what you're saying is basically there are multiple ways to get into the top 5, right? You had choices about, you had to get like 2 of B, D, E, G.
Yeah. I think
this is interesting.
Yeah,
it's very unusual.
The G was interesting. I think in this contest, because the problems are a little bit easier, I think, and we have like the hard end is definitely a little bit harder than this year. We don't see that effect quite as much, which is okay. I think it's.
Well, I mean, who knows? We might once the scoreboard gets revealed.
We'll see. We'll see. But yeah, it's definitely. Like, yeah, before the freeze and after the freeze, like a lot of things can happen. I don't think I've seen a team do the like funny strategy where they submit to every single problem to hide the problem that they're working on. Last year, one of the Berkeley teams did that. And
Berkeley, it looks like Berkeley could have done this now. Submitted to everything just to hide their submit on E.
Oh, did they?
They made a submit to E and their first submit to I. So the I, they could have, I mean, if I were them, I would have submitted to H, J, and I all at once.
Yeah, maybe.
Of course, that strategy only works if you don't have any, H and J on the deck, and you don't think there's any chance you get them by the end of the contest.
Yeah. That Berkeley team, it seems like what happened is someone on that team decided that, like, oh, they actually think they can solve problem E. Maybe they have someone who just is really good at graph theory and pulled out E. Yeah, G and I are both DP problems, so it kind of makes sense that, well, okay, there is one team, the Berkeley Ballers. They solve problem I, but they haven't solved problem G. They're both actually interval DP problems, so we'll see if they actually end up going for G. It should look it should feel pretty accessible, I would say, to them.
Yeah, Berkeley Ballers had a rough middle of contest. They had like a great start, really rough middle, and looks like they're maybe coming back a little bit at the end.
Yeah, they have a lot of wrong submissions, and I think they're in the they're in the mentality where like they just have to solve problems by any means necessary, and their penalty, they're not gonna catch up to the Berkeley, the OnlyFans Berkeley team. So that team has 9 problems solved with 800.
Do you understand, like,
It's a reference to OnlyFans, I'm pretty sure.
well, yeah, but what? Why is it a joke? Like, what is the other reference?
It's probably
Is it like,
something
oh, really, or whatever?
It's
The-
probably no. It's probably some internal thing. Like they probably have like, oh, it's the bear. I think it's the Berkeley mascot. Maybe it's a reference to the Berkeley mascot. No, that's Oski. Oski the bear.
There's a Wikipedia article for OLY. These are post-nominal letters granted by the World Olympics Organization to registered athletes who have participated in the Olympic Games.
Nah, I'm sure it'll be fine. Yeah, I think it's okay.
Oh, Olympian. That's what it. I get it.
It could be Olympian. Yeah, I
That's
don't know.
it took longer than it should have. Sure, for Olympian. Yep.
Yeah. But if we compare, like, if we look at the Berkeley teams, like, Return of the Sleepwalker, actually they have 13 attempts on problem I, so their penalty, if they solved it, they get like 500 penalty, which puts them, 500 penalty would put them below the other Berkeley team. And because only one team can go to NAC from Berkeley, all the other teams now have to win on solve count. So you have this sort of interesting strategy where like the teams that are catching up, because they're just permanently behind on penalty, they will just make ridiculous numbers of submissions because they no longer care about penalty. They cannot win on penalty, so they have to win on problem solve.
They could lose to each other though.
They could.
Second place could lose to third place based on their 13 submits.
Yeah, but I think these 3 teams, or I think all of the Berkeley teams are probably, they're all trying to compete for NAC, and they're not necessarily trying to compete against each other per se.
I know, yeah, but like, if you're in second place, right, the only way you win is both if first place chokes, you succeed,
Yeah.
and also third place doesn't beat you because you have 13 wrong submits.
Yeah, but that's where it gets tricky. But I think these 2 teams, they still have to solve 10, and solving 10 is already
very, very difficult.
Is going to be rough. Also, if that Berkeley team did solve E or I, then it's pretty much over for the Berkeley teams.
It's also one of the things people don't fully comprehend unless you've been in one of these is how mentally draining it is to work on these things for 5 hours straight.
Yeah.
Especially like with how much stress it is if you haven't like practiced a lot of coding contests, like long coding contests before. Because you have to like slow down in the beginning so you don't burn out all of your mental energy so that you still have something left in the tank when you have 20 minutes left in regionals.
Yeah, and also like if you get a bunch of incorrect submissions in the middle, like you need to make sure that you still maintain your composure and not let that affect you, like in the end. Like some team, like I have seen teams like actually fall apart because they had like 3 or 4 wrong attempts on the easy problem, and then they just tanked even further. Like they lost all their composure, and then they like stopped caring about penalty right after that moment. And like that's like not what you should do. Like you do need to kind of take a deep breath, take a couple minutes to calm down, and just be like, okay, the start of the contest was rough, but it's always the last hour. Like in the scoreboard freeze, like you can clutch out that solve at 299, and that happens a lot. Like you solve that problem at 299.
My freshman year in college, we had another team from UCF Raptor. They ended up being really good. I'm spoiling the story a little bit here, but they went to World Finals. They got a medal. They're one of the few UCF teams to medal. And in regionals, they almost lost to my team when I was a freshman. And we were not very good when we were freshmen, but they were like every practice they'd win. And then the first like hour and a half, 2 hours of regionals, they only got like 1 problem or like 2 problems or whatever. And they just like couldn't do it. And then 2 hours in, they had wrong submissions on like 2 different problems. And then they took a break, reset, and just like grinded through 4 problems in 20 minutes. And then flew up the scoreboard, had bad penalty, but they were able to do incredibly well with that. And of course, they beat all the other UCF teams, made it to World Finals, and did well from there. But yeah, you really gotta that mental shift can be tough to do sometimes.
Yeah. Even though like it feels like the right way to get low penalty is to be fast, actually like being slow can sometimes be net faster because you don't incur the wrong submissions, you don't incur the penalty from the wrong submissions, and you don't incur like the mental.
Yeah,
tax.
the biggest thing that isn't even like it's not even penalty. It's getting stuck.
Yeah.
When you have 13 problems, getting stuck is what kills you because not 1 minute that you spend stuck on a problem is 12 minutes that you don't get to work on the next 12 problems. So that's what you have to avoid.
Yep. We're coming up on, I think we have 25 minutes left in this contest. Yeah, I see 25 minutes on my clock. Yeah, what do we think that these, I'm seeing that there are submissions coming in. Cardinal just submitted they have a submission on H now, I think, D and H.
Yeah, I mean, so Stanford is potentially tied with problems with UBC.
Yeah.
And we know E and J are not out of the picture. I mean, maybe 25 minutes is a little tight, but
yeah, it's gonna be hard, I think. Like J, the solution is deceptive. It's like deceptively simple, but like it is easy to get stuck forever. I'm gonna actually quickly look up how long my solution was for that.
if you have it on paper, maybe 25 minutes is enough if you start like right away.
Yeah, we have yeah, actually my solution's a little bit long. It's at 100 lines. I'm actually a little bit surprised. Part of it is because even though I kind of joked earlier that it's not really like a super heavy geometry problem, you still actually need the like you need to adhere to like the standard.
Yeah, you need cross products. You need vectors. You need.
But specifically, like to be more specific, like if you do everything in floating point, like you will probably wrong answer. So you have doing everything in integers. Like it's not hard. It's just tedious. So you have to encode a bunch of stuff in like fractions, for example.
You have to use fractions?
Yeah, you have to use fractions for it. Like you can't use floating point, so you have to do it exactly. And so when you're doing it exactly,
oh, because of the intersections.
Yeah. So you
that's really annoying. I forgot about that.
So like conceptually, I think it's not hard, but in contest, like if a team comes up with this at the end, they might be like, we just have to use doubles. Actually, long doubles might pass, but if they're using regular doubles, they probably fail.
How big are bounds? This thing's 10 to the 9?
It's 10 to the bound. The x
like
and
the points.
The x and y's have to be 10 to the 6. You can show that you
usually can do that with doubles, right?
So what happens is we had to prove that the integer solution didn't overflow, and so you end up showing that the product you can do like you can multiply like the difference between the x. The numbers can. Sorry.
Like, is the hard part determining the difference between impossible and possible? But
yeah, like you have to compare
barely.
two fractions, and the numerator on the fraction can be at most like x times y, and the denominator can be at most like x. And so to compare two of these, in order to compare those exactly, you have to do like the a times d, like a over b compared to c over d. You have to compare a times d and b times c. And so in order for that to not overflow 64-bit, we had to keep the x values, x and y small. So x and y are at most like 1,000,000. But we can still break doubles with that. And yeah, we don't want to use
doubles. Do you have adversarial tests?
We did break some double solutions. I think there was one double solution that someone couldn't break, but we do break some. We were able to break 2 doubles submissions.
Gotcha. Looks like we're seeing quite a few more submits in Div 1 happening even now. They're by Berkeley and D. Different Berkeley team though, I think.
Yeah, Berkeley is having yet another strong showing. Like last year they had, it was like 3 or 4 teams in the top 5. I don't remember exactly. And this year they currently have like pre-scoreboard freeze.
They won last year.
4.
Right?
Yeah, they won last year. Oh, this year they only have 3 in the top 5. It's OnlyFans, Return of the Sleepwalker, and Garl, Jim, Green Book. I'm looking at the other 7s. We have, I think Broken Heart is University of California, Santa Cruz. They don't have any pending submissions at the moment.
Well, so, okay, they do have 3 in the top 5 this year, but it's also, as of the freeze, the bottom 3 of the top 5. Yeah.
And at this point, no team on paper like based on the current submissions, UBC wins because no
Yeah,
team has
yeah.
submitted to 12 problems.
Well, that's why the contest isn't over. There are 22 minutes left.
Yeah.
Can't can't call it now.
Yeah, I'm curious about the NAC. I didn't actually think about the NAC cutoff threshold. I feel like I should be because that's part of my job as like the contest construction. I didn't actually think about
like
it.
teams also probably know, at least the top Berkeley team in Stanford, that it doesn't really matter when they submit.
Yeah.
Like whether they submit now or they test their solution for 20 minutes and then submit at the end, it's probably better to do that because it's not going to affect whether you get first or second place, and, like waiting that amount of time, and it won't reveal to the third place team or to UBC which one you're working on. Maybe that doesn't matter. Maybe it's too late.
Yeah.
But
yeah, the Stanford team is definitely in a much more comfortable spot, I would say, than the Berkeley team. Stanford Cardinal is the current top Stanford team. They're at 9. And then the next Stanford team is Stanford Quad. They have 7 solves.
7 or 8.
Yeah, they have 7 or 8, but they definitely don't have 9, and they need 10 minimum to have a chance at beating Cardinal.
Yeah.
Whereas for Berkeley, it's closer. Like right now, like the return of the Sleepwalker team, if they actually solve their problems and
Oh, you're talking not about winning, but about being first for your school.
Yeah, I'm talking about NAC thresholds now
Yeah.
because I think at this point, like the probability of beating UBC is slowly. It's already low, but it's
Well, I mean,
getting
like
there.
Stanford, if they get J or E.
Yeah, and
I
if
mean,
UBC
it's-
doesn't submit.
Yeah, I mean,
But,
yeah. I guess
yeah.
if UBC has something on deck, then UBC wins.
Yeah, UBC could be doing the strategy. Like they could be thinking like, oh, we're not even gonna submit until the last minute because they're gonna stress test. They don't need to submit it because, well, UBC is definitely going to NAC at this point, right? Like there's no like you
can't.
Yeah, at this point, I think it would be crazy if like the RSK team.
No other UBC team is gonna get 12 problems.
Yeah.
Like I don't want to not to spoil it, but it's just not gonna happen.
Yeah, that's definitely pretty hard. But yeah, it's looking like UBC. So UBC, Stanford, and Berkeley at present look like they're going to be sending teams. There's UCSC, the Broken Heart team, also with 7 at the moment. It looks like they're slated to be in the 4th. They would be a 4th slot for NAC. It looks like. There is SFU Lavender actually. They have 6 solves.
Not to interrupt, but my real question is, what has UBC been doing for the past 100 minutes? They haven't made one submit. Their last submit was 172, right?
Well, there is the strategy of.
So it's almost halfway through the contest. It's 20 minutes after contest midpoint.
Yeah, well, I mean, we'll never know. Like, maybe they won't tell us. Maybe they're stuck. But maybe they had solutions, and they're just testing them, and they don't want to submit until 299 to leave us in suspense. I don't know. There could be any number of things.
Yeah.
But they haven't submitted, and
I'd be interested in like whether they're just like getting really upset at E not working, or whether J is just a massacre and they're like, wait, no, it's doubles, we gotta do this or what. But
I think it is very possible that
I'd really like to be a fly on their table right now. Like that, I'd like to hear what's going on.
I actually do. I'm going to take a quick look at the Berkeley submission to problem J, because that one I am a little curious about, because I want to see
did they get the impossible case wrong? Was that it?
Let me take a look here. View source. I see doubles. That is already.
That's it. Yeah, like what did they get? What did they get wrong? Was it they said like something when it was impossible?
I need to. In order to do that, I have to like run it. I have to like.
Oh, you don't have okay.
I'm gonna run it now, and it's gonna tell me, and I'll see like what happened. It failed some case. It gave big number, and it might be they printed a number that is slightly smaller than what is possible.
Yeah, I guess, I mean, there are other things that could cause that, right? Like if you have 2 points that are like on the same line,
yeah,
could be an issue.
I'm looking at their code, and It looks like they only. Oh yeah, their code is doing. They're trying to. They only look at like adjacent pairs of points on segments. So they say like if you have like 0.1 and 0.2, like 0.1 can interfere with 0.2 and 0.2 can interfere with 0.1, but they don't consider the case where like
0.1 interferes with 0.3.
Yeah, 0.1 and
Yeah.
0.3 interfere, and so because of that.
Wait, really?
Yeah, they don't. I looked at their code. I saw like an I and then like an I -1 and an I +1, but I don't see any.
Seems like kind of a hard
else.
thing to miss, but okay.
I think it's like a Hail Mary sort of submission, right? It's like maybe like they're like, how is this problem solvable? You have to like they made that like leap, right? They're just like, okay, I'm gonna guess that you only care about adjacent pairs. It's not actually it doesn't matter.
Yeah.
Because you can do you can do a thing where you have like 2 points up here and then you just have a point here and the segment's right there, and like that point clearly doesn't affect anything, and then these 2 points can interfere with each other.
Yeah, no, I mean, I was just it's just interesting to me because like clearly they're a smart team, right? But it seems like before I went down the path, I just think for a minute like, okay, can I just disprove this right away and save myself 30 minutes of coding?
Yeah, maybe they were
not,
like,
I don't know.
Maybe they were just like, oh, maybe the data.
Yeah, maybe they don't trust the judges. That's a good reason.
If they don't trust us and they think that we wouldn't have hacked that test case, then like sure.
Yeah.
But I would hope our test data are strong enough to beat that. I actually did submit. I have a wrong answer in there where I only consider like. I do the same thing, but I consider like points in like a square root bucket range.
Okay.
And I'm pretty sure that also gets wrong answer. So like, like even if you only compare the points that are in a neighborhood, like it still breaks. So we do have like some coverage for that.
I gotta go to the bathroom here, Nick, but I'll let you solo it for some of the next 15 minutes.
All right, I will see. I haven't been monitoring chat, so let's see if anyone's been saying anything in chat. All right, looks like we have 14 minutes left. I'm gonna look at the open contest for Pac Northwest. It looks like in the open contest, we have Kevin Sun, who has solved 12 problems, and also with 12 problems is a CMU team. So we'll see if they're able to finish out the problem set. They have a little bit more time because the open contest started a little later than the real contest. Coming up on 10 minutes left in this contest, going to quickly look at the Division 2 scoreboard. It looks like in Division 2, we have Trinity Western. They had 9 problems solved before the freeze, and they have 2 pending runs on problem G. It looks like we have a bunch of teams that have made submissions to problem J in Division 2. All of which are pending. We'll see if any of these people were able to solve it. It looks like no one in Division 2 solved problem J before the freeze. Problem J was Candy Factory. I think in Division 1, Candy Factory actually it was problem C, if I remember correctly. And in Division 1, it has 20 solves before the freeze. And it looks like there are a lot of teams that have pending runs on it. It looks like Candy Factory was the 5th easiest problem, and will probably end up being the median sort of differentiator. So it looks like the median team will probably solve either 4 or 5, and problem C will likely be sort of the decider for those teams, whether they solve it or not. Looking back at the Division 2 scoreboard, we also see a lot of attempts on problem K. Problem K was item selection. Item selection was problem F in Division 1. And item selection was the 4th easiest problem in Division 1, with 31 solves before the freeze. Also with a bunch of teams, roughly 10 teams, that have pending runs. Welcome back.
Thank you, thank you.
All right, I think we're at 10 minutes left.
It's the final countdown.
I'm wondering if they're gonna be.
Sorry.
I'm hoping that there are no like last minute clarifications, and then the team's like, you didn't answer my clarification at the last minute and kept me from solving a problem. I do have.
That happened to me one time. That was really frustrating.
Ooh, UBC submitted to E.
To E?
Yeah, I am not looking at the verdicts, and I'm like intentionally not looking at the verdicts. Like I'm not even trying. Like I am able to maintain composure here purely because I'm not looking at the results, so I can't like. I actually have no idea if they got it right or not. So I like. Don't try to get information on me. I intentionally closed the.
I can see his screen. It's yellow on his screen too.
Yeah, like I also intentionally have that score. Like I closed all those tabs so I don't leak anything on stream. I want the results to be.
What happened to the camera?
What camera?
The background here. Did it die?
Did it die?
Could have died.
It's been 5 hours ish. It's been more than 5 hours, right? Are you gonna go check it out?
Well, I mean.
Do you think
yeah, maybe I should actually. Maybe I should make sure because we're gonna need it for the score reveal.
Maybe you should go check it out.
Goodbye.
Make sure nothing has gone awry. That would be a disappointment.
Let me take the other battery too. Where's that?
Yeah. I got a lead solution presentation, so I'm gonna pop out right at 4:10. Hopefully not a problem. All right, so UBC showing signs of life with an attempt on problem E. We'll see if they or the OnlyFans team were able to solve it. Problem E, as mentioned before, was eccentric excursion. It was a graph theory problem where you have a tree and you wanted to come up with a permutation of nodes, like the lexicographically smallest permutation of nodes, where exactly like n minus k minus 1 pairs of adjacent nodes in the permutation are connected by edges. And it turns out that you can do this with a fairly sophisticated greedy algorithm. It gives me vibes to an old problem from 2012 called red-blue spanning tree. And that in that context, there was a problem which said like, oh, you have some red edges and some blue edges. Is there a spanning tree with exactly k blue edges? And the way you solve that problem is you compute the minimum, like a minimum spanning tree and a maximum spanning tree using the number of blue edges. And if k happened to fall within that range, it was possible, and if k wasn't in that range, then it was obviously impossible. And you could show that it was always possible to get every intermediate value. And you do something similar here for problem E. So you compute the minimum possible and the maximum possible. And to do that in both directions is a little bit, you do different things for both of them. So the minimum is almost always 0. But if the minimum is not 0, you can show that the minimum is actually 1. And showing that the minimum, or determining whether the minimum is exactly 1 is, or I thought it was the trickiest part of the problem. You have to kind of, there's one obvious case where the tree is a star, And if the tree's a star, then obviously you have to use the like center node somewhere, and then it ends up being adjacent to something else. But you have other kind of complicated cases as well, where like you have a node, and then you have like you still have a star, and the star is like distinct from it, and stuff like that. So there's a bit of casework around there. So that's to compute the minimum number of edges that you need, and then to compute the maximum. There are a couple of different ways. You can do a DP, and I think that David and Constantine were talking about that. But you can also do a greedy, and the greedy involves you end up constructing like a matching on the tree, and you can do this matching greedily if you go from the leaves all the way up to the root, and you only greedily match like if it's ever like possible to do so. And so you incrementally build the permutation like node by node until you get the whole thing. But at the beginning, you can just check if it's possible or not. And then you just simulate the process all the way through. So yeah, that's how you do problem E. I wasn't sure if E or J was harder. I probably would have bet on J personally, just because problem J, as a geometry problem, can be really intimidating, and I think it's very easy to come up with an overcomplicated solution based on like the convex hull and so on, when there is a much simpler solution, and so it can be very easy to get trapped there. It's very easy to assume that the solution is more complicated than it needs to be. Going over, just looking at the remaining problems, it looks like the Berkeley team and Stanford Cardinal have both made submissions to problem E. So it seems that everyone is deciding this could be the last minute rush. So in the last like 5 to 10 minutes, people start to just write anything, and then they just pray that it'll work. They're going to start to include heuristics or whatever and hope that they can make their way through the test data. I think for this problem, because you have to construct a lexicographically minimal permutation, it's going to be very hard to sneak an incorrect solution by, but when there's a will, there's a way. Did you get your phone back?
It should be, can you see it there? Is there a good background?
No, I don't see any background.
All right, well, it should be working. One second, I'll fix it in a minute.
Okay, I need to, I need to start wrapping up, or need to
3 minutes, 50
hide my
seconds
over.
left. I can go.
All right, I'll chill here, and then I'll let you wrap it up at the end, and then I will head off to do my solution presentation.
Okay, all right. Let me fix the screen. Where is the solution presentation happening, by the way? Is it going to be...
The solution presentation will be happening in the main room. So back where, I don't know, were you out there during the briefing? So at the other end of the hall, the opposite the entrance, there's a set of computers all close together, and there's like a projector or like a screen on the other half. I think it's in the opposite direction from where your camera was pointing. So I'll be leading the solution presentation from there.
Oh, okay. All right, sounds good. Well,
Yeah.
no worries on that. Camera should be streaming. I will go check that out to see if we can get solutions.
Mm-hmm.
That'll be happening in a bit. Right now we're in the hurry up and wait phase. I guess for contest it's hurry up and solve contestants.
Yeah.
You're gonna give solutions to all the problems?
Yeah, I will briefly go over all the solutions. I was just informed that there was a typo, but I need to figure out what's going on here.
minute and 40 seconds left. We have lots of submissions flowing in, as you can expect.
Yeah, I'm also getting
2
clarifications.
clarification requests.
Yeah, I got 2 clarification requests, and they were both like, "Our code is wrong. Can you help us debug it?" And I'm like,
Sorry.
I wish I could, but there's 1 minute left, and I'm.
It'd take me a minute to get there.
Yeah.
We do have submits from. I guess we can show this, right? This isn't gonna leak in a minute.
It shouldn't. The scoreboard's gonna stay frozen.
We have submits from UBC on E. Lots of submits on E, I guess. Nobody on J.
E, and I. No submits on J.
Yeah.
So no team is doing the submit everything. A little bit less entertaining during the resolver.
Stanford could, in theory, potentially win if all 3 of these are right and UBC is wrong. So we'll see once the scoreboard gets resolved. Hopefully we'll have video for that.
Hopefully, if Stanford wins, I'll be surprised. I'll be honest. I think I would be very clutch if they somehow
I agree.
got free in the last hour, but
it's possible.
Definitely possible.
Other than that, it's UBC doing a victory lap. It's theirs to lose.
Or maybe they won. Maybe they already solved E. I'm glad I don't know. I'm going to be in suspense. I got told from our sysops team that as long as all the results judge properly. Oh, I hear the clapping. They're done.
And that's the contest. All right. Thank you all so much. We will be back and we'll have the scoreboard reveal coming up soon.
given the bounds. Like you can check all distinct paths, but you have to check in constant time whether the string is balanced. The way to do that is, imagine that you're actually doing just like a DFS through the tree and you're sort of assembling the string as you go. The moment that your string is inconsistent, you can short circuit and you don't search the rest of the tree. And you can show that this ends up being quadratic time. Problem J is Candy Factory. There's a lot of text, but it basically amounts to you have an array of n integers. In a single operation, you can pick k unique indices, decrease them all by 1. Your goal is to get the array to be entirely 0. What you can do at the beginning is you can increment some of the values by 1, and you want to minimize the number of times you have to do this in order to make it possible to get down to 0. There are a few different approaches. I think the simplest one to see is the binary search one personally, but we know that there are some closed form solutions. So if we stick with the binary search approach, we want to identify if it's possible to form exactly D bags. In this case, there are 2 conditions that are clearly necessary. So the sum of the values has to be at least b times k, or sorry, less than or equal to b times k. And then also, no factory produce more than b candies. If factory did produce more than that, then there would be leftover candies from the factory. We can show that this is sufficient. For the sake of brevity, I'm not going to go over why, but I think it's an interesting exercise to actually go through and prove why it's sufficient to just check these 2. Problem K is item selection. You're given a bunch of pages, and then there are some items that are selected on each of the pages. You're in some starting state, you want to get to some final stage. You can either toggle individual items on a page, or select them all, or deselect them all. And then you can navigate between pages. And you want to minimize the number of, I think it's like button presses you want to do. So in terms of moving between pages, you can show that you never change direction more than once. So you either you go to like the leftmost page that's wrong, and then you go to the rightmost page that's wrong, and in the middle you like fix them all, or you do the opposite. But you never like go left and then go right and then go left again. Like that doesn't make sense. And then when you're on a given page, there aren't very many things that are worth trying. Like you don't select and then deselect. You should only do at most one. And that's pretty much it. There's some case work, but those are the high level details. And I think the difficulty of this problem is just about sort of figuring out all of the different cases and handling them properly. Problem L is magic cube. You had a n by n by n cube. You had an operation where you could like rotate a bunch of layers of the cube, and then you wanted to figure out which cube was. The cube is really big, so you can't actually store the whole cube in memory. But in the grand scheme of things, like the dimension of the cube is small and the number of queries is small. So we can, instead of thinking about doing this like forward in time, we can think about doing it backward in time. So when you have a given point that you care about and you have a rotation, you can sort of reverse it and see where the query location was. And if you just track this in reverse order, then you can figure out where the query location ended up and then figure out which cube that was. Finally, problem M is sequence guessing. This was the interactive problem. You had to create this sequence of integers from 0 to 100,000. And then in between, or it had to be sorted, and then the difference between adjacent elements could only be 1 or 2. And also there was this adversary who was trying to guess your sequence, and you had to tell them as many times as possible, oh, actually, the integer you guessed isn't in my sequence. But when an integer was in your sequence, you had to tell them like, oh, it's my 10th integer or 20th or whatever. This problem we thought was, we originally had a harder version of it, which I won't spoil, but there is a proof that 1/3 is sort of the maximum fraction of misses that you can have. So what you can do is, because you see that the number of misses at most 1/3, you can kind of reverse engineer a sequence from that. So you're going to include every multiple of 3 and also 100,000. And then in the middle, you have these like pairs, like 1, 2, 4, 5, and so on. And so for each pair, you can always force the adversary to miss one number in the pair, and then you lock yourself into the other number. And then you can just sort of print the whole sequence. And that's it. So that's it for division 2. Were there any questions?
Maybe be ready with the resolver pretty soon.
Okay. In that case, I'm going to. So we're going to start with the resolver pretty soon, is what I heard. So I'm going to go ahead and breeze through the division 1 slides. I'm going to clean these up and release later for some definition of later. And so because there are shared problems, I'm going to skip the slides for all of the shared problems. Problem A was ABC string, problem B was acceptable seating arrangements, C was candy factory. Problem D was cramming for finals. You had a binary grid, which is mostly zeros, but there were some ones. And so you wanted to find a 0 that was adjacent to as few, or as close as possible to as few ones as possible within a distance of D. The grid was really big. R and C could be almost 1 billion, but N and D were small. So the answer is usually 0, except in small cases. So what we can do is we can do a line sweep. So for a given one, we can sort of draw the circle, and we can find all of the sort of points that are covered. When we do the line sweep, we sort of take this union of intervals, and then we want to find like the minimum value over like this union. And you can do this with a difference array. And then the only other observation you need is, if the answer is 0, you just print 0 and stop immediately. And this ends up running quickly enough. Problem E was eccentric excursion. You have a tree of n nodes. You want to find the lexicographically smallest permutation such that exactly n minus k minus 1 pairs of adjacent vertices were connected by edges. So the minimum number of edges you need to use is usually 0. The only case where the answer isn't 0 is when it's 1, and that's when the graph is a star. And so this problem reduces to finding the largest number of edges that you need. And so you can do that either griddily or with some sort of dp over the tree where you go like from the leaves up. I think the hardest part of this problem is doing the casework for checking if the forced number of edges is 1. But that's about it. F is item selection. Problem G with matrix fraud. You have another binary matrix. And you can toggle individual entries. You want to compute the minimum number of entries to toggle such that each row, each column, or each row has a 1, each column has a 1, and then within any row and any column, the ones are all contiguous. So this is also like the DP over the intervals. Naively, you maintain like for a given row, the left and the right endpoint for your intervals. So this DP naively is r times c to the 4th.
You can transpose the matrix, which reduces the factor by square root. And then finally, you need to see that the DP has this 2D prefix minimum property. And so you reduce the number of transitions down to a constant number. And so the number of states ends up being R times C times the min of those two, which is upper bounded by the square root of the grid size. H's on-call team, you had a team of engineers, each of which is familiar with some services. The team robustness level is the maximum value K such that no matter which K services go down, you can always handle those K services being out by assigning some engineer to each service. This problem is sort of just a Hall's theorem knowledge test, but you don't actually need flow for this problem. You just need a Hall's theorem. So for each subset of these services, we check how many engineers can be covered, and then you do a little bit of optimization to make sure that by Hall's theorem, when you're looking at the other side, if the union has size at least the cardinality of your subset, you stop the search immediately. Problem I is range editing. You have an array of integers, and in a single operation, you can take an entire subarray and set it to some integer. So you want to compute the minimum number of operations to get some configuration. The standard, there's like a standard interval DP where you pick the interval and you pick the color of the interval, and then you sort of compute like, given that this is the current state, how do I construct like the final state? And it turns out that you can optimize the color dimension out, and you just lock the color in, having it being implied by the leftmost entry in the interval. And so this DP ends up being 3 for loops and then one line with that optimization. J is segment drawing, labeled points and line segments. And you want to connect each point with a line segment. You want to minimize the sum of the lengths of pairings, where you pair each point to the segment by connecting them. And no two of these segments are allowed to intersect. So this problem can be solved with convex hull, but if you maintain a stack, you can just keep track of left and right endpoints that are possible, and then it's pretty obvious to see what ends up working. And with the resolver being ready, that's actually the end of this working presentation.
Yeah, and we're for the other sites too.
Oh, I need to run the over your sites. Oh, I'm gonna present this. Yeah, there's so I need
I don't think I would have I don't
So, we're ready to look at the results. My name's John Clevenger. I'm the ICPC technical director. And because Tom Paul doesn't want to do this, he cons me into going through the results.
It's too fast. I can't keep up.
So, we have two separate contests. One is, of course, Division 2, and then there's the Division 1, which determines who advances to the North American Championship. So first, we're going to resolve the last hour of the Division 2 contest. Oops. There we go. So, for those of you that haven't seen this before, this is the ICPC resolver. The scoreboard was frozen with 1 hour left to go in the contest. And during that last hour, as you can see on the screen, there were 211 submissions. So what we're going to do now is look first at the scoreboard as it stood at the freeze point, the entry to what we call the blind period. This is what it looked like with 1 hour to go in Division 2. And at that time, the top team had solved 9 problems. So now we'll go down to the bottom of the scoreboard, and we will work our way from the bottom up, looking at or resolving all of those 211 runs. Okay. So, to start with, we've got the modulars from Deanza with 2 pending runs. Those 2 pending runs, the first one was a yes, and so they move up. And now we've got the MML Moogles from UW-T. They got a no. We move on. The frameworkers from Deanza had no submissions. The embedders from Deanza had no submissions. The Simon Fraser Honeydew team had no submissions. The Code of the Rings team from UW-T had none. Hawaii Pacific team had none. The UW team gets a yes, and they move up. The modulars from Deanza also get a yes, and they move up. The Vultures from UW-Tacoma, they got to know they're done. The Lutes from Pacific Lutheran University had 3 submissions. The second one is yes, and so they move up. The Code GPT from Washington State, Washington State University gets a yes, and they move up. The D2 Adobo team from Brigham Young University in Hawaii had 2 submissions. They're both no's. The Small Talkers from Deanza get a yes, and they move up. The red team from Hawaii Pacific University is done. The Asians team from UW move up. The Lutz team from BLU gets a yes, they move up. The Tigers from the University of the Pacific had one submission, it was a no, so they're finished. The Bike Coders from De Anza, they got a yes, and they move up. The Code GPT from Washington State University has no more runs, so they're finished. The Optimizers from De Anza get a yes, and they move up. Small Talkers from De Anza have two submissions. The first one's a yes, and they move up. The team Cyan from HSU move up, they get a yes. The half Asian team from UW Tacoma is finished. The Lutz team from TLU, Lutz 5 from TLU is finished. Team Yellow from HSU is done. The Bike Coders from De Anza are finished. The Transcompilers from De Anza have no more runs. They're finished. Control Alt Defeat from gets a yes, and they move up. The Small Talkers from De Anza get a yes, and they move up. The Optimizers also from De Anza, they get a yes. Another De Anza team moves up. Team Cyan from HSU, Humboldt State University is done. The Callbackers from De Anza are finished. The Abstractors are also finished. The Lutz 1 team from Pacific Lutheran is done. The Live Wires from Trinity Western finished. Lutz 3 from PLU have one run. It's a no. They're done. The Small Talkers are finished. The Optimizers are finished. Control Alt Defeat from Humboldt State is done. The Wildcat 4 team from Cal State Chico is finished. The Colonel Sanders team from University of Hawaii is finished. And a BYU Hawaii team moves up. The Monterey Bay team Sea Serpents get a yes, they move up. The Pseudocoders from De Anza have no more runs, they're finished. Below Average team from UW, they got a yes, and they move up. The Odd Bits from De Anza, they got a yes, and they move up. The White team from Hawaii Pacific University is finished. The Huskies Chosen team has one run, it's a no, they're finished. The Lab Rats from Western Washington get a yes, they move up. The Radar team from Sierra College up in the Sacramento area is finished. The Bread First Search team from Humboldt State is finished. The Lutz 4 team gets a yes, and they move up. The Santa Clara University team has 4 problems with pending runs. The first one's no, the second one's no, the third one's no, the fourth one's no. The Makahara Drill team from BYU Hawaii is has no more runs, but we stop here because the Makahara Drill team from BYU Hawaii is the 3rd place team at the BYU Hawaii site, the bronze medalist in Hawaii. All right, so we're moving up here. The below average team from UW Tacoma, they have one run, and it's a yes, they move up into 23rd place. Monterey Bay Sea Serpents have no more runs. They're finished. The Odd Bits from De Anza are done. The purple team from Humboldt State is finished. The Lab Rats from Western Washington get a yes, and they move up. The Dam Coat team from Oregon State has 2 problems. First one's a no. The second one's a yes. They move up. The Lutz 4 team from Pacific Lutheran has a no, and so they're finished. The SPU Coders, they get a yes, and they move up. The Mind Mappers from De Anza get a no on their first run. The second one's also no. They're finished. Another Hawaii Pacific team has a run, and it's a no, but we pause again here because that team from HBU is the silver medalist. We got the irresistible Insomniacs from Trinity Western with 2 different problem runs. The first one's a no. The second one is also a no, so they're finished. The Bricks team from UFB, they get a yes, and they move up. Group 7 from Western Washington, they get a no, they're finished. The Whiteboarders from De Anza have no more runs, they're done. Pseudo Wrestlers from Trinity Western, nope, they're finished. The Bike Buddies from UW Tacoma get a yes, and they move up. So the Monterey Bay Sea Urchins, they get a yes, and they move up. Going down now, the ICPC World Finalists, the Optimus but they're done, they're finished. The Water Bubbles from Santa Cruz get a yes, they move up. The below average team from UW Tacoma is done. The Lab Rats from Western Washington have 2 runs, they're both no's, they're finished. The Farreloots from Pacific Lutheran is done. The Dam Coat team from Oregon State University, no more runs, but they are the bronze medalists for the Oregon. SFU coders here, but they have no more runs, so they are finished. The UBC 02 team from UBC, yes, they move up. The UFV team is finished. The Oracles from George Fox have 3 problems. The first one's a yes. They move up. The randomizers from Zianza get a no, so they're finished. The Bike Buddies from UW Tacoma, 3 problems. The first one's a no, the second one's a no, the third one's a no, so they're finished. Monterey Bay Sea Urchins, they get a no. They're done. The Lexicals from Dianza get a no. They're done. The Water Bubbles from Santa Cruz are finished. The Access Code team from Santa Cruz gets a no, and so they're done. The Simon Fraser Maroon team, no more submissions, but they were the first to solve problem F in D2. So the GPT-5 team from BYU Hawaii has 2 problems, and they're both no's. But we pause here because they are the Hawaii gold medalists. All right, the Control-Alt-Defeat team from Oregon State has pending runs on 2 different problems. The first one, that one's a no. The second one, that's a no also. So they're finished, but they are the silver medalists at the gold at the Oregon site. So let's see. We're now in the top 15 in Division 2. We've got the One Punch AC from Trinity Western University. They have pending runs on 2 problems. First one's a no. The second one is a yes, and they move up into 7th place. The Berserkers from Santa Cruz, their first problem is a no, and the second one's a no, so they're finished. The Array of Sunshine from Western Washington gets a yes, and they move up. The OBC 02 team gets a no, they're finished. The Oracles from George Fox have 2 problems. The first one's a no, the second one is a no, but we pause here because the Oracles team are the gold medalists at the Oracles site. And so we're in the top 12. The How to Code team from UC Santa Cruz, they get a no. They're finished. The SFU Burgundy team is done. The UBC 2D2 team from the University of British Columbia has 1 pending run. They have pending runs on problem K. So let's take a look at that. And that one's a no, so they're done. They finished in 10th place. The Santa Clara University team, currently in 9th place, has a pending run on problem J. And take a look at that. That one's a no, so they finished in 9th place. Moving up, but I should point out, they finished in 9th place, but they are the bronze medalists. So we've got the One Punch AC team from Trinity Western. They have no more pending runs, but that means that they are the bronze medalists at the British Columbia site. Okay, we've got the Scrappers from Dianza, our local host here, and they've got pending runs on 1 problem. We'll take a look at that. And that's a no. So that means that the Scrappers from Dianza are the silver medalists at Scrapers. I apologize. It does say Scrapers. No. I don't know. Are they what? Are they here? They're here, right?
Right here.
Okay. Congratulations. Whatever your team is. Okay, we currently have the Get Push Gatekeep Girl Boss team from Western Washington University. They have pending runs on 2 problems. We'll take a look at the first one, and that one's a no. Take a look at the second one, and that one's a yes. They move up into 3rd place. Whoa! All right. So going back down here, currently in 6th place now are the Dream Demons from Sierra College. They have pending runs on 3 different problems. The first one is a no. The second one is a no. And the third one, that's a yes. The College is a 2 We've got the UBC 1 D2 team from the University of British Columbia. They have pending runs on 2 problems. The first one, that one's a no. The second one, that one's a no also, and that means that the UBC 1 team finishes as the silver medalist at the British Columbia site. Congratulations. So we're in the top 5 now, and currently in 5th place with no more runs. We've got a ray of sunshine from Western Washington University, and that means that they are the Washington Site bronze medalists. Top 4 teams here, and the Get Push Gatekeep Girl Boss team from Western Washington University has no more pending runs, and that means that they are the Washington Site silver medalists. Top 3, the Coding Cowboys from Western Washington University. They have pending runs on problem J, this here. That's a no, and that means that the Coding Cowboys are the Washington Site gold medalists and the D2 overall bronze medalists. Congratulations. And if you figured out how the scoreboard works by now, you can see that what happens is that the Dream Demon teams from Sierra College currently are the California gold medalists in D2 and silver medalists overall in D2. And the winner of the D2 division is the Out of Memory Exception team from Trinity Western University, and they have still pending runs, and one of them was a yes. And so they move up, they solve 10 problems. The second one, unfortunately, that's a no, but it still means that they are the D2 champions and the gold medalists for Division 2 in the Pacific Northwest contest. Okay, so having done the Division 2, now what we want to do is look at, oops, nope, that's not right. Here, we want to look at the, right. I'm afraid to touch anything. Okay, all right, here we go. Again, this is the way the scoreboard in Division 1 looked at the end of 4 hours in the contest. And during that last hour of the contest, there were 294 submissions. So this is what the scoreboard looked like at the start of the blind period, with one team currently having solved 11 problems, 2 teams solving 9, 8, and then a bunch of 7s and 6s. So we'll go down to the bottom of the scoreboard, and we will work our way up and see who is the Pacific Northwest Division 1 champion. Currently, at the bottom, the super long downtime team from University of Washington, we actually believe they weren't there. They didn't submit anything.
They had a lot of downtime.
They had a lot of downtime. Okay, and so moving ahead, the pointers from Washington State University get a no. The EIS 1 team from BYU gets a no. The UWT dogs are done. The for them from the Washington State University is finished. The Wildcat 5 team from Chico, they get a yes and they move up. The Not My Fault team from the University of Puget Sound, I think I should say, they're finished. The Agilis from De Anza are done. The green team from Hawaii Pacific University gets a no, they're finished. The Team Red from Humboldt State gets 2 no's. They're finished. The Fortran Knights from University of Hawaii Hilo gets a no. But we pause here because they are the Hawaii site bronze medalists. All right, so we've got the Sigfalters from Pacific University. They're finished. The Fighting Beavers from OSU, they move up. They get a yes. Sun Color from Hawaii Pacific University, they get 2 no's. They're done, but they finish as the silver medalist at the Hawaii site. I'll go look up and see what that color is. I don't know exactly what that color is. So we've got the data team from Pacific University. The first run is a no. Their second one is also a no. They're finished. The drop table contestants team from Pacific U gets a no, a second no. They've got a third no. They've got another fourth no, and they've got a fifth no. They've got a sixth no. So they're finished. The Jambroli team from Washington State University gets a yes, and they move up. The Wildcats 5 team from Chico State is done. Wildcat 2 has 3 different pending runs. The first one's a no, the second one's a no, and the third one's a no. They're finished. The Fighting Beavers have no more. They're done. The Null Hypothesis team from UW Tacoma has 2, and they're both no's, so they're finished. Jambroli from Washington State gets a no, but they are the Oregon site bronze medalist team. Oh, okay, I got it.
Yep.
So, okay. They're Washington State, but they're competing at the Oregon site. Congratulations, guys. The Wildcat 3 team from Chico State has a no and a second no. They're finished. The blue team from Hawaii Pacific University has no more runs, but they are the Hawaii site gold medalists. The traveling solicitors from San Jose State University right down the road, they have 2 pending problems. The first one's a yes, and they move up. The Wildcat 1 team from Chico State gets a no, they're finished. The UVic D1.2 team gets a yes, and they move up. The Topological Turtles from San Jose State, they get a no, they're finished. The Bit Brawlers from Western Washington, their first one's a no, their second one's also a no, so they're finished. The UVic D1.1 team gets a no, they're done. The Simon Fraser Viridian team is finished. The Monterey Bay Sea Otters get a no on their first one and a no on their second one, they're finished. The UVic D1.2 team has no more pending runs, but they were first to solve problem M in D1. The Slavs from UW Tacoma have pending runs on 4 problems. The first one's a no. The second one's a no. The third one is a no. The fourth one is no. So they're finished. Traveling solicitors from San Jose State, they're finished. The UBC 01 team is done. The POG team from UC Davis is finished. A bit shifty from University of Washington, 2 pending problems. Both of them are no, they're finished. The Goons from UBC, 2 pending problems, they're both no, so they're finished. The Bo Nix Rose Pigs team from Oregon State gets a yes, they move up. The Stanford Escondido team gets a yes, and they move up. The Segfolties from Santa Cruz, 3 pending problems. The first one's a no, the second one's a no, the third one's a yes, and they move up. So the Millennium Science team from the University of Washington also gets a yes, and they move up. The Paintbots from De Anza have 2 problems, and the first one's a yes, they move up. The Beaver Bites from Oregon State University get a no, and so they are finished, but they are the Oregon site silver medalists. So the Bo Nix Rose Pigs team from Oregon State has 1 problem left. It was a no, but they finish as the Oregon site gold medalists. You might notice that there's no picture here. That's because they're one of the teams that didn't deliver a picture as was requested. So if you're here next year and you want your picture, please contribute a picture. Let's go. Works on my machine from SFBU. Yeah, we heard today. But that was a no, so they're finished. The big bots from De Anza are done. The Segfolties from Santa Cruz are finished. The Stanford Escondido team has a no, they're done. The AMG team from University of Washington is finished. The Millennium Science team, also from UW, has a no, but they are the bronze medalists at the Washington site. Okay, the red team from San Jose State University, they get a yes, and so they move up. The Stanford Trees team, they get a yes, and they move up into 16th place. The Berkeley Gold team has 2 runs. The first one's a no. The second one is also a no. We move on. The Los Pollos Hermanos team from UC Davis is finished. The Bulldogs from UW get a yes, and they move up. The Escape Great team from UBC has a no on the first problem, but a yes on the second problem, so they move up. The Cash Cow Heresy team from UC Davis gets a yes. They still have 2 pending runs to go. The Red team from San Jose State has no more. They're finished. The Stanford Trees team is done. The Bulldogs from UW get a no, but they are the Washington site silver medalists. So the Escape Gray team from the University of British Columbia, they have no more pending runs. They're finished. The Golden State Bears from Berkeley, they get a no on their first one, a no on their second one. On their third one, they get a yes, and so they move up in place. The KKSK team from the UW, from the University of Washington also gets a yes. They move up. The Cash Cow Heresy team from Davis gets a no, but their second one is a yes. They move up into the top 10. The Giraffe Falls Near the Tree, nice name. UC Davis gets a no on both of them, so they're done. The Conqueror of Packing W team gets a yes. They move up. The Stanford Red team has 2 problems. The first one's a yes, and they move up. The Simon Fraser Lavender team has 2 runs. The first one is no, and so they are done, and they are the British Columbia site bronze medalists. So, currently the Berkeley Ballers team has 1 pending run. It's a no, so they finished in 14th. They were the first to solve problem A in the division. The Golden State Bears team from Berkeley, they get a no. They're finished. The Cash Cow Heresy team from UC Davis is done, finishing in 12th place. The RSK team from UBC gets a yes. They move up. The KKSK team from Washington also gets a yes. They move up. The Conqueror of Back NW team gets a no. They're finished. The Stanford Red team has 1. Let's see, we're in the top 10 now. So we're vying for the positions to go to the North America Championship. The Stanford Red team has pending submissions on 1 problem, and that's a no. So they finish in 10th place. The Stanford Quad team has pending runs on 1 problem, and that's a no. So they finish in 9th place. The Broken Heart team from University of California at Santa Cruz has pending runs on problem G. That's a no, so they finished in 8th place. The Carl Jim Greenbrook team from UC Berkeley has pending runs on 3 different problems. So let's take a look at problem D. That's a no. Well, what about problem H? That's a no. Well, what about problem I? That was also a no, so they finished in 7th place. The RSK team from the University of British Columbia has no more pending runs, which means that the RSK UBC team is the British Columbia site silver medalist. And then there were 5. But if you know how to read a scoreboard, you already know the KKSK team has no more pending runs, And what that means is they are the Washington Site Gold Medal. And I should point out that the top 5 advanced to the North America Championship. So the KKSK team is the first team to advance to the North America Championship, which will be in Orlando, Florida. So we have the top 4 left up here. The return of the Sleepwalker team from UC Berkeley. Now we're vying for bragging rights. This team is currently in 4th place, has pending runs on 2 different problems. The first one's a yes, they move up into 2nd place. All right, we got the OnlyFans team from UC Berkeley. Let's not even go there, folks. They've got pending runs on 2 problems. The first one, no, that's a no. The second one, that's a yes, and they move up and take over 2nd place. So the Stanford Cardinal team has pending runs on 3 problems. First one, that's a yes, and they move up into 2nd place. Back down here, and so now we've got the return of the Sleepwalkers, currently in 4th place, and they have pending runs on 1 problem. That's a no, and so that means that the return of the Sleepwalker teams from the University of California at Berkeley are the California Site bronze medalists. And so now we have 3, and that means, you can read it, it's pretty obvious. The OnlyFans team from UC Berkeley is the California silver medalist and the overall Division I Pac Northwest contest bronze medalist. Congratulations. I'll talk to you later about your team name. 2nd place right now. What do we got here? The Stanford Cardinal has pending runs on 2 problems. The first one, that one's a no. All right, what do we got here? The second one, that's a yes. But notice they didn't move. They got 1 more problem, but their points were too many. So that means that the Stanford Cardinal team ends up being the California State gold medalist and overall silver medalist. And that leaves us with 1. The UBC team from the University of British Columbia, but they've got 1 pending run. Let's see, did they beat the judges or not? Wow. No, they didn't, but they are still the 1st place D1 champions and gold medalists.
So you see why I don't want to read those things. That is just way too fast. Tell you can just push the button. So, anyways, a great day. What I can say in terms of advancement to the North America Championship, for those of you that are D1, the last couple of years we were able to advance 5 different schools, and that's an important thing to note is that it's the top finishers from each school. Even if a school might have finished higher than another school, it's about schools. So, and so we'll see what we can do. I will always lobby for more than 5. And so I'll do my best as far as that goes. The other thing I want to bring up is that for all of you that are medal winners, well, I have some email addresses. I'll reach out to you and I will mail you medals and plaques. Depending on where you finished, if you finished in 1st place, you'll get plaques as well. So look for those, coaches. In the coming, it'll be a week or so before I can get to that stuff. But there's that part. Another thing I wanted to bring up, really important. I had an oversight this morning with regards to the different sites. We had 2 microsites, so not able to compete in person for different reasons, and so Cal Poly Humboldt, I wanted to give a shout out to them. This is her second time competing as a microsite. It's a lot of work to run those things. We appreciate you guys and your participation. And then also University of Victoria did the same thing. So to all site directors, thank you so much for your effort. We already did thanks for the judges, the problem writers, the volunteers, all you contestants here. You should give your coaches a big hand right now because they put in a lot of work. And so, okay. All right. And so, yeah, just about done. And so the other thing is we'll post the final results on the PAC Northwest site in the next couple of days. Our head judge, Nick Wu, will have a write-up that discusses each of the problems. And as per usual, we will post the judges' test data along with official solutions, so you can look at that. We want this to be educational. And so that'll come in the next few days. Time permitting for me, sooner than later, we'll see. And so that's just about it. In conclusion, Deonza and Manish Well and Mary and crew, you guys knocked it out of the park. This was your first time doing this. Amazing facility. You put in so much work and effort. You made do with what you had. Beautiful lab, beautiful facility. I really want to go out and thank you as far as that goes. Okay. 2023. Remember, we had to push it back. The 2023 Pacific Northwest Regional is now complete. Thank you for participating. We'll see you in November.